We are live. And then there we go. Okay. I have YouTube and Twitch should be working for chat. Everything's good to go. I think today's my last day of restream. Yeah, today would be my last one. Just gonna do the bad thing. Here we go. Just get it done with. Okay, because I haven't set it up yet. I'm going to set it up. But I haven't found all the tools yet. Okay. How's everybody's day going today?
Drilling the default ones.
So good to go. Let's add this. We're just gonna do 3 minutes of ad breaks real quick here since no, never mind. Never mind. All right, let's get this started. Let's get this party started. Do I not have it open? I thought I did. All right, so we're gonna start doing the port from UE6 to Unity 6 to 2022. Tomorrow is going to be a bit of a potentially late stream, maybe, because I'll have a bunch of stuff to get done. I'll have extra stuff to do in the morning. There we go. I forgot to open a bunch of this stuff. So this is the new project. Excuse me. And this is the old project. All right. So we're going to not do UE6. Anyways, so we hit play. This is where we're at yesterday. Hit play, and we drop. I don't know why this doesn't go to stop. Because I think this one goes to stop, right? This is a quality of life change that I wish Unity 2022 had. I miss it from Unity 6 already. Okay. Now I think I can get away with this. My assets. There's that grid one, right? The grid prototype material. We're going to import that. Template scenes. We don't need the template scenes. So we can just get rid of those. And we don't need the demo scenes. Actually, do we need the template scenes? I don't think we need the template scenes, right? Yeah, we don't need the template scenes. Import. Then we need to make sure that we import the characters. Volleyball. Import. We could leave the Unity demo, the Unity file here. I don't think that should hurt anything. The nice thing about this is that we don't need to worry about there we go. Now when I bring her in, it shouldn't be, it should just be good to go, right? I shouldn't have to do any extras for her, right? What's up, Jack? I don't think this works. Does it? No, it doesn't. Damn. What's Mr. Jack up to? You having a good day? My mic is working, right? Yeah, okay. Hopefully I don't have any mic issues today. Like I did yesterday. Yeah, it's having been have been doing some rest. Maybe a tad loud. Really? Loud. That's a first. Hmm. Well, fix it in a sec. I don't think anybody's ever called me loud before. It's crazy because like I am currently below, I'm in the green. I'm not even in orange on OBS. And like people are like, oh, you should probably be like middle of orange. Is it still a tad loud, or maybe it was just that moment? It's like 50-50. Interesting. Should I turn it down? I didn't do that. I just want to finish doing this before I do that. Because it will break my flow. It's like more loud. I am so confused. I wonder if it's because I don't have any like backing music or something like that. Because I know that's like a big part of things, getting used to. So what do you, exactly what is this? Okay, so the prefab is just like a pre-existing one. Okay. It looks so blah. I don't know. Okay, no worries. I need to figure out how to get this into. I think this isn't set to UP Universal Rendering Pipeline. Unity 2022. I'm installing. So that's what I did wrong. Wait.
Tutorial projects, and I will name this. Hello, in this video, I'm going to be showing you how to set up, install, and configure Universal Render Pipeline for Unity. First thing I'm going to do is have my Unity Hub open and go to New Project. I'm going to choose the 2022.3.28 F1 version of Unity, and I am just going to use the default 3D built-in render pipeline option. If you don't want to go through the hassle of installing URP, you could just install.
So this is the mistake that I did. I installed URP. I mean, I did it this way instead of installing URP.
All this Universal 3D template, and then just create a project starting from there, and then you'll have URP already installed and configured. But if you don't want to do that, you could go to the 3D built-in render pipeline option. I am going to change my folder destination to tutorial projects, and I will name the
dots. The mass entity system in Unreal is still too experimental, and it's starting to cause problems. So I'm switching to dots. It's unfortunate.
This URP setup tutorial, and I will create the project. All right, now that we have our project open, we will need to go to the package manager. For me, that's right here, but for you, you might have to go to Window and Package Manager here, and then this should open. To get the Universal Render Pipeline installed, you'll want to go here to the Packages dropdown and go to Unity Registry and scroll down to the U section for Universal RP, and then you'll just want to hit this install button.
I don't know if I installed this. Oh, I do have it installed. Okay, sweet. I installed it. Wait, where was my tutorial?
One and well.
That's not the right tutorial.
The components.
That's not the right tutorial.
Button right here, and it should install the Universal Render Pipeline. And then after this installs, we have a little bit more setup to do, so stick around. All right, now that the Universal RP package is installed, we can see we have a URP settings file here. So to
do I have that? Oh, I do.
Set up the universal render pipeline for your game, you're going to want to right click, go to create, go to rendering, and depending on if you're going to be using it for 2D or 3D, you'll want to use the URP asset with 2D renderer for 2D games and URP asset with universal renderer for the 3D games option. I'll do the 3D games option, and
Let's create. I guess I can just do it here, right? He said, wait, what was it? It was create, right? Yeah, create and then rendering. What was I creating again? URP, render.
the URP asset with 2D renderer for 2D games and URP asset with universal renderer for the 3D games option. I'll do the 3D games option, and you'll see it made a couple new files here. So for these files to take effect, you'll want to go to your project settings and select graphics. And if you don't have this tab here for project settings, like if I close this tab, for example, and I want to get it back, you'll want to go to edit and project settings, and that should
Okay, edit. Project settings. Graphics.
appear somewhere on your screen. If you have multiple monitors, it might appear on a different monitor. That's what mine did, so I dragged it over here. Then you want to click graphics, and you could just click here, and the only one listed should be the one asset that you created, so you'll be able to select that. And then if you have a lot of stuff in your game already, it might take a long time for this to switch over, but
So we click this and we do that. Continue. There we go. So I'm technically not entirely like I'm not hard set on whether or not it's going to be Unity or Unreal at this point. I figured I have a general idea of like how much work it's going to be to get this done in Unreal, and I'm going to have to essentially build everything, like literally everything, because the mass entity AI system in Unreal is completely broken. Like it doesn't function properly. The collision detection for avoidance doesn't work with other objects and stuff like that, and it's turning into a bit of a clusterfuck. So I'm definitely gonna have to do away with that to get that working, and it's gonna be a lot of like slopping through actual like um it's going to be a lot of slopping through what was this again? This was sorry. There's going to be a lot of slopping through code to get everything to work properly, or even like get started on working properly in Unreal. So I'm just like, that might be the way to go. I think I've kind of looked at that in the past. Is this the one where they shimmed it into Unreal? Because there was I think there was one of these. It was either this one or one of or Flex, where somebody shimmed it into Unreal and made a plugin for it. Yeah, here we go. So like I could do it. It's not impossible, right? Is the thing. But it's a pain in the ass. And it's something that I don't really want to deal with because like so a lot of this with this being my first adventure into like a building out a game that like properly building out a full game that has like AI and moving parts and stuff like that. I don't know if I want to go down the route of like everything needs to be entirely hand rolled from the get-go and there's no tutorials. And going with something like ENTT or even the mass entity system, there's like almost no tutorials to like get the ball rolling, right? I just don't know if I want to try and deal with both of them at the same time. Is the 2D physics engine in Unreal really bad? I've heard of people like replacing the physics engine. Yeah. Okay, so there is a way to do this like convert thing, and I can't remember what it was. There it was. I don't know. I just wanted a lighter version. That's fair. Are you on UE5 or 4? Five point 5.1. Nice. I had problems with 5.5.1. I think I also looked at this at one point. Again, though, like the biggest issue with these isn't so much that they wouldn't work. It's that they're not. If I run into a problem, I'm on my own, right? There's not like there's not a wealth of knowledge around it that I can like go reach out to somebody. Also, this is 5 years old. Oh, this is also 5 years old. Although then I'd be able to. Oh wow. Okay, so the last supported version the last official supported version was 4.25. So I'd have to do some level of uplifting. I think if I was to do it, I would go with this one. And then as of writing, I think I'd go with 4.27 as the engine of choice. If I wasn't going to be using mass. Ah, okay. Yeah. I think if dots doesn't work or I get too frustrated with Unity, I'll probably use it. Yeah, Flex. Flex is the other one. It's ENTT and Flex are the two biggest open source ones. One of them is used by Mojang. I want to say that it's Flex, but it's not. It's ENTT. Yeah. Ported the entire simulation to Flex instead of. Yeah. I'll come back, right? Like I'm like I said, I'm not opposed to going with it. Looked into the third party directory and it seems that, yeah. I've kind of looked at these, but like somewhat decided against it just for Oh, this is interesting. How much is this, I wonder? Oh, $100. One-time purchase. That's kind of cool. Studio license isn't too bad either. The only thing here is that I think this is only for like Blender and Maya and stuff like that. Yeah, that kind of sucks. But this is cool. Anyway, sorry. Did we get any errors? Got lots of errors. I wonder if I delete them and bring them back in if they'll fix it. Okay, we're gonna re-import these. Project manager. In my project. No. Yes. Can I just do, oh, I can't. Okay, so what we do is we do this and then we delete them. Because if we bring them in with it, it might fix the, it might bring in the right versions of them. Let's see if it works. Because there's supposed to be a universal render. There's supposed to be universal rendering compatible. Wow. This is annoying. Mm. I think I like the dark gray better. I almost want to just... I don't know how to fix this current scene right now. I did get sidetracked a lot. That's fine. Sidetracked is fine. What's up, Don? Is this it? Yeah, this is it.
but since we have an empty project, this should be pretty fast. There we go. So now it is set up with the new universal render pipeline asset. If I go back to the inspector tab, we can now just look at these files that we have. If you have something that needs the depth texture, for example, if you're doing like a water shader and you want to have like foam around certain islands, you might need to turn that on. If you're doing a water shader, you might also need like the opaque texture. The opaque texture, what it does according to Google is it provides a snapshot of the scene right before URP renders any transparent meshes. So what that means is you can use the opaque texture with transparent shaders to create like frosted glass or water refraction effects. So you might need to turn these on. If you're not doing any of those effects, you can just turn them off. HDR, that's going to be high dynamic range. Anti-aliasing, that's going to smooth out your image, so you can choose what scale you want there. Render scale, that's going to be like resolution to which your game is going to be rendered at. Upscaling filters, lighting, you can do per pixel or just disabled for the main light, I guess. You can control your shadows. You can control how many additional lights you want. I usually just always max this out, but that's up to you. You can choose if they cast shadows or not. A lot of this stuff is pretty self-explanatory, and I don't need to go into all that in this video. For the asset renderer here, some of these you might be able to use like render features to do like screen space shadows, screen space ambient occlusion. You can do a full screen render pass. I have a video on that. These two files are extremely helpful in getting the game to look how you want. But that is really all I wanted to cover in this video. Some people in my previous videos seem to have issues just getting this part done, where you create your own pipeline asset and assign it in the graphics tab. But
I figured it would have fixed the look, but it doesn't seem to. And then these are completely broken. I don't know why they're broken, but they're broken. We still get weird errors, but at least like I think we're fine. we're not getting weird errors with like the fuck my head's I'm not all there right now. Actually, let's start this project over with with the proper thing. Okay, so we're gonna call it that again. But if I come out to not this folder, sorry, local projects, Unity, we're just gonna delete this one. Cancel. We'll do that. We'll take this one and we'll delete it. There we go. And then new project. And it's this one that we wanted, right? No. Wait, this is the wrong one. We want this one. And this one is the one that we want. The universal blank template. Okay, this is what we want. Download template. And then this is Unity Raccoon. Create project. And this will give us the the Truckcoon project we want. The Truckcoon project we deserve. And then we just have to go enable a bunch of plugins. I could have swore that girl said that she was you are universal pipeline enabled. Unity asset store. Like she was actually flagged as enabled. How do I go to my assets? Oh, there we go. So if I come down to her, it's these ones here. To be completely fair though, I did not use her in, like, I didn't pay for her. View full details. There we go. But she's labeled as URP compatible, but she doesn't appear to be. Either that or I had URP set up incorrectly, which is also possible. Oops. Oh, that's not right. That's not what I was wanting. What's this? That's like a global volume. We wanted a 3D object to cube. There, and then we want this to be 0, 0, 0. 100, 100. There we go. The Unity registry, we want entity. We're going to start with that one. Do, 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 do. Eventually, this will finish loading. There we go. And then we need Unity physics. Then we need I want the grid. Grid. There it is. There we go. And then I guess maybe we try a different character, because she doesn't work. Although we could still try her. What's up, Fox? Wait, what's the difference? Oh, more. That's what it is. More. I don't trust this character. We could try this one. This one here is available, and I think is URP compatible, or it's labeled as URP compatible with 2021. Additional compatibility information. The material in this pack uses Oh, what's this? Oh. Unity has a toon shader? The Unity toon shader is compatible with all the rendering pipelines, the built-in rendering pipeline, the universal pipeline, and the high definition pipeline. Though there are some differences in features. Interesting. Do I have that enabled? Is that a problem? That's the Japanese docs. That's interesting. Okay, so I can still fix that one, but let's see if we can find one that's not just out of the box broken. Just give me a moment. Unity Chan, is she not being maintained anymore? Is, I guess, the number one question. Hmm. Ooh. We've released. Use the create content that could be. Okay. Okay, now the question is, where do data download? Hmm. Hmm. Is Unity Chan actually from Unity? Why does she have a different page then? Whatever. She's not labeled as compatible. humanoids. Can I select the rendering engine? Where's the price? Free. Free as in I don't want to pay for shit right now. Can't remember if she was. Okay, she's supposed to be compatible with, I think, my exact version. Do installs. Yeah. Okay, so she's supposed to be compatible. She has a walk animation. We can come back to her. Add to my assets. Accept, sure. Really all I want is a character that I can have walk around. And I don't want to have to fiddle with her too much because she's temporary. Mannequin woman. Ah, okay. Mm-hmm. Doesn't say that she's compatible with 24. It doesn't mean that she's not. It just means that it's not stated. Ugh. This is why I can't have nice things. No. This looked like there was another guy that does stuff and his backgrounds look like that. I don't think he has any free assets though. Interesting. Okay, so was she might be compatible, but she would require the tune shader directly from whatchamacallit. Upgrade tool if the asset is materials of this asset must be upgraded with Unity's automatic material upgrade tool if the asset is used in Universal. Ah, okay. And this one just straight up uses the tune shader. I want to avoid that altogether. So where's the volleyball people? The volleyball people I think stated that they were, but I wonder if they've got that disclaimer. Where's the disclaimer? Where are the volleyball people? There they are. it does not have the disclaimer. So I think maybe it might just work if I just import it now. All right, let's import. Okay, so these are all still broken. Of course they're broken, because why wouldn't they be? Let's see. We'll save this and we'll come back to it. But I'm kind of curious as to like what their thing looks like. Demo sky. Materials are still broken. God damn it. But wait, what if I do this? Rendering pipeline converter. We do this and initialize and convert. Uh, okay, so it's still super broken. Fuck. Okay, that's one. We're gonna fix that, and then we're gonna do universal pipeline, and then we're gonna do unlit, and then we need to take this and pop that in there. Oh, wait. Opaque, transparent. There we go. Then if we go here, we can jump to 3. I'm gonna fix it. Do what? The blue in the eyes. What? Transparent. Fix. This is more than a little bit annoying. Sex. Do, 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 do. Fix object. When was this again? 7. Universal rendering pipeline. Unlit. 7. Transparent. That's 9. Universal rendering. Unlit. Transparent. Twelve. $16. Go. Clothing. 13. 13. Where did it go? There it is. I'm just assuming that it needs transparency on every single one of these, but I actually don't know. Oh, I think I'm good. There we go. Some of these do not need to be transparent. This one I think is opaque. Yeah, okay. This one opaque. This one here, let's do opaque. This one I feel like should be transparent. This one here I think should be opaque. Yeah, okay, there we go. Do 15. Do 14. 14. 14. There we go. Her neck is fucked up. So this is going to be one of the heads. There we go. So I think it's this one, and this one. Although this one, let's try opaque. What happens? Ah, it's supposed to be opaque too. It gives her volume. Okay. Okay, so it's just these two that need transparency, and I think the rest of them are opaque. Oh, the eyes too. Yeah. Okay. To do universal unlit. It's 10. Three. Universal unlit. Actually, maybe these need to be opaque. We're gonna leave them transparent for now. The blues in the eye, we're gonna do that. These need transparency. Okay. this one here. Okay. Skin 4. I wish that it would just convert with the right things. Wait, was it 7? I think it was 7. Yeah, there we go. Yeah, I was right. Now this one's 9. Ugh, I wish that they had better naming. Oh well. One. Hair. 14. Wait, which one? Which one's this? 18. 18. White hair actually kind of looks nice. Do 15. $16. This is the skirt, which is 13. What? Fix. I don't know what this one is. But it's 17. Oh, it was the jacket. This one's 12, right? Yeah, 12. Was this the one that needed transparency? Yeah, that one needs transparency. Does this one need transparency? Oh, actually, maybe. Or was it this one? That one needs transparency. I think this one's okay with opaque. I don't even know what this one does. I literally cannot fix. Oh, it's the sandals. Okay, that made sense. 10. Eyes. 3. Two. Ah, damn it. God damn it. This one. Or 7. Ah. Unlit. 9. Go, and this needs to be transparent. I believe it's this one. Yeah, it was. 15. Ah, shit. Wait, what? No, I just said 15. There we go. Unlit. This was 14. Transparent. 13. Universal unlit. 13. Transparent? Yeah. I think that looks good. Now we move on to the other girl. Ugh. 10. I know this is just riveting stuff, right? Three. Two. Okay. Bam. It's 3. Sorry, it's 6. 4. 7. 9. Do 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 do. Mm-hmm. Ooh. 13. $17. 15. 14. 12. 12. 16. 16. There it is. There we go. Ooh. 10. 3. 2. 6. 4. 7. Pipeline unlit. 7. 2. 9. 1. Man, I really wish these weren't like all over the freaking place like this. Make this part easy. Fuck, what was this? 14, okay. 14. 19. 16. 'Doesn't look like there's any transparency needed on that one. 17. 'Kay, that one's just the bow. 13. 'That one looks fine. 15. Transparency. 12. Eighteen. 18. And again, we do transparent. Beautiful. Don't see anything glaringly terrible here. I think we're good. Yeah. One last one to go. Ah, God damn it. 10. Three. 2. 6. 4. 7. 9. 1. Oops. 13. 16. 12. 'Kay. 14. And 15. I feel that's interesting. Oh, you know what? There's something weird going on with this shirt. Like, hers is different. What if this is transparent? No. Yeah, because like she looks weird, right? Like this looks odd from the yeah, even from the back. Whatever. All right, let's go to my scene. Flip normals, maybe. But like it's flip normals on that one thing. But it's not. I don't think it's flip normals because like we're not doing double sided, right? So like if it was flip normals, shouldn't we see nothing? Chrono, welcome back. All right, so we got we got our we got them all nice and worked out. Hey, Chrono, you might know the answer to this. In 2022, why does the play button not turn into a stop button when I hit play? Is that like a bug on my side or is that just standard? I think it's a bug. Okay. Cuz I was like that feels really weird. And then there's a way to change the color, right? When you hit play of the editor, right? Unity change color of editor when in play mode. Near the top left hand. Edit preferences, colors. Ah, there it is. Edit preferences, colors. What was it? Play mode tint. I just had it. There it is. Play mode tint. That's so dark. That got so dark so fast. I was not expecting it to be that dark. It's still so dark. Why is it so dark? There we go. That's it's not warningy enough. Like I don't know if I'm gonna be able to get what I want. Do. What if I go like really dark and then just turn this down? Maybe here. Hmm. There, and then if I turn, because I think this started out like that. There we go. Okay, so it was the transparency that was causing the problem. That's a bit better. I suppose that works. We'll find out when we start actually adding things, because I want to be able to like read values. Maybe I don't know. Okay, so let's get back to where we were, right? So I got all of the packages installed for Unity registry. So we've got the Unity Phys. Unity Physics is installed. We've got Entity. The entities and the graphics entities. And then we've got mathematics, all installed. Good to go. Good to go. So now we can start bringing in our movement stuff. Really, all we want to do is bring in the Unity graphics should be used with graphics. Wait, so what? We're gonna go like this. We're gonna take that. There, now we have it. I'm assuming that this has to do with this. No. Maybe? No. Yes? Is that this? No, this is... Yeah. This? Okay. Okay. How do I find this graphics setting? I'll open Unity to find where it is. It's at forward plus. In your settings folder, select the renderer that you are currently using. Then under rendering, change the rendering path to forward plus. Where is my... Oh, it's under settings, right? So this would be project settings. High fidelity. Is that it? No. Right? Okay, so it's one of these two. And there it is. And then this should be done, right? Found if faster than I did. I suppose. Wait, where did I change it in here? Yeah. There. Now, how do I know if it took effect? Like, it could clear this. All right. Well, I think we're in a good spot. So we're gonna go to one of these. Close that. Close that. Close that. Close that. Close this. Close this. Close this. Close this. Don't need this anymore. What was that even?
Hello, in this video I'm going to be showing
Oh, okay. Don't need that. Don't need this. This one I'm going to set to there. This is the one that I actually want.
Is on the inspector on the top right corner, we have the circle button. And if we click on it, we can basically tell on the inspector.
Well, you need a browser window for lookups and another one for videos. You might be right. You might be right. I need to do some pruning is what it is. This is usually what my browser tabs look like when I'm like learning something or studying something. I get a lot of flack for that. Mm. Okay, so now what we're going to do is we're going to go to scripts. We're going to create a folder and we're going to call this scripts. Then inside the scripts folder, we have another folder we're going to call entities. Authoring, and we've got our systems. And in the authoring, we're going, oh, wait, no. We want the systems first. No, we want the authoring first. Yeah, the authoring first. Create. Okay, so here we're going to create a new entities with, this is going to be component data script. Yeah. And this is going to be move speed authoring. And then we can open it up. New window. There we go. And then using Unity Engine, because I know that we're going to need it. Look at that. Isn't that beautiful? It just knew exactly what I wanted. Public float value, and then public class baker. Do public override void baker. Did I spell override wrong? Wait, what? Where did that come from? This isn't supposed to be a class. This isn't supposed to be that either. What the fuck was that? This is supposed to be move speed authoring. Wow. Yeah, it's out for me, gerb. Oh, that's an understatement. Okay, so this would be move speed authoring, and this would be authoring there. Did I misspell something or something? Give me 1 second. I'm just going to go boom, and we're going to do boom. There was something definitely weird going on there. Oh, wait. Right. I know what I did wrong. Okay, and then if we do packages, no, assets, scripts. I just want a AI that will autofill my code base and fix / suggest names. That might be asking too much, dude. Oops. To add a what am I doing here? This one is a iSystem. It really wants those namespaces. I don't want to deal with namespaces for everything right now. If I was to do it, it would be like specific to my stuff, but I don't think that we need to worry about it right now. I think that's actually correct. Using Unity dot transforms and using Unity mathematics. There we go. That actually looks right. Hey, look, it did the right thing. What's the problem here? Use var. Why does it want me to use var? Why? Why does it hate me like that? Okay, then all I need to do is take, if I take this, 1 sec. I have an idea here. Copy. Damn it. Yeah, I suppose. If I do this, I do this, copy, and then paste. It did work. Sweet. Copy. Paste. Copy. Paste. Copy. Paste. Look at that. We got everything back now. Do I not have better gizmos installed? I don't think I do. Damn. Oh, right. I forgot that Unity registry. Player input. Unity 6 is the first one to actually by default have the import system. By the way, I'm not too loud, right? Here we go. Now if I go to here and I hit build, I should get only minor warnings. And that's not what happened. Right. Yeah, I don't have the input system. What was it again? It was renderer, new physics. Animation controller. How the fuck did I make this input system? I had one made. I made one. Create input system. Where the fuck is input system? Light map, material rendering, auto, input assets. So weird. So I wonder if I can just do no, because they're the Unity 6, right? So I don't think I can just copy and paste it in, right? I don't think so. Do I need to restart maybe? Because I could have swore it was supposed to be in this list. Yeah, but I'm not seeing it at all. I might be blind. It should be installed and enabled, right? Is it not? Wait, edit. project settings? Ah. Okay, so something didn't get enabled, maybe? Unity 2022 new input system.
As you can see, I have a little square mapped to the as you can see, we're now unpacking the package and it's compiling all of the scripts required for it. Now, when we change our input system to the new Unity input system, we will have to restart the editor. We can just press yes, and it will do this automatically for us.
It was right. I do need to restart. Why did it not auto restart though? No, it's fine. Don't worry too much about it. Kind of would have rather stayed in 6 just because the project was kind of set up already. But if I'm going to have that random error, that I'm not sure how to fix, I'm just going to not do that. Yeah, it needed a restart. There we go. I would have imagined that like Unity 2022 and 6 would have been mostly the same. Like I wouldn't have imagined there'd be so many large changes between the two. I don't entirely get the idea of like why they switched from the year to uh a number. And why was it 6? Why was it Unity 6? It's got to be the dumbest marketing thing ever. Why was it Unity 6? So is the idea that Unity 2022 and 2023 or no, wait. I bet it was because they wanted to be like, we are one step ahead of Unreal. They're not going to support a number for. Oh, is that the idea? So like Unity 6 will be like a multi-year release. Okay. It makes perfect sense. Create new. Give me a moment. Beautiful. Wait, wait, wait. This is scary. I think it's like the collections. I don't know. We're gonna come back to that. But that's scary. That's actually scary. All right, so time to add a cube. Wait, do we have a cube? Oh, we have a bad cube. There's our cube. What a beautiful cube. This cube looks really big. Oh, that's why. Okay, that's fine. Where's our camera? I might be able to go back to UE sorry, Unity whatever. Unity 6. Yeah, that actually might be the play. Although I'm kind of annoyed because like I just spent all that time setting up all of those characters. Rigid body. Play. So it's the input system. Or wait, no. Let's go back. Okay, I'm gonna close this for now. There we go. And then we can move this one here over to here and minimize it. Then we can come back into Unity 6 here. And then we can hit play. And I think we're still going to be broken. Okay, so we're broken. Now, if I come back into here and we go to the vehicle controller is using the collections generic. If we do that, oh, that's a good idea. Give me a second. Okay, so we do that, and then we it does not. Okay, then we build. I think we're gonna get that error there. Okay. Using Unity engine dot system collections? No. What was the one that we in physics? Unity physics? Unity collections. This might be the fix. Let's try that. Okay, so wait, what if I just do this? Okay. So we know that this is going to be a problem, right? So if I just wait, I don't like that. One sec. Give me a second here. What we're gonna do is we're gonna take all of this. We're gonna do that because right now we know that it's not working. But what we can do there. Okay, so we still oh no, we still get that error. Do we have somewhere else where we're using the collections? We do. Why are we using the collections? I don't think there's newer versions of Visual Studio than what I have. No, because this was installed like last week. .NET 4. Huh. It's probably a package I have installed. Unity. I feel like the answer is actually with the. Give me a second here. I don't need downloads. We don't need that. Here we go. I'm gonna close out of that. I imagine that it's something to do with one of these. And it's probably one of these runtimes. Where was the extension development? I don't need this. It was required for. Okay. That one I need. Unity. They could not be resolved. Here we go. Common fixes, dependencies, update package and reinstall. Party components, binding redirects. In some cases, your project might specify or might need version of an assembly. See the understand how binding redirects work. Visual Studio or settings in project files can enable or disable automatically. This file here looks familiar. Okay, so we do this, exit. Then we bring this in. One. Okay, so there's only one in that one. What about this one? There's still only one. Oh, yeah, you're right. Forgot that Unity was open. But I should probably actually find out what I think I deleted the text. Yeah, I don't have that text anymore. There it is. Okay, so this is the one that we need to solve for. Okay, and then we can close this now. Exit. And then we can do vectors. There we go. I don't know which one of these needs to be edited, but we'll just edit both. So this is using C editor 6 editor data Unity reference assemblies system numeric vectors. And what were the two that we were struggling with here? Was chosen because it was primary and wait. Okay, so Microsoft Common version okay, which one did it say was selected? This is supposed to be the primary. Okay, so how do I set the primary? Because it's saying that this one was the one that was used. Or sorry, it was using the other one, right? Is there another file that I'm not aware of? Okay, so found conflicts between. There was a conflict between and system version public reference, which depends on reference, which depends on Okay, so 4.0 was chosen. Reference which is the Unity one. And the Unity one is the problem. I wonder if I install collections if it will work. Oops, wrong one. Oh, collections is installed. So what if I use... No, because we already established that just using it won't work. Check out the docs. I thought I was there earlier. Unity... wait. Unity physics. Forget whether or not I disabled that or not. Because I think I re-enabled it. Project settings editor. Is the file extension you found the reference? It was the okay. So I've got two of them. There's the CS project and which is the assembly CS project, and the assembly CS editor. And I feel like this here is the problem. What if I just delete it? We can just do this, right? Okay, so what I'm going to do is I'm going to take these and I'm going to copy them. I'm going to create a new file. Oops. New text file. Then we're going to paste them in. Beautiful. And we're going to hit cancel. That's fine. And then what we're going to do is we're going to come down here and we're going to do vectors. What about numeric, actually? Interesting. This one has a different thing. Okay, so this one here is the. Actually, you know what I'll do? This is a better idea. Traccoon Explorer. We're just gonna duplicate this. And then we'll do this. And we'll do dot old. There we go. Now we have the old copies. It's beautiful. Now we can come back into here and we can say, hey, this, let's just change it to that other one, right? So if we go back to here, we can say, since which depends on, okay, so they stated that one of these was going to be used. Found conflict. 4.0 was chosen because it was primary system vector. Okay. And then 4.0 is this one, which is the Unity Hub one, right? And what we want to try is the C program one, this one. No, that's the Unity Hub one, right? This one here that we want to use. There, and then we want vectors here to be the same. Now I should probably have not done that while this was open, but that's okay. That's okay. It's okay. Now if I launch this, we can open up TruckCon. So the file below where the one that references that file is said. Well, give me 1 second. Let's see if this fixes it. This might have fixed it. I'm gonna laugh if this fixes it. It's hard because like the warning, sorry, doesn't always happen. Yeah, this one's Happy Good Fun Times. Let's see if this fixes it. Still a fucking problem. God damn it. Make a new one of what? All right, maybe this will come back up with the. There we go. We got the error again. Which one did it use? Okay. Why this is happening, I don't know. Like, goddamn, is it annoying? Oh, that's the wrong project. Wait. That one was it the temp and the objects, right? It's an objects. Objects is debugging shit. Yeah, give me a sec. There we go. When you say rebuild the project from Unity, I'm not entirely sure what you mean. Like, I don't personally care whether or not this warning shows up, right? What I care about is the fact that physics stops working. And it's intermittent of whether or not it's going to work or not. I thought I already did that, didn't I? Create scene, scene. Template scene. No, it wasn't template scene. It was just scene. Create new scene. Scene. It's my scene. Wait, why would it be the scene? What in the scene is causing the problem then? No, now it's working. Does this work? It's definitely something. Okay, so we've narrowed it down now to it's the scene. So then that begs the question, like, I don't even know. Yeah, okay. Well, you know what? We solved the problem. We can stick with sex. Let's just stick with sex. At this point, I'm fine with sticking with sex. Okay, let's wait. Can I port? Is there a way to port the characters from from can I pull the characters assets out from the just grab the folder? You know what I wanted to do, right? Like because I just set up all those characters and I don't want to set them up again. Okay, so if I take these characters here, can I just move them over? Is that just going to work? Oh, fuck yeah. Okay. Oh, it's beautiful. Yes. Yes, it works. It works. All the things are working. Make it so, make it so. I still am I still think that like actually making the vehicle is going to be important, so I'm probably still going to do that. It feels like a good idea. Like build in when you say hit build, where? Is it the build in my editor or the build in the Unity editor? Like in Rider or in Unity? Okay. Cuz I'm fine with that. I do that anyways. I'm so used to Unreal because in Unreal I have to oh that's cool. So in Unreal you have to build the entire editor every time that you want to make a change. Right? So you relaunch the editor. The drifting is insane. So like I'm just so used to having to do that anyways. Fuck, I go so fast. Whee! Beautiful. All right, so I'm definitely going to stick with 6 then. We got it working. That's what's important. All right, so before we do anything else, this is going to be super important. We're going to close that. We're going to relaunch the game. We're going to see if relaunching the game continues to have the fix, or if I'm going to have to change the scene reload the scene every time that I want to make these changes. Do they fall or stay? They fall. Beautiful. Oh, thank God. Okay, sweet. We can move on. We have enough that we can move on, and I'm still planning on doing this. Right? This is an exercise in something that I would like to do. But we can move them out of the way. There we go. So now this said that it had I thought this said that it had animations. Do, do, do. Oh, okay. Here we go. This is all. Oh, it's $18. It's a lot of animations, though. So you have a free version? The full version? This is a sample animation pack to test if your characters are compatible with the animation. Sweet. Wait. Standing. Wait. Run, sprint. Okay, walking. Yeah, walking. Walking's there. Sweet. Okay, so add to my assets. Accept. Open in Unity. There we go. Is it find object? Find object of type has been deprecated. Use find object. No, I'm aware. It means that it's going to be removed in either in a future version of probably it's probably going to be removed in 7, I'm guessing. See, find object of type sorts the results by instance ID, but if you do not need this, using find object sort mode dot none is considerably faster. I literally do not see the difference here. Object at oh, I see. It's what this mesh render scene renders find objects by type, and we're going to use this one. And then this one has Alt Enter on it. Oh, yeah. Yeah. But this is the part that's confusing to me. These are the same wording, right? Object, find objects by type. Find object by type. I'm not sure what the difference is. I feel like I'm slowly going insane here. Okay, so this one's the one in question. Oh, it's by, not of. Oh, that's what I'm doing. By type. It's by type is the new one. Yeah, and then we do this gets moved into here, right? Which is mesh render and type. Right? No. Oh, okay. Okay, and then we just give the sort mode, which is going to be sort mode none. What was it? It was find sort mode none. There we go. And now I don't get the error anymore. Yay! Yay! No more warnings. I don't like having warnings. Warnings actually do bug me. I'm just gonna come out and say it. Warnings actually bug me. Warnings are errors waiting to happen. I go into some people's, like, when I've watched people do Unity development, and their console is just full of errors and warnings when they're doing stuff. I'm just like, dear God, why are you not fixing any of those? And a lot of the time they're just like, oh, I don't even know what's going on. And it's just like, what do you mean? You should know what every one of those warnings means and whether or not you can safely ignore it. Yes, but you know what the error, you know how to fix the error, and it's not worth fixing. I've talked to people and they're just like, oh yeah, they're warnings, right? They don't matter. And it's just like, no, wrong. Warnings matter. If a warning is there, you should take a look at it and figure out why the warning is happening. And I'm just like, please stop hurting me. How do you what was the steps to do the ragdolls again? Unity ragdoll. I'm gonna get that done too, really quickly.
Hi everyone and welcome to a new CodeFriend video in which I will show the ragdoll either on its simplistic shoulder. Dolls in Unity and in 1998 with Jurassic Park trespass stated because Unity does include a tool is the simplest one. System will do its job. Interesting example. There is a cannon shooting two examples. There is a GitHub link in a website on which you can catalog. I can go in of our characters. Humanoid characters are almost always built. This window to be set up for ragdoll. I can go in game object, 3D object, ragdoll. This window will appear and ask.
Wait, so I just do. I don't know why I was thinking it was just a component. Wait, what did I do wrong here?
You can download hundreds of characters and animations for free. The character I'll be using today for this example comes from the Mixamo catalog. I've also imported it in my project and in my sim. Now that my character is ready to be set up for ragdoll, I can go in game object, 3D object, ragdoll. This window will appear and ask us for the different body parts of our characters. Humanoid.
Left hips. Left knee. Left foot. Right. Yeah, right. Right. And then we've got there's the neck. Here's the head. Get the head out of the way. And then upper chest. Do. Neck. Do. Yeah, it's about this one. To do middle spine. Then we can do collapse that. Then we've got left shoulder. No, it's upper arm. Then the elbow is the lower arm. And then the lower arm. Total mass. This is total mass is in Unity total mass, ragdoll mass in Kiji. A ragdoll, okay, all ragdolls in the ragdoll weight weigh 5 kilograms. As a total, the total of mass is 75 kilograms. So my understanding is this would be 25 kilograms. So Japan average adult woman weight in kilograms. It would be at least 53. We're going to definitely go on the higher side, but we're going to give her 60. There you go. And then strength. What does strength mean? Mm,
Humanoid characters are almost always built the same way. There may be one or the other difference in the character's body part. For me, asking for the pelvis of my character, but in my case, it's actually called hips. The gizmo is for my in a lower arm, opposite neck, legs, head, and body sliders around our character fields with neck. Once all the body parts have been filled in, you can leave the last fields with their default values and click on create. You can then select the
Unity create ragdoll rank value. I hate that there is no browser level search in this. It actually bothers me. Unity forms are effectively somewhat useless because of it. It's bad. Strength. Why does nobody change the strength? I'm guessing this is like, I want to say that it's probably like, uncheck the joint enable processing. Character joints. All right, I guess I'm just going to leave it for now. Create. Then what we need to do is make sure that these are all kinematic at start. Look at that. We did miss one. Okay, so she's done. Is she got it? No, she does not. Okay, and then we do asset create. Did I do this wrong? I just did this. Asset create. Is it just here? Fuck, where was it again? I just had this too. Where did it go? Where did you go? Unity, Ragdoll physics.
Hundreds of characters put it in my project and in my sim. Now that my character is ready to be set up for Ragdoll, I can go in Game Object, 3D Object, Ragdoll.
Game object, not asset. I think I was going to asset, right? Game object. 3D object. Ragdoll. There we go. There's the hip. The head. And then we want the chest for the middle spine. And then we can close that. And we want the left shoulder. Wait, which? Okay, there's left shoulder. Left arm. This one? Oh, wait. It's upper arm, not shoulder. Upper arm, then lower arm. Upper arm, and then lower arm. And we've got the upper leg. This is left hip. Left knee. Then foot. Welcome back. What you end up getting to eat? Upper leg. Lower leg. Foot. Go like this. Fuck, I can't remember what I did. Was it 60? I think it was 60. I think I gave her 60. Then we do... I invoke my phone. I looked on my phone for stir, and yeah, no one touches it. Beans and chicken with guac and yogurt for sour cream. Nice. Game object, 3D, ragdoll, hip. middle spine. And head. Left arm. Left elbow. Shoulder. Right arm. Right elbow. Left upper leg. Left hip. Knee and foot. Is a sour yogurt less fat but same sour? I'm not sure. In component, to do 3D object, ragdoll. Type faster than my brain, so I missed some stuff. Sour yogurt, less fat, but same sour. Okay, I'm picking up what you're putting down now. Prefabs. Did I already do all of her? Oh yeah, I did. This is the first one of this one, right? I'm getting faster at this. Now, if I remember correctly, we don't need foot at all. Yeah, foot doesn't actually come into play here. Do, 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 do. And we have one left. Do, do, do. Shoulder. Oops. Oops, I grabbed over the same one there. There we go. I want Unity 7 so badly. They are bringing out a animation system like Unreal's. Sounds interesting. There we go. We have the thing. Okay. So now what we want to do is this is our subsystem here. We want to pop her down. So we take her and then we pop her into there. There we go. Oh, okay. Yeah, we don't care. Oh, it's just saying that it doesn't like the shader. And I'm not planning on keeping that shader, so it doesn't matter. Also, it's like it's warning you just in case you're not getting the look that you want, because it's saying that it doesn't support unlit properly. So if you're leaving it at unlit, you might run into problems in the future. So and at this in this case, I don't really care. So okay, let's see if we can. We can't move anymore. We can move again. Okay. No, I passed right through her. Oh, right. She doesn't have the appropriate stuff on her. So I changed the scene. I went to a different scene and came back. Unity. Refresh scene. Reload scene. Need to reload scene. Why is the answer to make a script? Why is the answer not like a button inside of Unity? Because like if I rebuild, it's not reloading this scene. So how do I not have a reload? Like just the ability to reload would be fucking fantastic, please. Probably. Unity reform domain reload. So is this like a Unity how to form a domain reload? usually keep both of the reloading options toggled off and add a couple of buttons in a custom editor window. How do I do that? Yeah, this is his script, but like how do I add the I usually keep both of the reloading options toggled off and I add a couple of buttons in a custom editor window. Custom editor window? Is that seriously all it is? Create scripts that drive. Oh. So all I do is I do that. So I come up to assets and I create a new folder and I call it editor. And then I just dump my file in here, right? And then this would be reload. Create a is a mono behavior. It's an editor window. Wait, no. Editor window. Yeah, that's true. Yeah, whatever. I'm already here. I don't have to create the folder again if I do it from here. Scripting. I can just do a mono behavior and change it later. Domain reload script editor. We'll do editor domain reload. Extension window? Interesting. Would I need to copy his name maybe? Did I not put this in the right spot? Oh, okay, there we go. Yeah, I was like, why the fuck is this not working? Like, why am I not seeing things? Hmm. I gotta admit, this is kind of nice. Nice and easy. And then I build. Do I have to restart Unity? Oh, nice. Wait, in the thing that the one that I was watching? And then tools. Tools. Scene tools. There's my scene tools. Okay, so if I bring in another one of her, okay, it's not working now, right? And then so if I do a domain load, wait, yeah. So if I do a domain load, and then I hit play. No, it's a scene reload, but scene reload is only available when it's playing. If do we this could crash. This could not do what I want, but reload the current scene. Reload scene. Okay. To do get the currently loaded scene. Get the Unity reload current scene. Oh, that's probably why. So this gets the active scene, right? And then we do load scene. Load scene. The editor. 15 because this takes what? Takes an int. Okay. This doesn't work. Wait. This can only be used during play mode. Use editor screen manager open scene instead. Open scene? Wait. What can only be used? Um, it's fine. I'm like halfway there. This can only be used. Use editor's open screen instead. What does this take? Open scene mode. Fixed it. Okay, this will cause finalize the in C#, the finalize method is used to clean up unmanaged resources before an object is destroyed. This method. Okay. This was specifically on the input actions. Input systems. This is not the not the one that we wanted. We don't want that. We want is it vehicle controller? Yeah, here we go. And then this would be void fine. I feel like that's right. But they're talking about going to 837. Hmm. Oh yeah, no, I was right. 70 10. 70 10 on the yeah, it was this. He doesn't say anything about domain reloading in his videos except for at the start. Yeah, I had a feeling. I thought that that wouldn't go through because I have it so it doesn't. It's not supposed to. I have a feeling that this is like just I just had this issue as well after upgrading. Yes, and Unity Destructor? Called when an object is about to be fully destroyed. Called when an object is disabled in the scene hierarchy. Called right before on destroy. Oh, okay, so I want the disable on disable, right? Custom vehicle controller. Instead of Sorry, vehicle controller here. Finalize. Instead of finalize, I think this needs to be void on destroy, right? Or no, on disable. No, on destroy. Yeah, on disable. On disable. On disable. There. Build. I will not see that error anymore. So it's the scene reload that causes the problem. So if I go into my project settings, and then it's editor, right? Here, reload scene only, right? This would theoretically always fix the problem. Now it should always do that, and then I don't have to worry about it. Beautiful. Okay, we've gotten somewhere. We're slowly getting there. She's not falling though. Why is she not falling? Oh, right, because she doesn't have a rigid body, right? No, she has a rigid body. Okay. Okay, she's in the air and so is that box. Okay, so reload scene. She's still in the air. The box is on the ground. This is okay. We hit play. That box drops. Does she drop? The answer is no. She does not drop. And it's probably because she doesn't have a rigid body attached to her in here. So if I do rigid body, actually we should do it on the prefab, right? Which prefab is this? I think it is Rin free time. Yeah. So if I add a rigid body here, rigid body, then she should drop. Weird. Oh yeah. it's probably it. Because that's how you disable ragdolls, right? Because okay, yeah, because she needs to have a okay, so we come here, we've got the rigid body, and then here we need the box, or we need a capsule collider. Oops. Is she on the ground? She's on the ground. Yay! No, she's still in the air. What? Mm. What if I turn this not rigid body or not kinematic? Mm. Because if I have all of these as kinematic, not kinematic, right? When the game starts, she's going to ragdoll into and be useless. So how did I get her before? Hmm. Well, she fell. Actually, wait. She fell, but she didn't ragdoll. Oh, because she's falling through the world. So why is she falling through the world? Well, no, because this one seems to work. I think. No, this one doesn't have anything. Box collider and rigid body. Yeah. Uh-huh. I feel like that's a problem though. What if I reload domain? Progress.
The subscene, and I create.
In this video, we're gonna have a look.
Where is my dots tutorial? Oh, that would be annoying. So how am I gonna, so the player has to be an entity as well? Is the player capable of being an entity? Does everything need to be an entity? Everything in the world needs to be an entity, apparently. Yeah, I'm trying to remember which one of the many tabs I have I left that on. Hmm.
Hello and welcome. I'm your Code Monkey.
Oh look, he did 3 days ago. He did the multiplayer one.
Download the project, you will have the same type as our authoring component. We have 100 entities, and if we put the inspector over there into runtime mode, and up here we do see all of the various components. Now our goal, like I said, is to move this unit using physics, meaning for move it, we actually want to modify the velocity, and yep, we can see it right here. This is the component we want to modify, the physics velocity. This one has a linear for the linear velocity, and angular that affects the rotation. So instead of manually moving transform, we want to be able to set this linear field directly inside the physics velocity. So back in our code here, in order to be able to modify the component, we just need to add it over here in our query. So let's add another one. In this case, we want to modify it, so let's make it a ref RW and call it the physics velocity. And yep, it is this one again inside unity.physics. So let's make sure to add this namespace. So yep, this is the component that we want, and let's also add.
Wait.
Hello and welcome. I'm your Code Monkey. Shrug, bring a cube. By the way, you don't need to follow this part. This is really just for testing. Just make sure that all of this is working. So I'm just going to place a bunch of cubes, place them like this, one over here, then place a bunch of speed, let's grab the value R0 for reading, and let's grab the move speed value, and then finally the time.time. Okay, so yep, just like this, we should be doing the exact same thing, so really just moving right. Let's just quickly verify. In order to actually make it move right, let's make sure that the move speed component does have a positive value. Otherwise, if it has a negative speed, then naturally it's going to move to the left side. So let's select our entity inside our subscene, and let's go into our authoring component over here, just make sure it has something like 3. Okay, let's test. And if there it is, unit moving right. Okay, great. Now let's add the rotation. So adding the rotation when we have a move direction, this is actually surprisingly simple. On the local transform that we've been using, well, there we have the position, but then we also have a rotation. We have a rotation as well as a bunch of functions to rotate by a certain amount. In this case, we want to set the rotation to something. Now in this case, this rotation field, this one is a quaternion. And again, note how it's quaternion written like this. It's on lowercase, not uppercase. This is the mathematics quaternion. So to get a quaternion for this move direction, it's actually surprisingly simple. We can go inside the quaternion class, and then we can use the function local rotation. This one takes a forward rotation, so let's pass in our movement direction, and then an up vector. So here we can just do new flow 3, 0, 1, 0. So this is our move vector, or we can actually use a constant, and the constant is going to be the math.up, and this is actually a function. This one returns the exact same thing, 0, 1, 0, and yep, like this, it should work. Okay, so with this, let's do a quick test. But also one thing, definitely make sure that you have the child object. Definitely make sure this one is exactly like this, everything on 0. It should be on position 0, 0, 0, rotation 0, 0, 0. If you do it like this, it should point in the right direction, but if you apply some kind of rotation here, then it won't point exactly. So make sure all these are on 0, and let's run play. And if this works, look at that, there's our unit moving right and facing right. All right, awesome. Okay, so now we have achieved our movement by just moving the transform, but to make the game a little bit more fun, we want to use physics. We want our characters to be able to interact with other physics objects. So let's do exactly that. As usual, let's set up our unit over here with normal components. So let's select the parent game object. And this one over here, let's give the unit a shape. So let's give it a regular capsule collider. Then let's set up the settings. We can see over here on the scene view. So let's make it a little bit higher. So with a height of 2, for the radius 0.5, yep, that looks good. And let's just lift it up a little bit so it doesn't touch the floor. Let's say 1.1. Okay, yep, so there's our unit collider. And again, just like this, just by attaching a capsule collider, just this will automatically convert into dots physics. We can already see down here, yep, the unity.physics.physics collider, this one will be added. So with this, we have a collider. And then for actually using physics, we also need a rigid body. So let's add that one, a rigid body. And again, just by adding it, add a bunch of big components down here. Then for the rigid body settings, over here for the interpolate, we want it to be nice and smooth. So let's make it interpolate. Then we don't want the scene to fall down. So let's make sure to disable gravity. And over here on the constraints, our units should really only move on the XZ axis. So let's freeze them on the Y. We don't want them to.
You disabled graphics. That's gravity. That's why. This makes sense.
Them to move up or down, and same thing for the rotation since we're going to rotate them manually. Okay, great. So that's our setup, again, using normal game object components. And if we put the inspector over there into runtime mode, and yep, here we do see all of the various components. Now our goal, like I said, is to move this unit using physics, meaning for move it, we actually want to modify the velocity, and yep, we can see it right here. This is the component we want to modify, the physics velocity. This one has a linear for the linear velocity, and angular that affects the rotation. So instead of manually moving transform, we want to be able to set this linear field directly inside the physics velocity. So back in our code here, in order to be able to modify the component, we just need to add it over here in our query. So let's add another one. In this case, we want to modify it, so let's make it a ref rw, and call it the physics velocity. And yep, it is this one, again, inside unity.physics, so let's make sure to add this namespace. So yep, this is the component that we want, and let's also add it up here. So we've got the ref rw physics velocity. Okay, yep, so we add a new component to our query, and now down here, for the rotation, we still handle it normally, but for the movement, instead of moving the transform directly, instead of that, let's go inside this one. Let's go inside value RW because we want to write to it. And we're going to modify that linear field. And linear velocity, this one's going to be set to our move direction multiplied by our move speed. So move speed, let's grab it just for reading, and let's grab the value. And if that's it, again, here make sure to not include time.time. Here, this is really just saying velocity is not actually moving the object. Then the physics system afterwards, they will apply the time.time, or actually the fixed time, and that's what actually moves the object. So make sure you don't include it over here. And also, since our units are going to collide with each other, that's actually going to mess things up and actually trigger some rotation. Later on, we're going to implement some proper collision avoidance logic. But for now, while that is still going to have tons of collisions, we don't want it to completely break everything, so let's make them not rotate. So here, let's make sure, even though we freeze the rotation, even with that, it will still rotate if it forces some collisions. So let's manually just set the inward velocity into 0. So we can just go inside flow 3 and access flow 3.0. Okay, yep, just like this, it should work. So instead of modifying the local transform position, instead of that, we are just assigning a velocity. So let's save, and now let's test. And if there it is, the unit is still moving exactly as intended, except now it is doing so using physics. Now we can actually verify that. So in our scene, let's add some objects. So inside the entity subscene, I'm going to add a bunch of cubes. So let's construct a brand new cube. By the way, you don't need to follow this part. This is really just for testing. Just make sure that all of this is working. So I'm just going to place a bunch of cubes, place them like this, one over here, then place a bunch more on top, and a bunch more on top. And for all these, let's also add a rigid body component. Just make sure they fall down, rigid body just like this. Okay, so with this, we have a bunch of cubes. Our unit is going to go right and should interact directly with those cubes. So let's try and test. Except nope, that didn't actually work. The cubes fell down through the ground. And actually, that makes this an excellent time to mention how dots physics and game object physics, those are completely separated. Those are two completely different worlds that do not interact with one another. These cubes that we just created, these are placed inside a subscene, meaning these are going to be converted into entities. They're going to be using dots physics. But the ground, this one is still a normal game object outside of the subscene.
Oh, we figured out what the issue was.
Meaning this one is using just normal game object physics. So that is why the cubes went through the ground. That's because they are working on completely different physics systems. It's as if for the cubes the ground does not exist, and it's as if for the ground the cubes do not exist. Because again, both physics were like completely disconnected. Now in order to see this working, it's actually very simple. Let's just drag the ground directly inside the subscene, and now they should all be baked into dots physics. So now let's test. Okay, yep, they stay there, the unit goes, and there you go, the unit does move and does interact with those cubes. Alright, awesome. Okay, so here we are using dots physics. The unit moves, it goes through, interacts with those objects, and everything works great. And again, remember how dots physics and game object physics, those are two completely separate worlds. So let's revert to what we did for this testing. Let's put the ground back outside, and let's delete all of our testing cubes. Yep, just like this. Okay, so here we set up our unit mover system, which is a query.
The age-old mistake of never watching it all the way through.
For some components that match exactly what our unit has, then it uses that to move that unit. We saw how to do it by moving it transform directly, and then by moving it using physics. However, right now our unit is moving to a fixed point. It is constantly moving to the right. So let's implement some logic for making it move towards the mouse position. So let's do that in the next lecture. Alright, quick intermission.
So that introduces a kind of interesting situation, right? Because now the character and the world needs to be within a dot scene, right? A subscene. Can my character work inside of a dot scene? Can I place my character in here and it still function correctly? Oh, right. I'm going to fall through the world. There it is. Environment, ground. I'll be right back. Okay, we're back. Yeah, there's probably a way. I think the answer is to continue watching.
I just want to ask you, how are you getting along with dots? Does the concept of entities, components, and systems, does that make sense? What about the baking system? Are you finding it relatively easy to write code in a data-oriented mindset? Dots is a very new technology, and I tried as hard as I can to make the course have a really nice, smooth learning curve. So I want to hear from you if you are managing to learn everything correctly. I found that during my own research, once I started to understand the core concepts behind dots, everything suddenly became much easier. Nowadays, after all my research, after learning a ton, now I can very easily picture a new system in my head and already think about all the components and how do I organize them in order to make whatever I want to do. So do let me know in the comments your thoughts so far. Feel free to post any questions you have, and I'll do my best to help. So pause the video to do that, and then let's continue on to the next lecture. Hello and welcome. I'm your Code Monkey. In this lecture,
Yeah, that could be the way. Though the alternative would be to have okay, so the alternative would be to just build the truck into dots. Like, why not?
we're going to learn how to get the mouse wrong position so we can tell our unit to move there. We're also going to learn about one very important topic, which is deciding what system should be using dots and which should be normal modifiers. All right, so let's get our mouse wrong position. Now, how to do this is actually quite simple in technical terms. The more interesting part in this case is where do we write this code? Now, when I was first researching and making the prototype for this course, I started by making it a normal I system using dots, and it did work. I had some logic working on a system. I would store the mouse wrong position in a component and read from it from various other systems. Then I added the selection logic on top of it, and again, I got around working with dots, but the whole process was definitely becoming needlessly confusing and very convoluted. So that's when I remembered how you don't have to build everything using dots. Always remember how you don't have to go 100% dots or 100% game objects. You should mix them and use the right tool for the right job. So the rough general rule that I came up with is actually quite simple. For things that are not performance critical or simply don't run all the time or only run on a single object, so things like mouse wrong position or the unit selection manager or the resource manager, inventory, and so on, for those, write them as normal mod behavior scripts. And then for things that do require maximum performance or impact lots of objects, like for example moving units, for that do use dots. So that's the rough guideline that we're going to follow throughout this course. Following that makes things quite a bit simpler and makes it easier.
My truck should be dots. Is what he just said. Yeah, dots truck. Yeah.
decide which is something to be dots or a modifier.
Which also means that I have to build the truck from scratch.
Here. So that said, let's make our normal mouse position script. We're going to make a normal script. So let's go inside the script folder. Let's actually make another folder for the mono behaviors. And let's right click inside that one, make it a normal mono behavior script. And let's call it the mouse world position. Then as always, let's make a normal game object to run it. So an empty game object with the exact same name. Again, outside the subscene, this is a normal game object. Let's attach the script onto it. Let's reset transform, put everything nice and clean, and open it. Okay, so now here let's do some super simple mouse world position logic. Now there are various ways we can do this. We can either use physics or not use physics. So let's do the similar approach without physics. First, let's make a function, so make it public so that everything can get this. We're going to return a vector 3, and let's call it get position. So this one will return the mouse world position. Now here, let's begin by constructing a ray from the camera. So we can access camera.main. This is going to be our main camera. And from there, we can call the function screen point to ray. This one basically takes in a screen position and converts it onto a ray object. And for screen position, we can get the mouse screen position by using input.mouse position. Also, by the way, here using input.mouse position, here we are using the input manager instead of the input system. Now, if you're seeing some kind of error in the code here, that is probably because you don't have input manager enabled. Although if you downloaded the exact same project files, it should already be set up correctly. But if not, let me just show you. Let me just return something just so this one doesn't throw an error. So just return that. Okay, let's save. So here in the editor, you can go into edit, then go into project settings. Then on the left side, let's go over here onto the player tab, then scroll down inside the other settings tab. And if you scroll down here, we should be able to see, yep, the active input handling. And over here, you can select use the input manager or the input system, or you can select use both. Personally, I really like using both. The input system is really awesome, but also quite a bit more complex, whereas the input manager is super easy to use. So while you can write the same logic using the input system, personally, I really like the input manager just for its simplicity. And of course, always remember you can always refactor your code. So this is actually how I normally build all my games. I start off with the simplest approach possible, and then later on, eventually I refactor it. So in order to be able to do that, let's make sure both are enabled, which again should already be done by default. So back to our code here. So we have this, and this one is going to return a camera ray object. Let's actually name this mouse camera ray. So it's going to be a ray that starts from the mouse position and is pointing directly as the camera is pointing. So now with this, we just need to know where does this ray intersect our game plane. So for that, let's construct a plane, like using the plane class. To define new plane, construct a brand new plane. This one takes in a normal and the origin. So for normal, let's use vector 3.up. We want the plane to be facing upwards, and for the origin, vector 3.0. Okay, that's our plane. And now with this, we can simply do a raycast against this plane. So let's go inside the plane, do a raycast using our mouse camera ray. Then this is going to return whatever distance we hit. So let's return out, float, and just call it distance. This one is also going to return a boolean whether it hits something. It should always hit something, but let's put it inside if. Then if it hits something, then we can simply go inside the mouse camera ray and we call get point. This one basically returns a position within along this ray axis at a certain distance. So let's just use our distance, and yep, this is going to be the mouse world position. And if it doesn't hit, which should never happen, it should always hit something because the camera is always going to be pointed slightly downwards. But still, just make sure this code compiles. If not, let's return vector 3.0. Okay, that's it. Pretty simple. We construct a ray object starting from the camera and using the input mouse position. That's the screen mouse position. Then we construct a plane directly on 0, 0, 0 pointing upwards. We do a raycast against that plane and we get the position. So this should be working. Let's do a quick test. Up here, let's do an update just for testing. So void update. On update, let's just do a debug.log on this get position. Okay, that's it. Let's test. Okay, so here we are, and we can see the log, and right around here is around the origin. And if we do see down there the position, it is close to 0, 0. As I move to the right, yep, it is increasing on the x and on the z. And as I move over here, lowering on the x and on the z. So yep, everything does look perfect. All right, great. So here we have one method for doing this. This is just using math, no physics, nothing like that. This is really great and really simple if you have a flat game plane like we're going to have in this game. But for example, if you wanted to use a non-uniform terrain mesh with different heights, if so, then using physics would be a better method. The way you do that is actually quite simple. It's very similar to this. You would go inside physics and do a raycast. This one takes an array as well, so we can use the same mouse camera array. And then we can use this version of the function that just returns a note, raycast hit for the raycast hit. This one also returns a boolean, so if it is true, that means it's going to hit something. And if it hits something, then we just return the raycast hit, go inside it next to the point. This is going to be the position where it actually hits. Then if you want, you could also add an external layer mask. So you can use this version with a layer mask and use that to make sure it only hits the terrain collider. And with that, then yep, this would be working exactly the same, but using physics. So depending on what game you're making, you have two options. You can use physics or not use physics. Now in this case, our game is actually going to have a flat plane area. So for that, we can just use the simpler, just math-based method. And yep, that's it. Here we have a nice function that returns our mouse world position. Now let's actually use it. Let's get rid of our testing update over here. And now on the unit mover system, over here, instead of constantly moving to the right, over here we want to move towards the mouse position. So here, let's grab the mouse position. And in order to make it easy to access, let's actually make the mouse world position a singleton. So back in this class, let's make the standard thing for making this a singleton. Now since this is an intermediate course, I'm assuming you already know what exactly is a singleton. Basically, it's a super easy way to access a global reference of which there exists only one of them. So here we can just make a public static of the type mouse world position. Let's call it instance. Make it a property with a public get and a private set. Then we just implement the normal awake for our mono behavior, and on awake set the instance equals this. Okay, that's really it. Now we can easily access this instance, and through there, then we can call this function. So let's go back over here onto our unit mover script, and when getting the type position, let's go inside the mouse world position, access the static instance, and call get position. And just like this.
Singletons are dangerous.
This unit should be going towards the mouse position. Let's make sure to save both files. Wait for Unity to compile. However, after we compile, we actually see an interesting error over here on the console. This is a burst error. It is telling us we cannot use burst inside of this function because inside it we are calling a managed function. We are calling our mouse world position.getInstance. Once again, when using burst, we cannot access any managed data. So this is why you have to be careful when not using just structs. If you don't, you get this issue, which means the code will still compile. We can have them play and it will work, but it will not compile using burst, meaning the code will still run just slower. Now, right now in this example, we can really just ignore this error since later on we're going to get the type position in a different way. But this is a great reminder of the limitations on burst. And when working with dots, don't get too scared if you see some burst errors because again, they don't stop compilation. They're really just warnings to make sure that you know that burst is not working, so your code is not running as fast as it could be. But in this case, it should be working fine. So let's test. Click on play. And if there it is, there's our unit moving, and it is indeed moving towards the mouse. So I place the mouse wherever, and the unit goes perfectly towards the mouse. All right, awesome. So everything is working perfectly, but two things. First of all, the unit is going towards the target all the time. Now, usually in an RTS game, you want to be able to actually control it. It should really only move towards the mouse position when I click on it. And secondly, the rotation is way too snappy. It rotates the target position 100% instantly. We want to make it look good, so let's make it smoothly rotate instead of being such an instant thing. Doing that is actually quite easy. So over here in our unit mover system, we are setting the rotation, and we are setting it directly to the final rotation. If we want to add some interpolation, we can actually use the slurp function. There's a function for it inside the math library. Again, that is the normal math library. Inside this one, we have a slurp. Again, do not confuse that with the math library. It is not that one. It is the math library. So here we have slurp, and slurp, by the way, means spherical interpolation. So basically, it interpolates from one rotation into another one. So we can use it to very easily smooth out our rotation. This one takes a starting quaternion, an ending quaternion, and then a time. So for the start, that is going to be our current rotation. So let's go inside the local transform. Let's read our current rotation. Then for the target position, that is going to be the one that we are calculating here. And finally, we have the t for the time. In this case, we can just use delta time multiplied by some rotation speed. So system API.time multiplied, and let's find up here some kind of rotation speed. Let's put it something like 10f and use it like this. So then we assign our rotation into this. Okay, that should do it. And this should now make the rotation nice and smooth. So let's test. Okay, there's the unit. And yep, as I move the mouse, even if I move really quickly, the unit still moves at a relatively nice, smooth pace. Okay, great. So now to solve the other problem, we only want it to move when we click. For that, we're going to need two things. We need to store the target position instead of setting a new one every single time. And we're also going to need to test where we click. That's actually going to be an interesting challenge. So let's do that in the next lecture. Hello and welcome. I'm your CodeMonkey.
There's something that I wanted to test now that I've brought this out. Does my truck still work, or do I fall through the world? No, I still work. No, wait. I fall through the world. Wait, what? Okay, so we have this. There's our main camera, but main camera. Yeah, there we go, the player. And then the camera offset. And then the rigid, I think the rigid body is on this one. No. Okay, and I should fall through the world. I don't fall through the world. Interesting. Wait, but she falls through the world. Huh? What? With this tutorial in YouTube, everyone says this is a bad way and don't do it this way, but they never show the right way. Oh yeah. Yeah, it's because the right way usually is cumbersome to pull off, and that's why people don't do it the right way in tutorials. And I think it's terrible that people don't do things the right way in tutorials. You should always try and do things that you shouldn't teach people to do things the wrong way. There was an engine that did that where they taught a bunch of people how to do things the wrong way, and it ended up causing like they ended up in a situation where um everything was wrong effectively at the end of the day, right? And um yeah. Okay, so this needs to be a rigid body in order to get physics, and then we use gravity. We just say we don't need that. Save. And then if I hit play, she won't fall, and I don't think I will either. There we go. She didn't fall through the world. Yeah. She's down there. That's good. There we go. Now she should fall and we should see her hit the ground. There we go. Beautiful. Look at that. It's amazing. You can re-download the debug material again. Yeah, but I don't need it. I'll come back to it. Like I'm sure I'll probably want it at some point, and I'll re-import it at that point.
In this lecture, we're going to learn how to get the unit to move to the mouse position, but only when we click. This requires refactoring our component and creating another non-dot script. Okay, so here we have our unit rotating and moving towards the mouse position, but we want it to only move on mouse click, not all the time. So let's solve that. And for that, we're basically going to need two things. So we need to store the target position instead of setting a new one every time, and we also need to test for a mouse click. Now first, for storing the target position, as always in dots, you store data in components. So let's actually refactor this move speed component to include a bit more data than just move speed. Let's rename this. So we can right-click directly on top of the symbol, and let's click on rename, which will automatically rename everything. So let's rename this instead of move speed, just call it unit mover. So this is our unit mover component. So rename that one, and let's also rename the authoring component. So let's rename it, and this one is going to be the unit mover authoring. Okay, so yep, everything has a different name, and now the unit mover system, this one is also using the unit mover. Let's just rename this one over here, so unit mover. So yep, that field has been renamed, unit mover has been renamed, and over here we're not using it. Okay, so far so good. Then back in Unity, make sure the file itself did change. It should be called unit mover authoring, and if we go inside the unit itself, yep, it should still have it, and if we hit on play, yep, everything should still move. Okay, great. By the way, here, make sure your unit is not on 0, 0, 0. Move it just a little bit. It's important because otherwise you won't get an issue with the math.normalize. If the move direction is 0, 0, 0, then this one ends up with nan, not a number, and that causes all kinds of issues. This will no longer be an issue once we add the stopping logic later on in the course, but for now, just make sure the unit is not on 0, 0, 0. So on this one, let's add some more data. Actually, let's also rename this one instead of being value. This one is going to be the move speed, and same thing on the unit mover authoring, move speed. Then here in Unity, let's select the unit and make sure that it has a move speed. So there we go, reset to 0. Let's put it on 5, and again, play again, and yep, it still works. Okay, great. So now here on the unit mover, now we can add whatever extra data we want. Like for example, we can add the rotation speed. Like previously over here, we were using a local variable, but it makes more sense for that data, that value to be defined over here. So let's do a public float for the rotation speed. And again, let's also define it on the authoring component so we can pass it in. So our rotation speed equals, go inside the authoring component and grab the rotation speed. Then on the unit mover system, over here on this one, instead of using a local variable, instead of that, let's use the one that we get from the thing. So we get the quaternion local rotation, and then for the t, we've got time multiplied by, let's go inside the unit mover component. Let's read from it. So let's access the value RO, and we want the rotation speed. Okay, so now our component should have some more data. And if there's our component with rotation speed, let's put it a bit faster. Let's say 15. Let's test. And yep, it is still rotating with the rotation speed. Okay, great. So this working. Now let's let this deal with making sure that it only goes towards the mouse position and only on click. Now technically over here on the unit mover system, on this one we could add that logic. So we could test over here if input.get mouse button down. So when player left clicks, if so, we can say the target position equals the mouse position. So technically we could do this. We could write this directly over here, directly inside of the unit mover system. This would technically work, but then it would also become quite messy. One of the main goals of dots is for your systems to be focused on doing just one thing. So for this system, which is called the unit mover system, this one should really only be moving the unit. It should not care about giving unit orders. It should only move regardless of where that target position came from. So let's make sure this system stays focused on just that, just moving units, not on giving orders. For that, let's make another script that will basically handle the unit selection, giving them orders. And again, we have the same question we had a while ago. So do we make that a normal system, or do we make it a mono behavior? Again, going back to the general guidelines that I mentioned a while ago, basically how you should use normal mono behaviors when we have something that only happens rarely or is not performance critical, and only use dots when it's something that involves tons of units or requires tons of performance. In this case, for the unit selection, at most the player is going to be selecting their units, let's say 10 times per second. So it is not something that is going to run 60 times per second. The logic for unit selection is not performance critical.
Okay, so you can add movement scripts directly into okay, so I can add the movement script directly into the thing, and then I don't know, that's a rough one. I might have to bring it out and I don't know. We'll play with it.
Pretty cool. So for this one, let's make another regular mono behavior. So let's right-click on the mono behaviors, create a brand new mono behavior script. And for this one, let's call it the unit selection manager. Also, as a personal rule, I decided to name all the mono behavior scripts, name them all manager, and then for the dot systems, name them all system. Again, not a requirement, just a nice convention that I find very useful to follow. Okay, so let's make a game object to run the script. So a new empty game object, give it the exact same name. Let's make sure to drag the script and reset the transform and open. Okay, so now here, let's make a normal update. So private void update, so the standard update. And now here we do want to test for the right mouse click. And again, we're going to be using the input manager. So input get mouse button down, mouse button with an index of 1. That is the right mouse button. So again, here we're using the input measure. Again, just for its simplicity, just because it is so simple to use. But later on, we can refactor this to use the input system. Okay, so here we've got a right mouse button click. And when that happens, let's grab the mouse worm position. So vector 3 for mouse worm position, and we just go inside our mouse worm position class, access the static instance, and call get position. Okay, great. So with this, we have the mouse worm position. Now the goal is to tell our unit to move straight towards this point. So this is actually an excellent time to learn how we can interact with the dots world directly from the
mono behavior? No.
game object world. We already saw the opposite over here on the unit mover system. So this is an I system, this is a dot system. But on this one, we already managed to interact with a regular game object, a regular mono behavior. We just use a static instance in order to access it. Now here we want to do the opposite. We want to access the dots world from a mono behavior script. This one's going to be a little bit more complex. Basically, the goal here is to give the unit the target position, which means we want to find all the units, all the ones that have a unit mover component, and set their target position. So to do this, the first thing we do is create an empty query with all the components that we want to find. So it's really the same thing that we have over here. We're doing an empty query for various components. So over here, let's query for that. However, we cannot use system.api if we do this query for, let's say, the unit mover. If we do this, nope, this does not work. It says you may not use system API outside of a system. Basically, this system API, this really useful class, this one can only be used inside of systems. So over here, since we are outside of system, we need to do do something a little bit different. We need to manually create the query with another method. So what we can do construct a brand new entity query builder. Yep, this one right here. This is how we can build queries. Now this one takes in a parameter for an allocator, and a bit strangely enough, it is not exactly this type, or the type that we're going to use. The one that you should use is called allocator. It is this one right here, the one that exists inside Unity.collections. Let's go ahead and use this one. Now allocators are very important. They are basically defining the lifetime for the memory that is going to be used by this object. It is very, very important that you choose the right allocator so you don't end up with memory leaks. Over here, the main ones you're going to be using are either persistent or temp. Now, for example, here, if you were to make it persistent, then Unity will reserve some memory for this object, and then it will keep that memory around until you manually dispose of it. So if you were to make something persistent and then you do not dispose of it, then over here we would be creating a new object. We would be instantiating new memory, doing that every single time we press the mouse button. That would essentially end up with a memory leak and the game would eventually crash. So if we were to use a persistent allocator, then we need to make sure to clear the memory. But we have other allocators, and the important one is over here, temp. This one is going to be the shortest one. This one is going to be automatically disposed at the end of the frame, so you don't need to manually dispose this one. In general, you should always pick the smallest allocation possible. It is more performant to make a temp allocation as opposed to a persistent allocation. So while technically over here we could use either one, we could make it persistent and then dispose of it, or alternatively we could make it persistent and then cache it inside a field. Both those options would work, but using these
I think I'd want persistent because persistent means that I don't need to, I can do it once. And then I assign the query because it's not like the truck is changing.
super simple temp. This one, like I said, is automatically deallocated. So in this case, where this code isn't insanely performance heavy, for this case, using temp makes it work perfectly fine whilst being quite a bit similar. So let's go ahead and use the temp allocator. Okay, with this, we have created the new entity query builder. And now with this one, we can do similar to what we did on the system API query. We can add the components that we want this query to include. So let's call the function with all to include all the components that we want to include inside of this entity query.
For what he's doing, it does make sense because the information is temporary because your unit count is changing. Yeah. So with the temp, because he needs the query to update. Yeah. Because he needs the query to be able to update, right? He needs a temporary one because he'd have to check every time. Where because I don't need it to ever, like, I only have one driver. It's not an issue.
In this case, we only want to set the unit mover target, so let's just grab the unit mover. And that's it. Here we have a valid entity query builder, but like name implies, this one only builds an entity query. It is not an entity query itself. So after defining all the components that we want to use, afterwards, let's call the build function, and this is what will actually create the final entity query. And this one takes in a parameter for an entity manager. So this means we need to access the entity manager for our world. And the way we get that is actually quite simple. We can access the world class. This one exists inside Unity.entities, and then inside that one, we have the default game object injection world. Basically, Dot can have multiple worlds. This is how, for example, Dot's multiplayer works. You have a server world and a client world. So in advanced use case, you can create multiple worlds and do some really complex things. But by default, it is always going to have the default game object injection world. This is the world that we've been working on so far when we constructed the new subscene inside of our hierarchy.
I feel like the answer actually might be our what you considered first, which is just have like a object that represents it and just not rendered, and that just be the have the mesh and just don't render the mesh, and have that sit over top of the player in dots, and then it drives around and destroys things.
All the objects over there that are going to be baked inside of this one world. So we can access this default world, and then inside of it, we can indeed access the entity manager. So let's grab the entity manager, just store it, entity manager, and it's exactly going to be that one. And then over here, we can start the query with all of our components. So we want the unit mover component, and we build an entity query, and it's going to be the entity query for our entity query. All right, yep, that's it. So here we have our final entity query that we want to use. Now all we need to do is really just cycle through it. Now there are two main methods for cycling through an entity query. If we go inside the entity query, inside we see the functions. There was one called.
I don't know if dots does raycasting. Unity dots raycast. I think that manager is probably going to be the thing. Look at that, joints. Single ragdoll unity. This is going to be important. Oh, look, it even has the it even has the truck. Yeah, there we go. It's under assets, right? Raycast car. Ow. Oh, this is scripts.
To entity array, like it implies this one will create an array containing all of the entities that match this query. It will have the objects of type entity itself. Or alternatively, the other one we have is two component data array. This one will return an array containing references to a specific data component. By the way, both of them, both this one and the two entity array, both these will return the same size. The entity query does not change. So this means that we can actually cycle through one of these arrays, and using the same index, we can either access the entity or we can access the component data. So if you had a query with multiple component types, and then you want to cycle through those multiple component types, you would just call this function multiple times for each component type you want, and then again, everything will be on the exact same index. Now in this case, we really just want to update the type position on our component. So let's use two component data array and grab the unit mover. Yep, just like this. Although one very important thing here, make sure you're using this function two component data array, not the other one. There's also this one, two component array. This is not the one you want to use. This one is meant for working with classes and returns a normal array. The one that you want to use is this one, two component data array, which returns a native array, and this one does work with iComponent. So don't make this mistake, make sure you use the correct function. And yep, so this one is going to return a native array of our component type, so native array of our unit mover component. So let's call the unit mover array. And since this one is going to construct an array, because that we need to actually input the parameter, and again, it's going to be our allocator. So again, same thing that I said a while ago, you can use whatever allocator you want, but in most cases you probably want to use temp. Okay, so yep, so this is going to return an array that contains all of our unit mover components. And again, note how it is not a regular array, so it's not a unit mover array like this. Nope, instead we have a native array. Now this is a type that exists inside unity.collections namespace. This is similar to the normal C# array, but this one is made specifically to work with dots and burst, whereas normal C# arrays, those are objects, so you cannot use those inside burst. You can use native arrays directly in there. Okay, so with this we have our unit mover array. Now this is going to work just like a normal array. So let's do a cycle through it. Let's do a for int I equals 0, while I under the unit mover array.length I plus plus. And the reason why I'm using a 4 instead of a 4 each is just in case in the future we want to use that index to go through either the empty array or some other component. So okay, so with this now we can grab that component. So we can grab that one on this index, and that's going to be a unit mover. Yep, here we are reading the component, and now let's just tell this unit to go towards this position. So that means we also need to refactor our unit mover component. We need to have some kind of target position. So let's make another field, make it a float3, since this is a position for our target position, and float3 exists inside of the unity.mathematics. So let's go ahead and use this one. In this case, we don't need to add it to the authoring component. This one is going to be set manually through code, and then over here on the unit mover system, instead of defining this target position, instead of that, let's just go inside the unit mover component, read it, and read the target position. So yep, now this unit should be moving towards this target position, and over here back in our selection manager, on this one we can just go inside the unit mover, set the target position, and set it to the mouse run position. All right, yep, like this. Let's go ahead and test. But before you do, I want you to pause the video right now and ask yourself, will this work? Will the unit actually go towards the mouse run position when we right click? Just pause the video and think about it for a second. Okay, so let me just save all the files, make sure.
It is a hard maybe. I'm thinking yes, but I'm guessing no.
Let's wait for compilation to finish, and now let's test. So let's hit on play. Okay, the unit is going to 0, 0. Let's just ignore the rotation. Now I right click, and nope, nothing happened. Target position is not changing. I can inspect the unit and go over there onto the runtime mode, and we can find our custom unit mover component. There it is, and yep, target position is on 0, 0, 0. So even as I right click, nope, it does not change. So the problem is right here. I wonder if you managed to notice exactly what the problem was. So the issue is, once again, here we are working with structs and not classes. It's a whole thing about value versus reference types. Here, when setting the target position, when we do this, we are just modifying this copy. We are modifying the copy stored in the array, and note how this is not a value RW. So like here on the move system, the reason why we can modify the fields inside of it directly, like for example here, the local transform modifying rotation, the reason why this works is because we are using the special type, the ref RW. But over here on this code, we just have the normal unit mover type. This is not a reference to anything. So over here, we are just getting a copy. By modifying this one, we are just modifying the copy and not actually modifying the data that's stored in the entity. So this is why the unit was moving, this is why it wasn't updating. If we do want it to update, then we need to modify it, and after we modify it, we need to save that data back onto the entity. So one way to do that is to access the entity manager. So let's access down the entity manager, and then we call the function set component data. This one takes in an entity, so let's actually get the entity as well. So let's go inside the entity query, and inside that one, let's call to entity array. Once again, let's use the allocator.temp. This one is going to return a native array of entity for our entity array. And now with this one, like I said, it's on the same index. So in order to update the component on this same entity, let's access the entity array on the same index, and we're going to set it to this new unit mover component. So here we grab the unit mover, we are grabbing having just a copy, then we are updating type position just on that copy. And finally over here, we are actually updating the value directly stored on the entity. So yep, like this, let's save. And over here, the game's playing, I right click, and yep, now it does work. Right click, and yep, down there we can see the type position. That one is indeed updating as I right click. Okay, great. So as always remember how when working with structs, you are usually dealing with a copy and not the original data. So if you do something like this without using the special refr double type, without that, you are likely working with a copy. So if something does not change, if something does not happen as you intended to, always think about this because this is probably the problem. It is probably because you are modifying a copy and not the original position in memory. Okay, so this code is working, but let me also cover one sneaky issue here. So here we are reading the component and then we are updating it. But technically, we could remove this. We could get rid of this, and then over here just create a brand new unit mover component, and inside set the target position equals our mouse wheel position. So yep, this technically looks like it should work, and it should also be faster because we are not spending any time reading the component. We're just cycling through it and just setting it to new target position. However, let's see, does this actually work? Let's test. So here we are, and I right click, and nope, it does not work. Or rather, actually, it did work. If we inspect the unit, if we scroll down and we look inside the component, yep, it did update the target position. So if I right click, you can see that one is indeed updating correctly. However, the issue is that while the target position is being correctly set, over there the move speed and the rotation speed, those are being left on 0. This is yet another very important thing you always need to keep in mind. So over here, when we construct a new instance of this type, like this, we only gave it a value for the target position. We did not explicitly assign a value to the move speed or the rotation speed. And if we don't do that, then those fields are simply going to default to 0. So that's what happened here. This is another thing you always need to remember, always need to be aware of. If you only want to update a single thing inside a component, if so, then instead of constructing a brand new component, instead of that, you should do what we were doing a while ago. So you should first read, then update, and then update the data. So first here we are reading, we are updating the copy, and then we are saving that copy directly onto the end. This way you can modify just one field, and it's going to keep whatever other data is inside of this component. Also, just one more note here. So this code is working. It updates the target position and does save it on the entity. In this case, this is perfectly fine since this code is not going to run constantly. This is only going to run whenever we right click on our mouse. But technically, over here, we are writing to our component for every single entity, meaning if we have 100 units selected, we are going to call this function set component data 100 times. Like I said, in this case, it's perfectly fine because this code is going to run pretty regularly. But if you really want maximum performance, if so, then another alternative to this is we can cycle through the unit mover array. We can update it with new target position, and then over here, we do not set the component data. Instead, we just save the new unit mover directly on the array. Again, we need to save it back, otherwise we are just working with a copy. So we are updating the data that is stored inside this array, but by itself, this will not update the entity. This is just modifying this local array. But if we do this, which is going to be pretty fast, after this, we can go inside the entity query, and inside this one, there's a really nice function called copy from component data array. This one takes in a nav array, so we can pass in our unit mover array. And if just like this function over here, this will basically update a normal array. So let's do a cycle through it. Let's do a 4, and we are reading the component 3, since this is a position, and go over there onto the runtime mode. It's not a time. Then we need to modify the same index. So now we are reading the component and then we are updating it. But technically it looks like it should work, and it should also be fair. And I right click the target position, so if it's on 0. This is yet another very important thing, or the rotation speed. And if we don't do that, then those fields are simply going to, instead of constructing a brand new component, feed directly onto the end. You should do what we this way you can modify just one field, and it's going to keep whatever other data is inside of this component. Also, just one more note here. So this code is working. It updates the target position and does save it on the entity. In this case, this is perfectly fine since this code is not going to run constantly. This is only going to run whenever we right click on our mouse. But technically, over here, we are writing to our component for every single entity, meaning if we have 100 units selected, we are going to call this function set component data 100 times. Like I said, in this case, it's perfectly fine because this.
So batching it at one time.
Code is going to run pretty regularly. But if you really want maximum performance, if so, then another alternative to this is we can cycle through the unit mover array. We can update it with new target position, and then over here we do not set the component data. Instead, we just save the new unit mover directly on the array. Again, we need to save it back, otherwise we are just working with a copy. So we are updating the data that is stored inside this array, but by itself this will not update the entity. This is just modifying this local array. But if we do this, which is going to be pretty fast, after this we can go inside the entity query, and inside this one there's a really nice function called copy from component data array. This one takes in a nav array, so we can pass in our unit mover array. And if just like this function over here, this will basically update the data on all the components that match this entity query. So instead of doing
Oh, I see what he's doing. Yeah, so instead of making the round trip for every single object, we're doing it once. It's just batching.
one write instruction per each entity. Instead of that, we update all the data inside this array. And then at the end, after doing all that, we do pretty much just one write instruction. And just that one is going to update all the entities with all the data inside of this array. So now if we test, everything should still work the same. So here we are, and I right click, and yep, it does change position. It does move. Everything works perfectly fine. All right, awesome. Now just for fun, let's duplicate our unit and test with a whole bunch of them. So here, let's just manually duplicate them a bunch of times. Let me select the unit. So just put one over there, and so on. By the way, this is really just a temporary test, so that is why I'm not bothering to make this unit into a prefab just yet. We're just doing a simple test. Okay, so with this, I have a bunch of units. Let's hit on play. And if they are moving, and I right click, and yep, they all go there, down there, and so on. They are all following the target position, so I can give orders to all of my units. Again, that's the whole thing about dots. It applies the same logic to all the entities that match the query, regardless of how many entities you have. All the ones that have that query are currently getting the target position assigned, so they all go towards there. So with this, everything's working great. Now, if we leave them on a target position, they still get a little bit messed up. That is because of the physics. They're constantly trying to go to the exact same position, so things get a little bit messy. We're going to solve that later on when we implement some stopping logic and multiple move positions and collision avoidance and so on. We're going to handle all of that in the future, but so far everything's working pretty great. We can click and all the units go exactly where they're supposed to. And in this lecture, we also learned the very important concept of how not everything has to be dot based. You can make some dot systems and you can make some model behavior systems. Everything works fine. We also learned how to interact with the dot swirl from the normal model behavior world. So we've already learned quite a lot over here. Let's just remove these testing units. Okay, they are working fine. All right, let's just leave it with one. And right now, our game, our basic logic, all this is working good. But so far, we're only been using the main thread, so we're not yet taking advantage of all the massive power that dot brings. Now that the move code is fully working, now let's learn how to use the job system and burst in order to make this move code insanely fast. So let's learn how to do all that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to create a job and use burst so our movement code is insanely fast. We're going to look at the results before and after to see the really massive difference that it makes. Okay, so here we have our unit. I can right click and tell it to go to some position. So yep, everything does work. And here we have our unit mover system. So all of our logic is over here on update. We're doing a simple for each, cycling through the query, meaning that all of this code, all of this is running just on main thread. So for example, if we have a CPU with 16 cores, then 15 of them are going to be completely idle, doing nothing, just wasting time. Only one of them is actually going to be working. Ideally, we don't want that. Ideally, we want all the cores in the entire CPU to be doing some work so our game is as performant as possible. Now, in order to write multi-thread code, we could use normal C# code. We could manually create threads and give them tasks. But like I said on the lecture on what is not, writing good native multi-thread code is extremely difficult and it is very easy to make all kinds of mistakes. So thankfully, Unity has has created the job system, which makes that process much easier. So let's see, how do we create a job? Now, first thing we do is define a struct, and we can define it anywhere, but it makes sense to define it next to the system where we're going to use the job. So here on the exact same file, let's define it. Although if this were a job that would be used in multiple places, then we would probably define it in a proper file. But this unit mover job, this will only be used over here by unit mover system, so it makes perfect sense to define it right here. Okay, so let's define a struct. So that's the first thing. Then jobs are also going to have some source generation, so let's make sure to define it as a partial struct. Then we use a name. Let's call it unit mover job. Personally, I like to append job to the name, but again, not a requirement. And now finally, we implement an iJob interface. Now you can just write iJob, and you can see all kinds of interfaces you have. These are all going to run slightly different. Remember how I said that all the components that make up dots do not have to be used together all at once. So you can write multi-thread code with the job system without using entities at all. In those scenarios, when not using entities, when just doing some random normal multi-thread code, for that you'd use either iJob or iJob4. Those are the two main ones. But when working with entities, for that we have the super useful iJob entity. This one is going to be really easy to use. Technically, we also have iJob chunk. This one is also related to entities, but this one is for more advanced use cases. It is more performant, but requires you to do a little bit more setup. Whereas the iJob entity, this one runs super fast and is really easy to use. So let's use this one, iJob entity. Let's go ahead. Now for this work, we really just need to write a void execute function. So just like this, and on this function, on the parameters, over here we include whatever components we're going to need. So let's copy exactly the same query that we have up here. So we need the local transform, the unit mover, and the physics velocity. So let's add those. So local transform. Then we have the unit mover, and finally the physics velocity. Okay, that's our three components. And is really easy to use. So let's use this one, iJob entity. Let's go ahead. Now for this work, we really just need to write a void execute function. So just like this, and on this function, on the parameters, over here we include whatever components we're going to need. So let's copy exactly the same query that we have up here. So we need the local transform, the unit mover, and
This makes sense.
the physics velocity. So let's add those. So local transform. Then we have the unit mover, and finally the physics velocity. Okay, that's our three components. And now here we also need the same thing that we defined up here. We need to define them as either read write or read only. However, down here on the job, this one uses a different syntax. Although actually, technically, you can use the same syntax, so you can use refrw. Technically, you can use this, but the Unity docs, they recommend something a little bit similar. So instead of using that, if we want to make something as read write, for that we write the ref keyword. This is the ref C# keyword. This one basically means that this field will be received as a reference. And since it is received as a reference, even though this is a struct, it means we can write to it. And then if we want something as read only, like for example the unit mover, we only want to read this one. For that we use the in keyword. So yep, ref for the local transform, so we can modify it. In for the unit mover for read only, and for the velocity we want to write to it, so let's make it as ref. Okay, yep, just like this. Again, technically you can use refrw and refrw and it won't work, but the docs recommend this syntax instead. So like this, we have defined our execute method, and basically when we set the job to run, it will automatically create a query with all of these components. It will do all of that just like the system API up here, and we'll run the execute for each entity that matches that query. So now our goal here is to do literally the exact same logic. So let's just copy the same code. So just copy it down here, paste it, and the only difference over here, we don't have the refrw or refrw, so we don't go through the value RO. Instead, we just modify directly. So just get rid of this, this one, and this one. Okay, so yep, so here we have exactly the same code, and the other difference is what we see here, we have an error, and this is actually the general limitations that exist inside of jobs, meaning that jobs mostly have to be self-contained, meaning they cannot access data outside of it. Now, technically you can pass in a array and then access different positions in memory and stuff like that, but in general, jobs are self-contained, meaning they need to have all the data that they need in order to execute their function. Now, this limitation of jobs being mostly self-contained, this limitation is actually what helps write super fast multi-thread code without causing all kinds of chaos. If the job only works on data that the job has, then it's super easy to make it run parallel in multiple cores at once. So the error that we have here is because we cannot access the time.time from here, and the way we solve this is super simple. We basically just define a field on the job. So up here, let's just find a public float delta time, so just a perfectly normal field, and then down here, instead of going through system API, we just use that field. So that's it, no more errors. So now basically when we construct our job, we simply need to assign the delta time and everything will work perfectly. So let's actually do just that. So up here on the on update, let's construct a brand new job. So a unit mover job, let's call it unit mover job, and construct a brand new unit mover job. And now inside of it for delta time, over here we can indeed access system API .time. And so that's our job all set up. Let's make sure to comment out the other random query code. Okay, so up here we have defined our job. Now all we need to do is really just run it, and we actually have multiple ways of doing that. Now the most straightforward one is go for the unit mover job and just call run. Now this one will run the job directly on the main thread. So this kind of was the main point behind jobs. You should probably only use this one just for testing or debugging. Essentially this will end up pretty much the same thing as we had previously. The main goal of job is to make multi-thread code. So usually the one that you want to use is one that's called schedule parallel. This one will schedule the job to run on all the entities that match the query in parallel. Meaning if you have lots of entities, it will run the job on multiple threads at once, and each entity will be responsible for updating a few entities. Although quick note, just something to keep in mind, which is actually something that I only learned after doing a bunch of research. This one, schedule parallel, this will split the logic in multiple jobs based on the number of entities. So this is real perfect if you have tons of entities doing some logic, but if you have just a handful of entities, so if you don't have many but you have a complex job, if so, they're likely all going to run on the same thread because you don't have enough entities to split it. So just keep that in mind, that's how the job system works. If you have some really super complex logic, but you're only running it on a handful of entities, if so, then this will basically run just on one thread. So in that case, you probably want to split the logic into multiple jobs yourself. Okay, so just with this, we can test and see that it works. So here's our job, we construct it, we schedule it, and let's comment out the rest. Okay, let's save. And over here, let's hit on play and try to move the entity, and yep, everything still works perfectly. All right, great. So the unit is still moving exactly the same, except now it is moving using a really nice job. By the way, what we just did here is actually what we're going to do a lot throughout this course, and what you should probably do when building any kind of new system. First, make it work just with the normal for each, just with normal main thread code. First, get it working like that, and then once you have that logic working, then you refactor it into a super fast job. Okay, so this is working. However, we still have one thing missing. We're currently not using burst. Now, adding burst is thankfully super simple. All we need to do is up here on the job itself, let's add the attribute burst compile, and yep, that's it. That is literally it. Just by doing this, our job will now run with burst enabled, which is going to make it insanely fast. So let's save and let's test. Just also here in the entity, make sure you go into the menu, burst, and make sure that compilation is enabled. If you disable it, then even if it has that attribute, it will not use burst. So make sure this is enabled. Let's test. And there you go. Everything still works fine. Now let's actually see the difference that all of this makes in real terms. Now this code that we have here, this one is really simple, so it is going to run insanely fast no matter what. So it's actually a little bit tricky to see the results, just because again everything's going to be insanely fast. For a test, I'm going to duplicate this unit a ton of times. And before I do, let me just get rid of the capsule collider, just because right now we really only want to test our movement code, not any physics system. Just make sure that it's still working. And yep, it still moves. Okay, great. So now I'm going to duplicate this into a ton of units. Okay, so here I duplicated 10,000 entities. Now my Unity editor is a little bit slow, so to make it a little bit faster, let's use the power of dots. Let's close the subscene for editing. And again, now everything is being baked into super fast binary data. So now there it is, and now the Unity editor is working a little bit faster. And we can verify that we have 10,000 entities. So let's hit on play, and down there we can see, yep, the Unity mover system is working on 10,000 entities. Okay, great. Now over here in our code, let's make it run the slowest possible. Let's use the normal for each without jobs. So let's actually comment out this one right here, comment out the job, and let's uncomment out the for each. Okay, so we're going to use the normal code. Let's save this. So we are not using jobs, and also let's go up here and make sure to not use burst. Okay, now for seeing how fast it goes, let's go into window, then go into analysis, open up open up the profiler. So here it is, and I'm going to hit on play and capture a certain frame. So they're all moving, capture frame. Okay, here it is, and let's see how fast it is. And yep, here we have our unit mover system in total running on 10,000 entities, and it is taking 9.13 milliseconds. Okay, that's great. And right now it is not multi-threaded, so we can see down here all these threads, all these jobs, all of them are empty. So this is where we can see all the threads that I have on my PC, all of
We're
these
like
are completely idle, just wasting a ton of
halfway
time.
there already.
Whereas only the main thread, that's the only one that's actually running this logic. So this
We almost have the system.
is normal C# code just running on the main thread. Okay, now back in code here. Now let's enable jobs. So let's go ahead, comment out the system, and let's enable our job like this. So let's see with this. Although here, let's also make sure burst is disabled. Okay, burst disabled, just using jobs. Let's play. And now let me move them and select a certain job. Okay, so here's a frame, and now got to zoom in in order to actually find it. And yep, it is actually right here. I had to zoom into the maximum in order to find it. Like I said, the code is super fast. So even though we have 10,000 entities, right now it is running on 0.01 milliseconds as opposed to the 9 milliseconds we had previously. Now over here we can see our jobs. So we can see all of our worker threads, and we can see all of them. Yep, the code is being split across all of these threads, and all of them running at the exact same time. So because of that, previously we were taking 9.1 milliseconds, whereas now if we add them all together, 30 instances.
The question is, like, how insane will I be able to get this to work on my system versus how insane, how much less it would be on somebody else's system? Because I have an unfair advantage when it comes to threading. My threading is insane. I'm running a 32 core Threadripper with 256 gigs of RAM. So I have a lot of threads. I've got it works out to be 64 threads. Available threads. Actually, I wonder what that looks like in Windows 11. The performance, CPU. Yeah. It's not as cramped looking as it used to be. Wow, I'm like using no memory right now. Yeah, this computer's a bit of a beast.
Over 30 threads in total, it is taking 8.3 milliseconds, but in reality, it's just taking 0.3 milliseconds. Because again, all of this is all working at the exact same time. So as opposed to having just one thread and running all the logic for unit A and then unit B, instead of that, both threads are working at the exact same time. So within the same amount of time, they are running twice the amount of work. So right away, you can see the huge improvement you get with
Maybe. What are you running that you think has a memory leak?
multi-threaded code. By taking advantage of all the cores in the CPU, your code can become massively faster. Like it's not literally just 2 times faster or 3 times faster, but literally over 10 or actually over 20 times faster, from 9 milliseconds to 0.3 milliseconds. And now for the final piece of the puzzle, let's enable burst. So over here we create the job, and over here we make sure we add burst compile. Then in Unity, let's go into jobs and enable burst compilation. Okay, that's it. Let's hit on play again, and now let's find. And you can already see over there in the graph how quickly it moved. Now I need to zoom all the way out and then all the way back in. Okay, let's see if I can find where it is. Okay, I found it. So right here for scheduling the job, this one is pretty much as fast as it was a while ago, which is pretty much instant. So scheduling the job just takes 0.014 millisecond. Again, keep in mind these are milliseconds, not seconds. It is taking 0.01 milliseconds. So with burst enabled, scheduling a job is pretty much instant. Now let's see if I can find exactly where the job is being executed. And it's actually over here. And here is the job, and we can see all of them running in parallel. And by burst, we got yet another 10x performance improvement. With just the job system, it was taking 0.29 milliseconds, and on burst, it is taking 0.035 milliseconds. Like it says here, the total amount of time is 0.84, so that's the total amount of time, but since it is running in parallel, the whole thing runs in 0.03 milliseconds. By the way, the green color over here, that's how you can easily see which things are using burst and which are not. Green means burst. So here you see the insane power of dots. Honestly, no matter how many times I see it, I can't help but be impressed. As long as you follow the data-oriented design and you keep in mind some limitations, as long as you do that, your exact same code can run multiple times faster. And again, it's not just 10%, 20% faster, or even 100%. No, it is 10,000% faster. It really is insanely impressive. Watching these results always impresses me. So originally, our code running on a single thread, that one was taking 9.13 milliseconds. Then we added multi-threading with the job system, and we got it down all the way down to 0.29 milliseconds. And then finally, we enabled burst, and in the end, the exact same code runs in 0.035 milliseconds. So we went from 9 milliseconds to 0.03. I don't even know how many percent that is faster, but it's something like 300 times faster, again, for the exact same code doing the exact same logic. And again, what I mentioned a while ago, what we did here is what we're going to do throughout this course and what you should do, meaning get your logic running just on the main thread, just using a for each system query, get it working, then refactor it to use a job system, apply burst, make it schedule as parallel, do all that, and all of your code will run insanely fast. Okay, so yep, everything worked. Let's just clean up our testing scene. And by the way, here we can see all the units. Really nice to see 10,000 units, all of them moving for the same place. Okay, great. So now let's clean up this test. We really don't need 10,000 units just yet. So I'm opening up the subscene, gonna select all of them and get get rid of all the units except for one. And yep, we're back to having a single solitary unit. Press on play, and yep, everything still works perfect. Let's just make sure we remember to re-add the capsule collider. So the capsule collider, let's put it on y of 1.1, radius of 0.5, okay, and height of 2. Okay, our unit is back. Now, just before we end this lecture, let's do just one tiny thing. Let's add some simple stopping logic. So right now, if I hit on play, you can see the unit gets a little bit bugged. That's because it's constantly trying to go to the position 0, 0, but the unit is already on there, so it gets all messed up. Thankfully, adding some stopping logic is actually quite simple. So over here in our job, we are calculating the move direction, so the target position minus the current position. And now, before we normalize this vector, before we do that, then this vector actually has a size. It actually has a length. So we can grab the move direction.length, although actually it's not done like this. We go math, we use math.length, and we have either length or length square. This is actually an important thing, and it's yet another performance thing. Basically, the way the actual length is calculated by doing that is first by calculating the length square, and then by doing a square root on that value to get the final length. Now, doing a square root, that is a relatively expensive process. So if you don't absolutely need the actual value, then really just use a square. In this case, we don't really care. We just want to compare if it is close enough. So we can just test for a squared value. So let's use this one. That is super fast. So we get the length of the move direction. Then we really just want to check if it has reached the target position. So let's define a float for a reached target distance squared, and let's put it at something like 2 units. Then we simply do an if the length of this vector, if it is under this amount, then we have reached the target position. And if we have reached, then we simply just want to stop moving. And the way that we do that is super simple. We just set the linear velocity back into 0. So for this one, float 3.0. We set that, and of course we stop executing. So let's add over here a nice return. Okay, so yep, that's it. The unit should now be stopping. So let's test. And here we are in right away. We don't see that bug. If I click and move, go there, and yep, it does stop as it gets within a certain distance. Okay, great. All right, so here we learn how to convert a normal main threaded system into a super performant multi-threaded burst compiled system. This makes our movement code super efficient. But so far, we have no control over which units we want to control. Right now, we're just using the same unit or all the units at the same time. So let's handle a way to select our units individually, and let's do that in the next lecture. Hello and welcome. I'm your CodeMonkey. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to handle the logic for selecting just one unit. And the way we're going to do that is with a raycast. If it hits a unit, then we select just that one unit. So this means that we're going to need to learn about how to do physics queries using dots. Okay, so we already have the selection area working. I can select a bunch of units, do a little square, and select all the units within that area. Then I can just give them orders, something like that. However, we cannot easily just select just one, so I click on this one. Nope, doesn't work. I need to do at least a select square in order to be able to select. So let's tell this. Let's use physics and a raycast to test for single unit selection. Now, physics and dots is actually surprisingly easy to use. But before that, first let's add some logic to test when should we use physics, meaning how to define when the player is trying to select just one unit versus selecting multiple. For that, essentially, we can check the size of the selection area. So if the selection area is at least a decent size, if so, we're going to engage the select multiple mode. But if it is small, like something this tiny, if so, then we're going to select just one single unit. Okay, so let's add that logic. Now first, let's deselect all of them. Okay, that makes sense. So we handle all of the deselection, and then for selecting, let's grab the selection area rect.
Oh, wait. So he's pushing data. So maybe I should go back to this.
Hello and welcome, I'm your CodeMonkey. In this state and towards the target position, it goes there perfectly. It works with one unit and also works with multiple units. All of them go towards the target position. Now, before we make some duplicates again, it's really time to make this unit into a prefab. So first of all, let's keep things like we don't have any issues with it, but that's actually a problem. All of them are moving. Now in an RTS game, you really want the player to be able to control which units to move instead of just our authoring scripts. And this one already has a Baker script. So let's see this one, just see what this template has. Let's call this the selected authoring. Okay, let's open and see. All writing process, or we can go over here into entities, and this one already has a Baker script. So tagging units, we have multiple options. The first one is with a simple component tag. Let's create one, just see how that works. So in our authoring scripts folder, let's go ahead create. And by the way, for making a new authoring component, we can create a model behavior script and go through that whole writing process, or we can go over here into entities, and this one already has a Baker script. So let's see this one, just see what this template has. Let's call this the selected authoring. Okay, let's open and see. And yeah, this is what it creates by default. So it creates a model behavior class, and then creates a second, a Baker class, implements Baker, and the bake method. Now honestly, personally, I still prefer the format that I have over here. I think this one makes it look a little bit cleaner. So I've got the authoring class, it has the public, everything looks nice and proper. We've got the Baker class inside of it, and then the component down here. So technically you can use this template if you want, but me personally I prefer this format over here. So I'm going to basically follow this. So we're here on this one. First of all, I like to be explicit, so let's make it as public. Then we've got the model behavior. Then inside we've got the Baker class. I like to call this one just Baker and make it public. Okay, so yeah, but again, personal preference. Personally, I prefer this format. Okay, so now let's make our actual component. Let's make the usual thing. So this one needs to be a struct. Then for the name, let's call it selected, and then we implement iComponent data. And that's it. That's all it takes. Here we have just a tag component, meaning it's a normal component, a normal iComponent data, and it simply does not have any fields at all. It really just exists, so it can be used to tag objects. Then over here on the bake, we really just set it. So let's grab the entity. Let's call get entity, and for the transform usage flags, let's default to
Yeah, no, it is kind of nice.
using dynamic. Okay, then we call add component. We're going to add a component onto this entity, and it's going to be a new selected component. Yep, that's it. Super simple. We've got our authoring component, we've got the Baker, and we just add our component, which does not have any fields. So this one is just a tag component. Let's go ahead and save this. And now let's add that component to the unit. And also again, make sure you select the prefab so that it applies to all units. So don't add it to just one of these units. Let's add it to the prefab itself. So over here, let's drag the select authoring component. Yep, just like that. And just like this, we can already see what that does. So let's select one of the units inside of our subscene. This one, yep, does have the select authoring. And on the inspector, let's swap it into runtime mode. And right here up top here, we have a section for tags, and you can see, yep, here we do have our selected tag. Okay, great. So this is how tags work. Tags are
Wait. What did I just
so yeah,
miss?
but again, personal preference, personally, and that's it. That's all it takes. Here we have just a tag component, meaning it's a normal component, a normal iComponent data, and it simply does not have any fields at all. It really just exists, so it can be used to tag objects. Then over here on the bake, we really just set it. So let's grab the entity. Let's call get entity, and for the transform usage flags, let's default to using.
Oh, I see what's going on. So because it's a struct that we're able to attach to it, it acts like a tag. It has no data, but it acts like a tag.
Dynamic. Okay, then we call add component. We're going to add a component onto this entity, and it's going to be a new selected component. Yep, that's it. Super simple. We've got our authoring component, we've got the Baker, and we just add our component, which does not have any fields. So this one is just a tag component. Let's go ahead and save this. And now let's add that component to the unit. And also again, make sure you select the prefab so that it applies to all units. So don't add it to just one of these units. Let's add it to the prefab itself. So over here, let's drag the select authoring.
Yes and no. The gas tag system is a bit different.
Component, yep, just like that. And just like this, we can already see what that does. So let's select one of the units inside of our subscene. This one, yep, does have the select authoring. And on the inspector, let's swap it into runtime mode. And right here up top here, we have a section for tags. And we can see, yep, here we do have our selected tag. Okay, great. So this is how tags work. Tags are really just empty components. They don't have any extra data, and they show up over here on this special section. So this is one way we could handle the selecting logic. And basically for selecting units, we would add this component. Then for deselecting, we would simply remove this component. Now, technically that
I didn't see how he attached it as a tag though.
would work. However, adding and removing components is what is known in dots as a structural change, and that is something you should actually avoid as much as possible because it is a quite expensive operation. Basically, the way dots works in the background is it creates what are known as entity archetypes. So an archetype is a unique identifier for all the entities in the world that have the same unique combination of component types. So for example, all entities in the world that have component types A and B, those share the same archetype, and then entities that have components A, B, and C, those have a different archetype. This is a really important thing to know. Dots in the background does a lot of work to place all those entities of the same archetype together in memory. Again, that's how it works so fast. But since the archetypes are based on a specific set of components, because of that, if you add or remove a component, you are going to be changing the archetype. And doing that, like I said, is what is known as a structural change. And like it says here, moving entities between archetypes, that is a resource-intensive operation and reduces the performance of your application. Essentially, when you do a structural change, like for example, you have types A, B, and C, and you remove the C, when you do that, then whatever entities used to have A, B, and C now just have A and B. So now those entities need to be copied onto the entity archetypes that have A and B. Basically, doing structural change requires lots of moving things about in memory in the background. This is a resource-intensive operation, so you should avoid using it as much as possible. So for this particular scenario, since we're going to be selecting and deselecting units quite a bit, for that, instead of adding or removing a component, which again would trigger a structural change, instead of that, we're going to be using something really awesome called enableable components. This is basically a component just like this, except it's as if it has just a boolean inside of it that defines whether it's enabled or not. But unlike just storing a regular bool inside one of these components, unlike that, if you have an enableable component, those can be used in many special ways without having to read the entire component data. Now, the way we make something as an enableable component is super simple. We literally just implement another interface. It's called enableable component. And if that's it, we don't need to add any extra data. Just by adding this, it already works. So let's go ahead and save. Let's wait for it to compile and then look at the entity. And if there it is, there's our selected component, and now you can see it does have a nice checkbox. This checkbox lets us easily either enable or disable this component.
How did he get it into the
interface? It's called enableable component. And if that's it, we don't need to add component data. Now that just by adding this, it already works. So let's go ahead and
is because it's empty, it becomes a
save.
tag.
Let's wait for it to compile and then look at the entity. And if there it is, there's our selected component, and now you can see it does have a nice checkbox. This checkbox lets us easily either enable or disable this component. And since the whole thing we're doing here is just flipping a boolean bit, we are not adding or removing components. So because of that, setting this to either selected or deselected will not trigger a costly structural change. Okay, so we have our nice enableable component. Now let's see how this actually works inside a query. So let's create a simple testing system just to test out some things. So inside the systems folder, let's right click, go inside the entities, and create a new iSystem called just testing system. Okay, so now here, let's get rid of the create and destroy. We don't need those. Okay, so now on the update, on this one, let's go inside the unit mover, and let's basically just copy the for each that we have here, just to copy basically that query. So let's copy and paste it over here. Okay, everything worked. Again, if you're seeing some errors, it's probably because your Visual Studio did not automatically write the using statements, so make sure those are all there and this works. Okay, great, except here we don't want to do any of this logic. Instead, let's just count the number of units that this query applies to. So let's do an int unit count, let's default to 0, then on the for each, let's increase it ++, and finally do a debug.log, and let's print out the unit count as something. And by the way, this is actually an error that happens every once in a while. Basically, when I wrote debug, instead of implementing Unity Engine, for some reason, Visual Studio is defaulting to importing this class, system.diagnostics. That is not the one that we want. We want the debug class that is inside using Unity Engine. Kind of like that, and we have the normal debug log. Okay, so let's run.
It has to be tag based on the interface. It in I probably missed something there.
Run this and see how many units have all of these components. It should be the same number of units. And up here now we can see we have 8 entities that match those components. And here we can see, okay, we have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, great, everything's correct. Now let's include our enableable component inside of this query. So one way to do that is to literally include it in the query. So over here, let's add another component. We're going to go with ref ro, and let's choose the select component. Then let's also add it up here for the selected. Okay, yep, like this, let's test. And again, this burst error is normal. That's because we are doing a log on that value. But again, it's just a burst error query. So one way to do that is to literally include it in the query. So over here, let's add another component. We're going to go with ref ro, and let's choose the select component. Then let's also add it up here for the selected. Okay, yep, like this, let's test. And again, this burst error is normal. That is because we are doing a log on that value. But again, it's just a burst error, so let's ignore it and play. And if it still says the exact same thing, by default, the component is going to be enabled, so it makes sense that it still says the same number. Although actually, we can modify this. So over here, we can add the new select component, but if we wanted them to default to being not selected, for that over here, we can call set component enabled. This one pass in the entity, so our entity, and then let's set it as false. And for passing the component type, we just need to use generics, so pass in the select component and set it as false. So let's save. And yep, now they show 0 units. And if I select one of those units, and over here on the inspector, make it in runtime, and we can see over here it's selected, and we can manually toggle this box. And as I toggle, if they go down goes to 1, toggle again, and goes down to 0. So yep, that works. And again, remember, one very important thing is how whether this one is toggled or untoggled, the entity still has this component. It still belongs to the exact same archetype, except now this component is simply marked as either enabled or disabled. And by seeing the number 0 here, we're actually already seeing another interesting thing. Over here in our query, we're querying for everything that has a select component, but note how if it is disabled, this one actually says 0. That's because this query over here, when we query for something with a select component or any enableable component, when we do that, that entity is only included within this query if that component both exists and is enabled. So if the component is disabled, this code will not run for that entity. It needs to be present and needs to be enabled. Alternatively, if you want to query for entities that have a enableable component but have it disabled, if so, then instead of this, let's get rid of that one and this one right here. Okay, back to what we had previously. Now we can add the option with disabled and pass in the component, so selected. So let's select this. And yeah, there it is, 8. Now that query is only included entities that have that component disabled, and right now by default all of them are disabled. If I set this one as enabled, there you go, now it says 7. So like this query will only apply to entities that have the component and have it disabled. If it does not have the component or the component is enabled, if so, then it does not run this logic. And yet another thing we can do is simply query if the component exists on the entity. So for that, we can use with present. Let's see. And yeah, there you go, now it is saying 8. And if I go into one of these and I set it as selected, yep, it still says 8. So the entities are being included within this query, regardless of the state of the actual component. Enabled or disabled does not matter. As long as the component exists on the entity, it is included within this query. So these are the various options that we have for dealing with enableable components. As we go on in this course, we're going to use quite a lot of these options. So now that we can actually select the units, now let's actually use that selection logic within our move logic. Now, thinking like we saw, it's actually super simple. Let's just go over here on our testing system and comment this out. Let's leave the file created just in case we need to do some more testing in the future. And now let's go over here onto the unit selection manager. This is the code where we are giving orders to our units. And over here for the query that we are constructing, we are just looking for the unit mover component. So in order to be able to give orders just to select units, that's super simple. Just add a comma and let's also include the select component. And again, like we saw by default, this query will only include entities that have the component enabled. So that's exactly what we want.
Yeah,
and just like this without modifying anything else, it should already be working. This query will only include query that. Let's leave the file created just in case we need to do some more testing in the future. And now let's go over here onto the unit selection manager. This is the code where we are giving orders to our units. And over here for the query that we are constructing, we are just looking for the unit mover component. So in order to be able to give orders just to select units, that's super simple. Just add a comma and let's also include the select component. And again, like we saw by default, this query will only include entities that have the component enabled. So that's exactly exactly what we want. And just like this, without modifying anything else, it should already be working. This query will only include entities that have both the unit mover and a select enable. So then OnLogic over here just runs within those entities that match that query. So let's test. Okay, here we have our units, and if I right click, and nope, not a single one of them moves. Okay, that's great, that's exactly as intended. Now if I select just one of them, let's say select this one, over here on the inspector, I'm going to manually set it as selected. And now I right click, and there you go, now just that one unit moves. Just one that is selected, that is the only one moving. Now if I go select a different unit, now mark this one as selected, and click, and
I do that same thing where I speed up any video I watch, except if the person doing the explanation has a strong foreign accent I don't understand. Yeah, I do the same.
there you go, now both selected units are now moving. All right, awesome. So our basic selection logic is really working. We can toggle this select component, and depending on that, we are moving.
We're almost to the point where we can start actually potentially making the AI. I'll be right back. I'm gonna go grab food. Ah, okay, I'm back.
moving whatever units we want to move. Now in the next lectures, we're going to make it selectable with a mouse instead of manually clicking over here on the inspector. But for now, this is looking good. It's working. So let's just add a visual to it. For that, let's go into our unit. And again, let's make sure we work inside the prefab so it applies to all of them. So let's double click on this prefab, go inside of it. And now let's right click on the unit. Let's create an empty child game object. Call this the selected. And now let's apply visual. So here we actually have two options. So the simplest one is to add a sprite render. And by default, let's select the circle sprite.
We're just gonna do this real quick. Did I close that? Oh, I did. Ugh. Wait. What? Oh, somebody subscribed on YouTube. Oh wait, no, wait. Never mind. You just subscribed. Thank you for the sub, man. I got gifted a sub. Oh, you got gifted? Oh, now I see it. Okay, so my Twitch wasn't up. My Twitch management was not updating to tell me what was going on, and I was like, I don't know what's going on. Anonymous gifter. Thank you to the anonymous gifter for gifting a sub to Chrono. I appreciate it. I'm sure that they appreciate it too. So here's my lunch. It's just essentially like leftovers from yesterday. I'm just having a bunch of noodles. Oh wait, that's the wrong one. 4? Camera 4. No, camera 5. There we go. Yeah, no more ads. It's gonna be great. Now every time I go to ask you a question, you're not gonna be like, I'm in an ad.
So there it is right there. Let's just rotate it to face upwards and make it a little bit bigger. Okay, something like this. Now let's go ahead and save the prefab. Let's just increase it on the Y by a little bit, like 0.1, just so it doesn't collide with the floor. Let's go ahead and save the prefab. And yep, all the units have that. Press on play, and yep, they all still work perfectly. So this seems like it's working. Our sprites are being rendered. However, it is not actually being rendered by dots. Like I mentioned in the first few lectures, only a few built-in components are automatically supported by dots. Mesh rendering works, so our meshes over here, those are being rendered by dots. Physics also works, that one is also running on dots. However, for rendering sprites, if we actually select one of these objects, so let's select this select game object, and we'll look over here for the components, and we see these strange components. Companion link, companion transform. Basically, this is what happens if you bake an entity with some component that isn't yet supported by dots. It creates all of these companion components, and what these do is essentially the game keeps both the game object and the entity both alive at the exact same time. The entity will simply drive the game object behavior. So this is working, but it's just not as efficient since we are busily back to using game objects. We have an entity, but the entity is linked to a game object. Now in this case, our solution is actually pretty easy. All we want is really just a render sprite. So instead of using the sprite render component, instead we can just use a mesh render. So let's go back inside our prefab unit, and for the selected, instead of using a sprite render, get rid of this one. Let's add the simple, the mesh filter, and the mesh render. Then for the mesh, let's choose a default quad mesh. And for the material, let's go inside the materials folder. And if here is the select material, let's go ahead and select it. And if there you go, right away it does work. The only thing is, I believe this one is pointing downwards. Yep, so let's just flip it over. So make sure that over here on the rotation, yep, let's put it 90 on the X, put it 0.1 on the Y, and for the scale, let's make it a little bit smaller, so let's down 2. And yep, that's it. Now since we're using a mesh filter and mesh render, which again, they work with dots, because this will be using the super fast dots render, just like all our other meshes. So let's go ahead, save the prefab, go back outside, and if there it is, all our units with all rendering being done, and we can select the selected, and yep, it does not have any of the companion components, it has the normal rendering components. Okay, so with this we have the visual. Now let's show or hide it depending on whether the unit is selected or not. It's actually an interesting problem to solve. Our visual.
Thank you, still needs work for subscribing. Much appreciated. Now you won't get ads either. No more ads. I would entirely turn off ads if I could. But they get forced in anyways. So having the ability to actually see when an ad is playing is fucking great. And I think if you don't enable that, then you don't get to see when ads are playing. Or at least that's my understanding. If I could be wrong on that one. Oh shit. Thank you for the bits too. And thank you. Thank you so much. It means a lot to me. I feel like it's somewhat true. But it also might not entirely be true. One sec. Excuse me. The reason I say that it might not be true is because, like, he does have, at the end here, he does have animations. And you can't do animations on a mesh. You have to do them on a skeletal mesh. Unless I'm misunderstanding the way Unity works.
Is over here, it is a child object, meaning it's actually attached to a different entity than the one that has the select component. So as we are doing our query for the select component, we are going to cycle through just this parent entity. It is not going to cycle through the child one that has a visual. So as we select or deselect, in order to update visual, we basically need a reference to that visual entity from the parent entity. Now thankfully, this is actually pretty simple to do. We can go here on the select component, and directly on the component, let's set a new field. Let's make it of type entity, and let's name it the visual entity. Yep, just like this. So now the question is, how exactly do we get that reference? And the answer is simply through the baking system. However, if we were to just add an entity field directly up there, if we do this, if we save, if we look over here in the editor for selecting, nope, it does not have that field. If we make something of type entity, it does not show up over here in the inspector. However, if instead of making an entity, let's make this of type game object, called the visual game object. If we do this, yep, no, it does show up a normal game object field. So now we can assign it, and again, make sure you're working inside the prefab, so let's open, go inside the prefab, and over here now we can just click and drag the select game object. And yep, that works. Let's save, let's go back outside. Okay, so now we do have this field assigned with the correct reference, and now the question becomes, how do we convert a game object onto an entity? And once again, thankfully, because of the baking system, the answer is super simple. We just use literally the exact same get entity function. So over here, when constructing the selected, let's assign that one. So we're going to want to assign the visual entity, and over here we call get entity, and for the first parameter, we pass in the game object we want to convert. So let's go inside the authoring component, grab the visual game object, and then for transform usage flags, let's make it dynamic. And yep, that's it. So this will basically take this game object and convert it onto an entity, and assign that entity over here on the visual entity field. Now we can verify that this did indeed work. Let's save it, and over here in the inspector, again, make sure you drag the reference, but make sure you drag it from inside the prefab. And now if we select one of these entities over here in our hierarchy, and if we go onto runtime mode, again, select bug, let's select a different one, and there you go, it show up. And now we scroll down, and if there's our selected, and we can indeed see it does have a reference to the selected entity. That's the entity with ID 129, so we can manually go inside of this one, select the selected entity. Yep, entity, it is indeed 29. All right, awesome. So with this, we have a component, and that component does have the correct reference to the visual entity that we want. Now with that, we have all the info we need in order to show or hide it. So let's make a system to do just that. So on our systems folder, let's right click, going to create a new iSystem, make this the selected visual system. Now over here on this one, let's cycle through all the entities that have a selected component. So we're going to do system API.query, so the same thing we already saw. Let's grab the selected just for reading. We don't need to write anything to it right now. Let's grab the selected component. So that's going to be our query, and let's put this inside the for each for the ref RO of our selected component, and we have the selected in this query. Okay, so this is going to cycle through all the entities that are selected. Again, keep in mind that whenever we include a query, it is only the entities that have that component, and the component is enabled. Then for actually showing or hiding, for that we're going to be playing around with the scale on the local transform. So let's go here onto the select component, and let's also define a field for the show scale, basically how big we want this to be. If we want to hide it, we're going to put it on 0, but if we want to show it, let's put it on something, and let's also expose this over here and pass it in on the baker. Okay, like this. Let's say this one, just set it in the editor. So here in the editor, let's select the prefab itself. Let's scroll down, and for the show scale, let's put it on 2, because that was the 2 that we used over there. Okay, great. So back in our select.
Wait, is he distinguishing from a rigged and skinned mesh? Yeah, at the moment he's just got effectively nothing going on. CodeMonkey has a mesh that he removed the skeleton from, so it's just a static mesh in a pose.
Visual system here, we have the query running through all the entities that have a select component, and now we want to grab the local transform for the select visual. However, again, it is the local transform of the visual entity, meaning it is not the one inside of this query. This query is basically going to give us the parent, but we want the local transform of the child visual. So the way that we grab a component for a different entity, the way we do that is we access the system API, and then we have a bunch of get component functions. We can do this one, which is just going to return our component. But in our case, we actually want to get the local transform to then modify it. So let's actually use this one, which returns a ref RW of that component. So let's go and get component RW. We're going to grab the local transform component, and for the entity that we want is the one that is inside selected. Let's read the value and read the visual entity. So yep, this is going to be returning a ref RW local transform for the visual local transform. Okay, we have this one, and now with this we can simply make it visible. So let's go inside the value RW for writing, and let's set the scale. Go inside the selected. Let's read the value RO, and let's grab the show scale. So this code right here should be making the units that are selected actually visibly selected. Although right now you might be thinking an interesting thought. You might be thinking, isn't this code actually losing the benefits of dots since we are essentially accessing a reference that points to a completely different position in memory? And the answer is yep, that is indeed correct. Technically, since we are getting and setting a component on a completely different entity that is not within this query, because that this code will not be as fast as if we were just doing a query. But two things on that note. So first, this code isn't super complex, so even though it's technically going to be slower than if we weren't using this, technically it's not really going to be an issue. And secondly, in a few lectures, we're actually going to implement a really nice event system, which means this code will only run when the units are selected or deselected and not on every single update. So performance on the system isn't really going to be an issue. And this is also a great example of how when working with dots, technically you want to take as much advantage of the massive speedups as possible. You want to really only access components components in memory that is tightly packed, but in some cases like this, you always need some kind of random memory access. That's normal. It would be pretty much impossible to make a game that completely avoids any kind of random memory access. So while it is something you should avoid as much as possible, it's also fine to use in certain scenarios. Okay, so like I said, this one should be cycling through it and should be making the visuals visible. Let's test to make sure. Let's save this. And here in the editor, let's make them essentially deselected by default. So let's go inside of this prefab. Let's double click, go inside on deselected, and let's set the scale to 0 so that it's essentially hidden or deselected by default. Okay, great. Now let's test. Yep, right now by default, none of them is showing deselected visual. Now if I were to select a unit, and over there manually let's select it. And by the way, if you make something as enableable, but you add some extra logic inside of it, some extra data, if you do that, then it no longer shows up over here on the tag section. If so, then it shows up as a normal component, but it still has this nice toggle. So right now the unit is not selected, and if I click, hey, there you go, the select visual did show up. If I select a different one and set this one as also selected, let's go down, select, hey, there you go, now both of them have the select visual. Alright, awesome. Except one issue. If I now deselect this unit, so let's deselect it and move, and okay, so it is not moving, but the visual is still there. It is not hiding. So over here for hiding, it's actually super simple. We can do pretty much a very similar query, so let's copy this and paste it up here, except instead of just looking for components that have the selected enabled, instead let's use with disabled, and we're going to look for the select component as disabled. So this one's going to run on all units that are selected, and this one on all units that are deselected, and for the show scale, let's just put it on 0 to make it deselected. Okay, that's really it, super simple. Let's save. Okay, let's test. Hey, by default, all of them are deselected, none of them are selectable. Okay, great. Now I select one of these, and let's manually make it selected, so down here on selected, enable this, and there you go, that one is now selected. Now let's deselect it, and there you go, the visual disappears, and I can no longer give orders. So I can select this one, set it as selected, select another one, set it as also selected. Now I have both of them controlled, they both have the visual, deselect this one, and only that one has a visual. Alright, awesome. With this, we can now easily
Going to lurk as I work on my schoolwork, or I'll just watch the stream all day and get nothing done. Sounds good. Thanks for stopping by. Thanks for the subs and bits. It's much appreciated. I'll be right back. I'm just going to take my container into the kitchen. Going to do a 5-minute walk. Be right back. All right, sounds good. If you're still there, have a good walk. If not, I'll see you when you get back.
select any entities we want, the visual updates to show whether they are either selected or deselected, and depending on whether they are selected or deselected, we can give them different orders. Okay, great. So with this, we have our basic installation working, except we are manually selecting them by clicking over here on the inspector. We should really implement some logic by selecting them by using the mouse in-game, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up the UI and learn how to create the selection area so that we can finally select multiple units. Alright, so our selection logic is working. We can only control units that have the select enabled, so if I select one of them, I can manually assign that selected, it shows visual, and I can control just that one. But of course, we don't want to select the units by clicking on the inspector, we want to do it directly in-game. So let's set up a logic for selecting units using the mouse, and we're going to set up a standard RTS multi-select mechanic, meaning click on one place, click on another, it creates a selection area, and then we want to select all the units within that area. Okay, so over here on the unit selection manager, in order to check if the player is actively selecting an area, for that, let's just listen to the left mouse button down and up. So up here, let's do an if input.get mouse button down on the 0, so the left mouse button, and same thing for the get mouse button up, also for the 0. Okay, just like this. And again, like I mentioned previously, we can later.
Yeah, this is still that. And I don't want to be calling over to this all the time. So I'm gonna have to figure out how I'm gonna do the vehicle movement. But luckily I think this covers it. Ooh. I'm curious as how this works here. Oh, it's a mono behavior. So this is the vehicle. Which is entirely outside of it. Oh, it's creating a struct that contains the data. I think this is actually doing that thing that Chrono and I spoke of earlier, where it's got essentially two representations, one inside of dots and one outside of dots. Back already? That was a fast 5-minute walk. Had like a min left. Get entity transform flag dynamic. Add component view. This is the authoring. I imagine this is pretty hard to read. Native array wheel bake info. Wait. What? This looks like a lambda almost. Oh wait, no, this are just get in wheel info. Oh, there it is, right there. Update after type of end collision baking system. Oh, that's kind of cool. The update after thing, that's kind of neat. World system filter. Baking system. I have to look into those. Requires matching queries for update. I think common buffer. I think common command, but for each, this is the query, right? In var wheel in, this is grabbing the wheels. World from suspension. Configure properties of the vehicle mechanics which change with low frequency at runtime. World center of mass. Interesting that we're passing through the world center of mass. Because that will update every time we move. See graphics representation used for steering, used for driving. Why are we passing through a byte? I guess a byte would. I want to know how they're going to use the byte. The smaller we can, the better we can pack the data, the better, the more performant it will be. Well, yeah, no, like everything has a purpose, but like I wonder how the byte is being used. Because there's eight bits in a byte. So like used for steering, I feel like can be a bit, but maybe we don't have access to like a public bit. And a byte is the smallest amount that we can actually pass. I was right. It kind of makes sense though. Yeah, it kind of makes sense. Because like for access when you're doing memory access in assembler, you can't access a singular bit. You can only access down to a byte, which obviously, right, is 8. So that makes sense. So booleans would be in this case would get represented as a byte instead of like an int. And the only reason for this is because like if we were to take a look at this and link here, right? If we've got our memory, right? We want to pack this and be as efficient packing this as possible. Right? So if we're saying this is 8 bits, right? But then if we were to pass it through as an integer on a 64-bit system, it should default to 64, which would then be like this much bigger. Now we have to copy, now we have to allocate for that. And well, like by default, that's not too bad. But like if we were to able to allocate, if this is say 128 bits, right? And we allocate 64 bits for checking whether or not we're, let's see. So if we cut this down the center, right? And we say that this is 128 bits in width, right? And we're to allocate 64 bits or even 32 bits, right? Let's say 32 bits. If we were to allocate 32 bits for a Boolean value, that means that we can only pack 2 Boolean values next to into this before we hit the halfway mark, which gives us 4 Boolean values that we can access, right? And the reason why this matters, right, is because like our registry is going to be our cache is only so big, and we want to keep as many entities inside of cache as the data for the entities inside of cache as possible, right? Yeah. So if we can pack them more efficiently, even if we need to even when we're accessing them, if they need to be expanded out from 8 to 64, into the registry, right? We can allocate it. It costs the same to allocate 8 bits into a registry as 64 bits, right? 8, 64. These cost the same, right? Because everything's done in chunks of 64. I just noticed that Paint has layers now. Is this an AI generator? Yeah, that's new and interesting. Okay, so component data can be a transform and an entity. Why paint.net? No. I just stick to, so there's a couple different ones that are popular. There's one that I would stick with if I really want. Krita is my favorite for this. It's effectively Photoshop, but it's probably not as lightweight. Um, there was another one that was really that was pretty good, and I can never remember the name of it. Oh yeah, I don't like GIMP either. Yeah, but Krita's pretty good. GIMP's like just hard to use. Mm,
Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to handle the logic for selecting just one unit. And the way we're going to do that is with a raycast. If it hits a unit, then we select just that one unit. So this means that we're going to need to learn about how to do physics queries using dots. Okay, so we already have the selection area working. I can select a bunch of units, do a little square, and select all the units within that area. Then I can just give them orders, something like that. However, we cannot easily just select just one, so I click on this one. Nope, doesn't work. I need to do at least a select square in order to be able to select. So let's hold this. Let's use physics and a raycast to test for single unit selection. Now, phys and dots is actually surprisingly easy to use. But before that, first let's add some logic to test when should we use physics, meaning how to define when the player is trying to select just one unit versus selecting multiple. For that, essentially, we can check the size of the selection area. So if the selection area is at least a decent size, if so, we're going to engage the select multiple mode. But if it is small, like something this tiny, if so, then we're going going to select just one single unit. Okay, so let's add that logic. Now first, let's deselect all of them. Okay, that makes sense. So we handle all the deselection, and then for selecting, let's grab the selection area rect, and from that one, let's calculate a selection area size. So float selection area size, and for the size, let's just do selection area rect. Let's grab the width and add the selection area rect dot height. Now technically, this isn't going to be an area. If it was an area, we would do multiplied as opposed to plus, but we're not actually trying to get a specific number. We're just trying to get something, and if we multiply, we end up with a huge number. So either way it works, but let's go like this. Just have a simpler test. So let's define a float for the multiple selection size minimum. Let's say something like 40 units. We need to test this, and basically let's find a boolean for is multiple selection, and basically we're going to be doing multiple selection if the selection area size, if this size is bigger than the multiple selection size min. If it is bigger than that, then we are going to do a multiple selection, and if it is smaller, then select just one unit. So let's just do a log on this one. So debug.log. Let's print out the multiple selection, and let's also print out the current size, just so we can see if the value 40, if this one does work right. Okay, let's save. Okay, so now here let's look at the log. So basically, if I do a big one like this, it should select multiple. So yep, that is true, and has a size of 1,000. Okay, and if I make something like this, this should probably be something like this should be the smallest. So let's see how big is this square. It's about 100. So if it is something like this, about 50. So yeah, 40 pretty much means just a tiny square. So as long as it's a little bit bigger than this, then we're going to select multiple. If it's smaller than this, we're going to select just one. Okay, so I think either 40 or 50, that one seems pretty good. Okay, great. So if I just click, that's going to be pretty much 0, select 1. If I do a square, then select 1. Okay, good. So now we have this simple boolean. So if we are doing multiple select, then we're going to do this multiple select logic, and if not, then single select. Okay, sounds good. Now over here, let's learn how to do a raycast. So for that, the first thing we need to do is grab something known as the physics world singleton. That is an actual type, physics world singleton. This type, which exists inside unity.physics. So up here, let's go ahead and make sure to include that. Okay, so we need to access this type, and this exists inside an entity. So the way we're going to find that is by doing a query to get that type. Now for that, we can do the exact same thing that we did up here. Create a new query builder with all. We would write this type and then simply get it. That would work perfectly fine. But let me also take this time to show you a different way of also creating an entity query. So this way works fine using an entity query builder. That works. But another alternative approach is to go through the entity manager. So we go through this one, and on this one, it has a function called create entity query. So now this one has a different syntax. So instead of taking in the types as generic, instead we write the type directly as a parameter. And this one takes in an actual type object, meaning it is not just physics world singleton. It is not just like this. This is a syntax error. We need to pass in the type. So let's use the type of keyword in order to convert that into a type. So just like this. So this is doing essentially, let's copy this one, just see the exact same thing. So create a new entity query builder with all of the physics world singleton, just like this, and build the query. So basically both these lines are doing the exact same thing. So feel free to use which one you prefer most. Okay, so this one will return an entity query, and that query is going to contain entities that have the physics world singleton. And like the name implies, this one being a singleton means there's really only one of them. So technically we could take this query and do the same thing that we were doing up here, convert it to an entity array or to a component array of this type. We could do that and then simply access the component that is on position 0. That would work. That would get us the component, since again this one is only going to have one. But the entity query, this one also has some helpful functions, like one called get singleton, which does exactly that. So we call get singleton. This one takes generics of a physics world singleton, just like this, and yep, this is going to return an object of type physics world singleton. So that's it. So we construct the query looking for this object, and then this one automatically finds the single instance, the single entity that has this component, and we get it over here. So with this we have the physics world singleton, and now inside of that one there is something called a collision world. Let's store this one. So a collision world like this, and now it's inside of this type. If we go inside dot, and up here you can already see we have functions for doing a box cast. We can cast some collider, cast array, check a sphere. We've got a bunch of overlap sphere, capsule, and so on. So basically this is where you can do all kinds of physics queries. We're going to use these quite a lot. Now for this one, for the click, for this we want a simple raycast. So we can just use this one over here, cast array. Let's see what parameters this requires. It takes in something of type raycast input.
Wait, so physics world singleton. We were asking for a physics world singleton. And that's just the physics world of yeah, so that would just grab the physics world based off that. Interesting.
So let's construct this type. So a raycast input, construct a new raycast input. Okay. And now for that inside of this one has a start, that's a float 3. So it's a world position. It has an end, which is another float 3, and then has a filter. So for getting the start and the end, that's actually quite simple. Again, we're trying to do a raycast from the camera's position. So like we did on the script for finding the mouse position. So over here on this script, we use the camera in order to convert the screen position onto a ray. And then from this ray, we can call get point to get a point on any position within that ray. So over here in our code, we can do exactly that. So let's grab a ray for the camera ray. So here we go inside the camera, get the main, and let's call the function screen point to ray. This one takes a screen position and converts it into a ray. So for the screen position, let's use input.mouse position. Okay, yep, that's it. However, here we actually see an error. It is saying ray is an ambiguous reference between unity.physics.ray and unity-engine.ray. Basically the unity-engine.ray, this is one for the game object world, and unity physics, this one is from .physics. Both of those namespaces contain a ray class. So one solution is to go up here and get rid of one of these. We could get rid of the unity-engine, but then we would have errors whenever we use debug.log. So down here, let's just write the full name. So this one's screen point array, this one's going to return a unity-engine.ray. So let's write the full name. So unity-engine.ray, just like this. So we have the camera array, and then from there we can call the function getPoint. This one takes in a distance and basically returns a point at that distance along the array. So for the start point, we want to start pretty much at the camera position. So let's start on 0f, and then for the endpoint, let's do the same thing. And basically we just need the point that is far enough away. Now technically we could do a raycast in order to find the perfect distance that the unit is from the camera position, or you can just simply put a huge number. Either one is really going to work fine. So here let's just put a bunch of 9s, and that is more than enough to actually collide with the unit. To do that, and the final parameter is the filter. This one is of type collision filter. This is a special dots type. Let's construct a brand new one, a new collision filter, which by itself also has 3 parameters. It has belongs to, collides with, and the group index. Now these are essentially layers, or rather layer masks. So the ray is going to belong to this layer, and it's going to collide with this layer. The layers over here are the ones that you define on the game object itself. So if you go back over here into Unity, let's select actually our prefab instead of any of these. Okay, select the prefab, and over there in the inspector we can see the layer drop down menu. So we can click on it and we can add some more layers. So for example over here for layer 6 for the first empty one, let's define this one as our units layer. So just write units. Now here we just need to memorize this number, so this is going to be layer 6. And now we can select the prefab again. Again, select the prefab, not the ones on the scene. And now this one, let's swap this one from the default layer onto the units layer. And nope, we do not want to apply to children. The only thing that matters is the object that has a collider, which is going to be this one. So let's go ahead. Yep, okay, so this one is now on the units layer, which again is layer number 6. So here in the code for finding that is exactly what these are going to represent. We use those layers to say that this raycast is going to belong to a certain layer and is going to collide with a certain layer. And by the way, for the group index, this is basically a special override. This one is just a number, you can see it's just an int. So if you put a number here, like number 56, and then you have another object that has the exact same group, then the raycast will always collide with that object, regardless if it belongs to a different layer or does not collide with that layer. So basically, group index is always going to be an override, but in most cases, we don't really need to worry about this one. So we can just default this to 0 like that. Okay, so now for these two that are important, the belongs to and collides with. So how exactly do we set these up? This one is actually a uint, so an unsigned int, but this one is a bitmask number, meaning that the layers are defined by the digit position in binary. So over here we do not put 6, this is not correct. Like I said, this is a bitmask number. So a bitmask means that essentially the layers are going to be defined by the digit position in binary. So here we have an 8-bit number defined, it has 8 bits. All of them are on zeros. So if we were to use this as the
So
belongs layer, then the
32
raycast would
bit
not
though.
belong to any layer because again, everything is on 0. So if we want to hit layer 0, then we need to flip this bit. So we need to flip this from 0 onto a 1. And yep, this would be the layer mask for hitting things on layer 0. And if we wanted to hit things on layer 5, so this layer 0, 1, 2, 3, 4, and 5, so we want to modify this one, and we would flip this bit into a 1. Then if we want to hit both layer 0 and 5, if so, we just put both of them on 1s. So this is a bit mask. Basically, the layers, instead of being integers, they are essentially just positions on a bit mask. Those are either 0 or 1, depending on what layers you have selected for either the belongs to or the collides with. So over here, as to how exactly do we construct that bit mask, we start with number 1, which going back to our diagram here, 1 is really just this. So a bunch of zeros with 1 at the end. So we start with number 1, and then we bit shift. So put 2 angle brackets. This is called the bit shift. In this case, we want to bit shift to the left by the number of our layer. So if we wanted to shift this to the left by 3, then we do it just like this. So essentially what we're doing is first we define a 1, and then we take this 1, and we essentially want to move it to the left. So move to the left by 1 position, 2 positions, and 3 positions. So yep, that logic is doing exactly this. It is finally generating this number. So here in the code, if the goal is to collide with everything on layer 6, if so, then we need to do this, and we do not do this. That is a completely different thing. So let's do 1 bit shift by 6. However, we also should not put the 6 here. You shouldn't really hard code magic numbers like this. Magic numbers are only something you should avoid. Magic numbers is really just a number that has some special hidden meaning that is hard to decipher. So in this case, right now we just wrote this code, so we know that this 6 means the units layer. But if we leave it like this, we are definitely going to forget what it means. So instead of hard coding a magic number, let's use a properly named local variable. So here, just find int for the units layer, say 6, and then over here in our code, do it like this.
I wonder if it'll be can we do like unity static global static variables? I feel like scriptable objects are a trap on this one. I mean, no answer, no. That would work, but I think it would also bust the ability for us to utilize it in a multi-threaded system. I'll come back to it.
Yep, now this makes quite a bit more sense. Except we also see that we have an interesting error. This telling us we cannot implicitly convert from int to uint. That's because the belongs to, this one is a uint, it is not an int. So this one is a simple solution. We take this one, instead of using a 1, which is an int, let's append the word u, and there you go, now this one is assigned as a uint. Okay, great, so this is how we construct a bit mask. And actually for this one, we want this raycast to belong to every layer and collide with that one, so let's actually swap this. So let's put this one like this. We want the raycast to collide with only things on the units layer, and over here for the belongs layer, simplest thing is to really just make it belong to every single layer. The collision at the end of the raycast will be whatever matches both these. So to make the raycast belong to all layers, that is also pretty simple. We start with number 0, which again, going back to this diagram, the number 0 is literally everything on zeros. So all the bits are 0. In order to get all the bits into 1, we really just need to invert them. And the way we do that is with a tilde. So that one essentially takes all these zeros and converts them all into 1s, meaning that the raycast will belong to every single layer. And again, this one should be a uint, so let's append u just like this. Okay, so yep, that's it. And just another quick mention that you might not know about that relates to over here the belongs to and collides with as to why this has both of these instead of just having the collides with. For that here in Unity, we can actually go into edit and let's go into project settings. Then on the left side, let's go into physics, the physics settings. And up over here we see what is called the layer collision matrix. Here we can define that some layers do or do not interact with some other layers. So
I'm surprised that this isn't like a globally accessible enum. I feel like it should be, right? Like I can understand that like it's not going to necessarily like have all of your custom stuff in it, but there's no reason why it shouldn't be an enum. I feel like I'm crazy here, right? Oh, this is rendering. It could, because you have to send everything with it. So you'd have to send in the layer information as well, right? So effectively, what happens with the threading is they like, yeah, it has to be entirely self-contained. That way, it can punt it anywhere and it doesn't matter. It needs to be, yeah, it just needs to be entirely self-contained. So it has to be able to execute outside of the context of everything.
So that is why over here the raycast has an option, so you can make it belong to a certain layer and only collide with certain layers. Okay, great. So here is our raycast input. So we define the start point, that is going to be the point directly in front of the camera. The end point is going to be a near infinite distance falling along the ray. And for the filter, we're going to make this raycast belong to every single layer and make sure it only collides with the units layer, and the group index is going to just default. Okay, great. So like this, now we can use this raycast input on the cast ray. And now for the other parameters, so here we have multiple versions of this function. So we've got this one, which will output a raycast hit. This will output just a single closest hit. Or we have this version. This one returns a native list, which is going to be a list containing every single hit that gets hit along this line. Now in this case, we really only want to select a single unit, so let's just grab the closest unit. So let's define an out raycast hit for the raycast hit. And again, raycast hit exists in both the physics engine for the game objects and dots. So let's be explicit. This one we want the dots. So unity.physics.raycast hit. Okay, yep. So here's our correct ray. Now this function will return true if it hits something and false if nothing is hit. So let's do this into an if. So if this raycast, if it hits something, if so, then we want to look inside the raycast hit. And over here we can see the entity. So we can find out which entity did we hit. Now technically, since we made sure that it only hits things on the units layer, because that we can be pretty sure that this one is going to be a unit. But still, if we want, we can just ask the entity manager to verify. So we can, for example, go entity manager. Inside that one, we can check has component, and we check does it have a unit component. And yep, so if this entity has that component, then hit a unit. Okay, that's really it. So now we can just go into the entity manager, call set component enabled, set the select component on this entity. So raycast hit.entity, set this one into true. And yep, this should be working. So as you can see, it is really simple to do a physics screen dots. You just have to set up data for the raycast or the overlaps here or whatever, and you just call a function. And of course, before that, the more complex part is just having to go through all this. We need to construct an entity, we need to get the physics world singleton, and then get the collision world. So it's a little bit more worthy than the normal game object physics where you just do physics dot overlap box and so on. So doing it in dots is slightly more complex, but still it is pretty understandable. Just grab the physics world singleton, get the collision world, and from there you can do all kinds of physics queries. You go through all this. We need to construct an entity, we need to get the physics world singleton, and then get the collision world. So it's a little bit more worthy than the normal game object physics where you just do physics dot overlap box and so on. So doing it in dots is slightly more complex, but still it is pretty understandable. Just grab the physics world singleton, get the collision world, and from there you can do all kinds of physics queries. Okay, so let's test and see if all this is working. Let's make sure to save. Okay, so here we are. Those are all the units. I'm just going to try to select just this one. So just a click, and if there you go, with this select just that one unit. Now select all of them, move them all. It works. Single click, select, and so on. So I can select individual units, or I can select all of them and tell them where to move. All right, awesome. Now it looks a bit odd that all the units are moving into the same place. On the next lecture, we are going to generate the proper move positions. So let's re-enable just collisions just to see what that problem is actually going to solve. So over here, let's just go inside the unit prefab, and on the capsule collider, let's make it not a trigger. So let's make it so that it's solid. And if it is playing, they all go into the same place, and they all hit one another. So they all go into the exact same position. And I can select, can move a bunch of these, and yep, everything does work. Okay, great. Everything works, but of course, selecting multiple units and clicking still looks odd because again, they are constantly trying to go into just one position. They're constantly pushing each other around. So instead of telling them all to go to the exact same position, instead of that, we should write some simple code to generate some valid target move positions. So let's do exactly that on the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to dynamically generate some move positions so our units don't all try to go to the exact same spot. Okay, so right now we have units that we can control. I can click the select an individual one, select a group, and all of it works. However, right now, all the units, those are all trying to go to the exact same position, which leads to all this piling up. They get all kinds of collisions, so it's really strange. Basically, the more units we have, the worse it's going to get. Now, there are actually many ways to solve this problem. So one way is to sort of leave it like this, and then simply make the unit stop moving when it gets to the target and then allow it to be pushed around. So that's one option that could work, but another option that I think is best is to generate some proper move positions. So just like in
I love that.
many RTS games, you have formations. That's basically what we're going to build here. We're going to dynamically generate some positions in the code and send each unit to a slightly different position. Now, there are many shapes we can generate. So RTS games usually have some kind of rectangular formation. Sometimes they have circle formations. You might see some arrow formations and so on. So you can really go as simple or as complex as you want. In this case, let's go with a very simple circle formation. So we're basically going to have our target position right down the center, and then we are going to generate rings around that exact same position. And on each of those rings, we are then going to generate a bunch of positions within that ring. And the further we go out in the rings, the more positions we can generate. So by following this logic, even if we have just 1 unit or 10 units or 100 units, everything won't work. We're basically going to slice a ring into as many times as we need. We're going to basically slice a ring into how many positions we want to have. So in this case, let's say we make a slice here, then make another one here, make another one here, and another one. Let's find a minimum of something like 3, and then add, let's say,
Generate move position. That is yeah, this is
ring times 2. So on the first ring, on ring of 0, we are only going to have 3 positions. Then on the second ring, ring of 1, it's going to have 3 plus 2. On the next ring, it is going to have 3 plus 4, and so on. Okay, so now that we know how many positions we want to generate for this ring, let's actually go through them. So let's cycle through all those positions. Let's use a simple for. So in I starting on 0, while I is under the ring position count, I put. So we have this vector that's going to be, then we don't really generate anything, so let's just return the position array. If not, then it'll be our position array. And for the array. Then for the parameters, so first we need to for the return type. Okay, that's the rough logic. Now let's implement it. So over here on the unit selection manager script, let's make a function to generate our position. So let's write private. And for the return type, technically we could return a normal vector 3 array. We could return this, that would work. But instead, let's actually return a native array, make it a native array of float 3s. Again, native array that is a native collection that works with dots and bursts. So let's make this one and call it generate move position array. Then for the parameters, so first we need to know the target position, so float 3 for the target position. And then we're also going to need to know how many positions we want to generate, so an int for the position count. Okay, sounds good. So now here the first thing we do is create the array with this size. So native array of type float 3, that's going to be our position array. Let's construct a brand new one. Let's use allocated.temp to make it temporary. And for the size, let's define with the size of position count. Okay, yep, just like this. Then we can simply test if we are requesting 0 position. So if position count equals 0, if so, then we don't really generate anything. So let's just return the position array. If not, then let's keep going. So if we're generating at least one position, then the very first position on the array, so on index 0, this one is going to be the target position. We always want to make sure that we want to use that position. And then let's do another if. So if the position count, if it is 1, then this one is really all we need. So let's return the position array. Okay. And if not, then let's finally generate all the others. So first let's define some settings. So we basically need to define the ring size. So how far away is each ring from the origin? So let's find a float for the ring size, and let's use a number like 2.2. Okay. Then we also need to keep track of which ring we are currently generating. So let's define a ring int for 0. And let's also keep track of which position index we are trying to assign. Now since we already
oh, okay, yeah. That makes sense.
assign the origin over there on index 0, Let's start with the position index and start off as 1. Okay, great. So now here we're going to run our generation logic while the position index, well, that one is under the total position count. So basically keep generating until we have all of them. So that makes it perfect to use a while. So while the position index, well, that one is under the position count. While doing that, then we're going to generate a bunch of positions. So it's over here that we want to cycle through all the rings and calculate all the positions. First thing we should define here is how many positions we're going to have for this ring. As the ring expands, we can see it has more area. So as it expands, we want to have more positions. So we don't want to just be fixed. We don't want to have just 4 positions on every single ring. We want to have some kind of minimum and then some kind of bonus depending on the ring. So let's define int for the ring position count. Is how many positions we want to have in this ring. Let's define a minimum of something like 3 and then add, let's say, ring times 2. So on the first ring, on ring of 0, we are only going to have 3 positions. Then on the second ring, ring of 1, it's going to have 3 plus 2. On the next ring, it is going to have 3 plus 4 and so on. Okay, so now that we know how many positions we want to generate for this ring, let's actually go through them. So let's cycle through all those positions. Let's use a simple for. So in I starting on 0, while I is under the ring position count, I plus plus. Okay, we're cycling through all the ring positions. And now here, like I said, we're going to have a vector. We're going to start with the vector pointing in some direction, and then we're basically going to apply some rotation, then keep increasing that angle until we have all the positions generated. So let's calculate what is this angle, which the first one should be an angle of 0. We should just get the vector. Then for this one should be some kind of angle and so on. So for calculating the angle, it will be whatever is the index of the angle. So are we trying to get on position index 0, 1, 2, 3, and so on? We're going to take that, and basically for calculating this angle, we just need to divide the entire rotation divided by the number of positions we want to have on this ring. Okay, so here for calculating the float angle, for this one, let's say once again start with the index, and then multiply by the angle, which is going to be the entire ring split by some amount of ring positions. So let's grab math.pi2. Pi2, this one is the entire ring. Again, this is only radians, and we divide this by the ring position count. So this one gives us the angle that we want to apply for this one. And now with this, we can calculate our ring position. So what is going to be this ring position? So it is going to be the entire position plus we take our vector pointing to the right. So there's going to be a new float 3. And for the size of this vector, it is going to be based on the index for the ring multiplied by the distance. So that is going to be the ring multiplied by the ring size. Except for the first one, we also want it to be offset. If you use a ring of 0, then it's just going to spawn in there. No, we want to spawn in here. So here, let's use ring size multiplied by and then use a ring plus 1. Just make sure that even on ring 0, we still offset by the ring size. And yep, we just want the vector pointing right, so just like this. So this is vector, and then we just need to apply rotation to that vector. So let's actually define up here a float 3 for the ring vector. And we're going to start off with this one like here. And for the rotation, we can use math and call the rotate function. This one takes in a quaternion and a float 3 vector and simply applies that rotation. So now we just need to take this angle, which is in radians, and convert it into a quaternion. So for that, we can use quaternion and call the function rotate y, because we are working on a top down, so we want to rotate on the y angle and rotate by this angle and use this quaternion and that vector. Okay, so yep, so this is the ring vector, and we just apply that offset onto that one. And that's really it. So we start off with a vector pointing straight right, we apply some rotation to it, and then we take that final vector, apply it to the entire position, and that's how we get our ring position. So again, going back to the diagram here, we have this vector pointing right, then we apply some rotation. Hello and welcome, I'm your CodeMonkey. In this array, so select equals this, and finally go into the empty query, and let's copy from component delegate, which is another object. So in dots, we're not. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn one way for how we can handle events in dots, meaning how to know that something happened in a specific frame. One way we're going to use this is to make sure that our visual selection logic only actually updates when it needs to update. Okay, so here let's learn how to do dots events. Events are one of my favorite tools in programming. In my games, I use events a ton to keep my code nice and clean, and
Yeah. Enemy factions. Find target. Health. Health is kind of important. Bullets. Despawning. Despawning is actually something cool.
hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to dynamically instantiate some
Why? C++ has events. Sort of.
entities. We're going to have the soldier spawn the bullet, which will then move towards the enemy and deal some damage. Okay, so in the last lecture, we already created the bullet entity. If I hit on play, the bullet starts moving towards the enemy, hits the enemy, and deals some damage. So now let's leave that with the exact same behavior, but spawn it from the soldiers.
Well, it depends, right? Because like right? Like there's events in C++. Like native events. They're a little bit different.
Then let's go here onto the shoot attack system. And here, instead of dealing damage instantly, instead of that, we want to spawn a bullet. Now, spawning an entity is actually quite simple. We just need to access the entity manager. So here inside the system, we can access the state, and from the state, access the entity manager. Now from this, we can call instantiate. So just like you instantiate a normal game object, you can instantiate an entity. But of course, the question is, how exactly do we get a reference for the bullet object?
That's
Normally,
fair.
when writing normal modern behavior code, I would just expose some kind of field. Then the editor, I would simply drag the prefab reference. But systems in ECS, they do not have any game object in the world. So there's really nothing for us to drag a direct reference. And of course, there's also the fact that we have to go through the bake process. Here, we are not instantiating a game object, but rather an entity. So we need to take the bullet prefab, bake it into an entity, and then we get the entity that we can use over here. So in solution is to make a component that takes a game object field and converts it into an entity. And we could do exactly that, make a specific component just to store the bullet prefab. But as we're going to be making this entire game, eventually we're going to need to reference various object prefabs that we're going to spawn, like the soldiers, the zombies, the bullets, and so on. So instead of just one specific component for each object type we want to spawn, instead of that, let's create a component to store a bunch of entities references. So let's build that in the authoring. Let's right click, create a new modern behavior script. Let's call it entities references authoring. Okay, let's just clear our error over here and let's just comment out this code, just make sure the code compiles. Okay, let it compile so we have our components. And on the entity subscene, let's construct an empty game object, call it entities references. And I like to put it up here, so let's just drag it up to the top of the hierarchy. And now let's attach the entities references authoring. Okay, so now let's open this. Over here, let's write the normal stuff. So a struct entities references implement I component data, and then make the baker. So class for the baker of entities references authoring. Then let's implement the abstract class. Let's get the entity, get it as dynamic. Then add component on this entity, new entities references. Okay, great, just like this. Now with this, over here on the entities component, let's add an entity field. So public entity, let's call it bullet prefab entity. Yep. And now up here on the authoring component, let's add a public of type game object. And this is going to be our bullet prefab game.
So I don't remember. Do I fall through this world? Okay, so I can collide with. Wait. Yeah, that's fine. So I can collide. My truck can collide with the entity that is ground. So the entire world could be, or like the entire map could be inside of my pedestrian sub scene script thing, which I'm probably going to rename because there's no point in it being a pedestrian sub scene. Actually, I wonder if I do this, create. Wait. Create new subscene. If I duplicate this, no. New subscreen. Why is it making me? Why is it making me? Oh, I'm gotta do it anyways. Um, where are these being saved? Oh, here we go. Okay, so we're already there, right? And then we do this. Then if I enable this and I duplicate that, right? And I move that into here. And I duplicate her and I move her into here. And then I disable that one. Let's save everything. And I take this and I move this over here like so. And then I take this one. Then I take this this one. Actually, no. And then I just hit play. Mm. Yeah, the subscenes interact. I have a feeling my vehicle doesn't move right now. Yeah, my vehicle doesn't move. Wait, what the fuck just happened? Mm. Expected behavior. Oh, mhm. This means that the entire world can be made in a subscene that doesn't have anything to do with the other subs with anything else. My entire world can be a subscene. I could. I don't know if it's going to be required though. I guess it depends, right? Because a subscene could still be like could I do like subscenes? The subscene will do like calling and stuff like that, right? To be entirely honest though, like it might not even matter. It's gonna be something I'll worry about when we get there. Cause like this is the heaviest that this is going to be. Right? This world, like the environment itself, this is the heaviest that it will ever be. It's gonna get easier. Because these are super complex compared to like what I'm actually planning on doing. Although the draw calls are going to be really low here. Actually, they might not be, but I think they all like a lot of this shares a lot of no, these are all individual text materials as well. Yeah, it's going to be something I'll worry about later. I'm not gonna. It's not a reason not to use Unity. Is what it boils down to. Like it's a problem that needs to be solved. It's a problem that might need to be solved later. So I'll worry about it when it needs to be solved. I don't know. Yeah. Who the fuck knows?
Game object. Okay, and now we do what we've already seen. So down here on the entities reference, let's set that one equals get entity of the authoring component dot bullet prefab game object with dynamic. Okay, yep, just like this. Let's say now here in the editor, let's just drag our reference. So we've got the bullet, which actually means we need to make it into a prefab. So let's drag it onto the prefabs, and on the bullet itself, let's get rid of the one over there. And on the entities reference, let's drag the bullet prefab. Okay, so far so good. Now back here on the show text system, so we've got the code for calling instantiate, and over here we just need to reference that entity. So here's another important question, which is how exactly do we get that component? Now we can't really add it here. This is a query that is cycling through the units, and the units do not have the entities references component, so we can't just add it over here on the query. But the goal that we did with this entities references, this is basically just a single component that exists on a single entity that in itself is going to contain all the references that we need. So since there's just a single one, that means this one is going to be a singleton. And like we saw previously, System API has a real units do not have the entities reference. Here's another important prefab. How exactly do we get that component? Now we can't really add it here. This is a query that is cycling through the units, and the units do not have the entities references component, so we can't just add it over here on the query. But the goal that we did with this entities references, this is basically just a single component.
Okay, so an entity can be a prefab
That exists on a single entity that in itself is going to contain all the references that we need. So since there's just a singleton, that means this one is going to be a singleton. And like we saw previously, System API has a really useful function called getSingleton. So with this, we can very easily get it. So let's get the entity's references. Let's get it just like this. Entity's references equals down. Okay, so with this, we can easily get it. And then down here on the instantiate, let's go inside and grab the bullet prefab entity. Right, awesome. So this is going to spawn our bullet prefab. Let's just define entity for the bullet entity. Okay, now what we need to do is actually initialize it. So first, let's actually position it on the correct position. So let's just do System API call set component, and we're going to set the local transform component on this bullet entity. And we can actually use one of the helper functions inside local transform. It has a bunch of functions like this one from position. This one basically takes a position, returns a local transform filled in with that position, 0 rotation, and 1 on scale. So since once again we use our nice trick of having an empty parent game object that has a scale of 1 by default, and we only modify the scale in the child object because of that we can use this one. So from position we just need to know the position from where to shoot. So let's set it as the position for this unit. So let's modify over here the query. Let's grab a ref RO local transform. We grab this one and let's put it over here. Local transform. Okay, we have that, and from that one grab the value RO and grab the position. Okay, so this is going to initialize the position. Next, let's set up the bullet component. So let's go on the System API. Let's get the component RW of type bullet for this bullet entity. So it returns a ref RW of type bullet. So this is the bullet, a bit of a strange name, but it makes sense. Okay, so then on this one, let's go inside the value RW and let's set the damage amount. So as to where we get this damage amount, let's store it in the shoot attack component. Let's put it over here so that different units with different shoot attack components can deal different amounts of damage. So here just in for the damage amount, and then we just pass it through. So add it on the authoring component, and then over here that one equals authoring.that. Okay, great. So now back on this one, let's initialize the bullet, go inside the shoot attack, value RO just for reading, and let's read the damage amount. Okay, so that's the bullet component setup. We probably don't need to modify the speed. We can probably just leave that one with the speed that the prefab has. So final thing is run just a target. So System API, let's get the component RW. In this case, it is going to be the target component, and it's going to be that for the bullet entity. So this returns a target for the bullet target, and then we go inside this one. Actually, this is a ref RW. So then we go inside this one, value RW, and set the target entity. And it will be the same target entity as the one on this unit. So let's go into the target. This is the unit's target, value RO, and grab the target entity. Okay, yep, just like this. This should do it. So here we are spawning the bullet entity. Then we are setting it to have on the position from the same as this unit position. Then we set up the bullet by setting the damage amount, and we set the bullet target by setting the target entity. So yeah, just like this, let's test. Okay, here we are. Let's grab a unit. Let's get it close enough and see if it starts shooting. And if there you go, it does indeed start shooting towards the target. All right, awesome. However, I actually forgot to assign the damage. So right now the bullets are dealing 0 damage. Let's fix that. So on the project, let's select the soldier unit, and down here for damage, let's put 5. Okay, great. Let's test. So here we are. Let's select one of these, move there, and start dealing damage. And yep, and after a while, it should kill the zombie. So let's see. And there you go. It did shoot the zombie. Right, awesome. So that did work. But now let's actually see one interesting thing. So instead of one, I'm going to shoot with a ton of them. So we have tons of bullets flying around. So there you go, tons of bullets. And as soon as the zombie dies, yep, there you go, we have an error. The error is saying the entity does not exist. Now this is actually basically the exact same issue we already encountered on the shoot attack system. Here on the bullet mover system, this system assumes that the target always has a valid target. But of course, if the target is set as null, then this one is going to throw an error. So we need to check against null. So let's check if the target.value RO, if target entity equals entity.null. If so, that means the target is now dead. And if the target is gone, then over here on shoot attack system, we're just continuing. But on the bullet, we really don't want it to continue. If the target is already dead, then this bullet is no longer going to do anything. So if the target is dead, we want to destroy this bullet. So let's use the code that we have down here for destroying an entity. Let's destroy this bullet right here, and then just do continue. Okay, so let's test. So here we are. Let's pick a bunch of these, get them all close so they all shoot at pretty much the same time. And if there you go, this works. So they all shoot a ton of bullets, and they all get destroyed if the target is now dead. And actually, let's just solve one bug that I just noticed right now. It has to do with our reset target system. So over here, if we play and if we have multiple units, all of them shooting bullets, all of them firing towards the enemy, if there you go, we eventually have an error. It says the entity does not exist. And this error is coming from the bullet mover system. So basically the issue is that the bullet mover system, this one, the bullet still has a target, but the target has since been destroyed. So what's happening is actually a very strange thing. So basically on frame 1, the bullet moves, the bullet sets the target, destroy the target. Okay, great. Then the help that system test down runs. That one eventually queues up the entity for destruction on this one. And then on the next frame, the entity still has a target because the reset target system down does not reset target because it is only destroyed afterwards. So then the next frame, the bullet mover system runs and still has target, and that throws the error. Except that is not just the error, it is actually a bit more complex than that. Technically, if that were the error, we could put the reset target system, put it at the beginning of the frame, and that could work. So let's try doing that and see. So over here on the reset target system, instead of updating on the late system group, trying to update it at the end frame, which again is only actually going to reset on the command buffer, which happens way at the end of the frame, so even after this one. So instead of doing that, let's pretty much reset target on the beginning of the next frame. So we can put this on the simulation system group, and then we can use order first and set that one into true. So like this, it should run pretty much at the beginning of the frame. Okay, let's see like this. So let's test and pause. And yep, we can see the reset target system is running at the beginning of the frame. Okay, so let's see if it still throws that error. So they all go, they all shoot, destroy, and nope, we still have the error. So even though we technically fixed that, the error still exists. So on frame 1, the bullet
This is what we call a race condition.
moves, it hits the target, it destroys the target, then the help that system down is going to destroy the entity, or rather it queues that out, and the entity is actually destroying this one. But for some strange reason, on the next frame, when we reset and come back over here, for some reason the entity actually still exists. It was queued up for destruction, but it still sort of exists. The entity still exists, and it's actually only over here on the parent system.
It has to. I'm guessing under the hood, it has to do with the reference still being like allocated, right? So it's not actually fully purging from the system. So what I'm guessing he's gonna have to do, he's gonna have to do is like go in and check to make sure that it's still valid, and if it's not valid, destroy itself.
When the entity is sort of destroying. So by the time we get to this one, technically it thinks the entity still exists because the target was not reset, but the entity no longer exists. So again, we have an issue. Now this is a very, very strange thing. I have no idea if this is a bug. We can add some logs here just to verify exactly what I'm talking about. So let's do entity engine debug, do a debug.log. Let's print out the name of the system, and let's also print out the time, the unity engine.time, and let's print out the frame count, the frame number. So let's print this one, and then over here let's also print if the unit actually exists. So unity engine debug.log, and let's print if this unit exists. So let's see this, and then also let's go onto the bullet mover system over here. Let's do the same thing. Let's also print in order to see in which frame the system is running. And then over here let's do the same thing. So let's see if the entity still exists. Let's test it out on this one. Okay, so let's see like this. What exactly does it say? Okay, here we are, and let's shoot and kill the enemy and find the error. Okay, the error happened, and now let's look at our logs. And yep, here we do see these strange things. So on reset target system, the target still exists, but then on the exact same frame, frame 497, on that one the target no longer exists. These ones, by the way, this is actually just entity.null. We can verify that. Let's just print out the entity, just make sure we are talking about the same thing. So print out the entity like that, and same thing on the bullet mover system. Over here, print that one. Let's see everything. So let's move the units, attack the target, and let's see fire the error. There you go, there's the error, and now we can definitely see. Okay, so on reset target system, so previously it makes sense that the unit does exist. Unit 196, that's the zombie, and that one does exist. It does say as true, so the entity does exist. And now let's see over here. So on frame 495, on this one the entity still exists, so it still does exist. And then on the bullet mover system, again on the exact same frame, for some reason in between this system and this system, all of a sudden the unit stops existing. So basically when this runs, it does not clear the target because technically it seems like the unit still exists, but then down here at the end of the frame, on the exact same frame, the unit no longer exists. I've done some testing and it seems like the thing that actually destroys the unit is over here, the parent system. I have no idea why that one is specifically the one that is actually destroying the entity, but there's actually one more very strange thing. Let's add another log here to verify another thing. Let's call system API that has component of a local transform on the same target entity. So target value RO, target entity. Okay, let's print this to see if this target entity has a local transform component. Let's print it out on this one and also over here on the target. Okay, so let's see what both these say. Let's go ahead and shoot them all. Okay, there's the error. Now let's look at our logs. And okay, so frame 493, that's when we have the error. And if you look at the frame before on 492, yep, the entity still exists and it does have a local transform component. Okay, makes sense. But then on the reset target system, so on this one, the entity technically still exists, but no longer has that component. So this is why I'm saying this is very strange. I have no idea if this is a bug or not. The entity should really be destroyed on the previous frame, but it doesn't. But then for some reason gets queued up for destruction and only the parent system actually destroys it. So anyways, this is all very strange. So the entity that exists, that one seems to behave very strangely, but we can basically use has the component of the local transform, use that as a sort of proxy. So here for the reset target system, we're going to reset the target if the entity no longer exists or no longer has a local transform component. Since the targets are always going to have local transforms, we can assume that if the local transform is gone, that means because the entity is also gone. So we're here on the reset target system. Let's just add that logic. So we're going to reset the entity, reset the target entity if system API, if the entity no longer exists, or the entity no longer has a local transform component. So that one or that one. If it is either of those, then the entity won't reset the null. Another thing is here we are running this code all the time, even when the target entity is null. So that makes no sense. That's just wasting a bunch of performance. So up here, let's check if target entity is not entity.null. If it isn't, then we do this. But if it is null, then the entity is already not assigned, so we don't need to do anything. Okay, so like this, finally, everything should be working. We should not have that error, and our reset target system should now be behaving correctly. It should be 100% resetting the target at the beginning of the frame. So we're here on the bolt move system. We can get rid of our logs, and yep, let's save everything. And now let's test. So here we are. Let's move. Have all the units shoot at the zombie. Destroy the zombie, and yep, there you go. No more errors. All right, awesome. So this was very strange, but we figured out a solution to our problem. We set the
So there was an additional problem.
Reset target system to run at the beginning of the frame, and we added some extra logic. Instead of just checking if the entity exists, which seems to behave very strangely, instead of that, we also check for the local transform, and that does seem to work. So the bullet move, the bullet set the target and damage the target with a help null 0. Then this system runs and queues up the actual entity for destruction. Next, this entity command buffer system, this one runs and supposedly actually destroys the entity. And then on the next frame, this one says that the entity technically still exists, but does not have a local transform component. So use that to basically invalidate the target. And then when this one runs, it no longer has target, so everything does work.
I have manually learned to code like a year or two ago and jumped around between languages and engines trying everything out to see what I like. That's not a bad way to go.
So very strange, but now all the code is working. Okay, so here's an update that I'm recording later on. I believe I figured out the reason why this is happening, thanks to a comment from a student. I believe the issue has to do with cleanup components. These are special DOTS components that will basically keep an entity sort of half alive until they are manually removed. The transform system uses a cleanup component, so that's why the entity stays sort of alive until the transform system runs on the very next frame. Only at that point does that system finally remove the cleanup component for the transform, which then finally allows the entity to destroy itself. So if I'm correct that this is what is happening, then this is not a bug. It is working as intended. It looks a bit strange as to how the entity is destroyed in the middle of a frame, but it does make sense based on this. Essentially, the entity is only destroyed when all the cleanup components are manually removed. So if while working in your own DOS projects you encounter this issue with entities being sort of half dead, half alive, if so, then remember this. Remember all about cleanup components. Okay, awesome. So our bullets are working perfectly fine. They spawn, they move towards the target, deal damage, and destroy themselves. However, we have a bunch of annoying issues. For example, one issue is how the bullet is actually spawning from the floor, or that's spawning from the floor instead of spawning from another. The other issue is that the unit is not looking at the target, it is looking away while shooting. So let's solve a bunch of these issues. Let's do a bunch of improvements for our shooting logic, and let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to build a super simple zombie spawner. This is going to be a quick lecture because we have already learned everything we need to do. This is going to be an excellent example about how after you learn how that works, it becomes actually relatively simple to build brand new systems. Okay, so far here we have our soldiers, we have zombies, I can approach with the cylinder, and yep, there you go, starts attacking the zombie and eventually kills the zombie. So all of it is working perfectly. We've got the soldiers, we've got bullet spawning, everything works. So now that we have the bullet spawning working, let's also spawn some enemies as well. Like I said, the logic is going to be very similar to what we already did, so this is going to be an easy lecture. First, let's begin by...
Okay, so I think can we have full AI in? I don't think we have full AI inside of entities, right? Unity. Dots AI. You can't have interface fields in a struct data component. Really a first-class citizen in ECS. Can you access Unity dots? Can you access the nav mesh? Because Unity has a nav mesh, right? Yes, you can access the Unity nav mesh within a dot system by using the nav mesh query system, which allows you to do transform position. When making queries, you need to convert your entity position stored as a float3 in dots to a nav mesh location. I don't know if I like that. Unity dots dev on AI navigation livestream clip.
All right, moving on. AI navigation for entities. I know that is one thing if we're looking at the DOTS roadmap. It's not currently under development, but it's in the kind of like under consideration category. Is that right?
Yeah, that feels right. Yeah, under consideration is under that. Yeah.
Yeah. So it's not quite in development, but it is something they're considering. I know for me personally, I think the one that I would recommend is I did a video on it a couple weeks ago, which is the Agents Navigation package, which is available on the Unity Asset Store.
Yeah,
I
think he used to be a Unity employee as well.
Let's take a look. Interesting. Okay.
I've heard, yeah. Yeah. No, I had a really great experience using that. It like really just feels like it is kind of like a native Unity package, to be honest. Like it just works really well. You can, it fits in with the existing navigation package. It works great with game objects and entities. So I was really happy with that one. So
that is really cool. And obviously there's also the classic approach, like going with an anime, like having a ghost game object once again, and then using the classic game object situation. Or there's also like a what's it called, navigation mesh query. We have a native API. It's very manual.
Oh yeah, nav mesh query or something. I tried to do that one for a while, and it was just like I was not getting very far.
It's a very manual process, but it is
very
one that is probably supported by us.
Yeah.
I would definitely recommend, like for ease of use, just to get really good at the very situation. Or there's also like a what's it called, navigation mesh query. We have a native API. It's very manual.
Oh yeah, nav mesh query or something. I tried to do that one for a while, and it was just like I was not getting very far.
It's a very manual process, but it is
very
one that is probably supported by us.
Yeah.
I would definitely recommend, like for ease of use, just to get really good at that ghost approach. Because that's like a common theme. Like how do you want animation to work? Well, you gotta have some syncing.
Yeah.
And then you want UI to work, you have something.
Yeah, or even feel free to go ahead and try and take a stab at implementing your own navigation pathfinding algorithms, because with the performance of the job system, burst compiler, and all that, you definitely can get some pretty good results from it. Maybe doing something manually can be a good exercise, and you can also get something really high performant and specific to your needs.
I think we're gonna have to do something manually.
So that definitely is an option as well.
And maybe one can just try to implement, like if they don't feel like generating the entire nav mesh themselves, they can make a simplified thing on top of the nav mesh query, or they can take what's the one we call? We actually underneath use a public one. It's like if you search nav mesh, there's a high chance that you will find a C++ thing that is a generator of nav meshes. And
interesting. It's just like an open source repository, basically.
Exactly.
Cool.
And similarly, you could, because of Burst, also just try to implement that.
Yeah. Good point.
Because Burst is directly able to call native C functions. No plus.
Okay, so we don't have nav mesh. So that kind of sucks. Path finding algorithms. Yeah, A-star is one of the best, but I don't know if that's going to be necessarily the one that I go for. It probably will be. But yeah, like, so, okay, so I was
All right, moving on. AI navigation for entities. I know that is one thing.
Yeah,
I
I think he used to be a Unity employee as well.
I've heard,
Totally
yeah.
data assets,
Yeah. No, I had a really great experience using that. It like really just feels like it is kind of like a native Unity package, to be honest. Like it just works really well. You can, it fits in with the, existing.
He's saying scary words. It works like a Unity native package. So buggy.
Navigation package. It works great with game objects and entities, so I was really happy with that one. So
that is really cool. And obviously, there's also the classic approach of like going with
Buggy and half baked. That's what that means, right? That's
and then like having a ghost game object once again, and then using the classic game object situation. Or there's also like a what's it called? Navigation mesh query. We have a native API. It's very manual.
oh yeah, nav mesh query or something.
this is literally what I mean, right? Like this type of stuff just annoys the fuck out of me. Right? Like there should be something, right? Like you're removing functionality. If I go back to 23, no. If I go to 2. Yeah. Okay. Well, at least it's experimental. Okay, never mind. I take that back. They don't they've explicitly stated that it may or may not get be maintained. Okay, never mind. Was the main reason I went with Unreal till I got overloaded with the gas stuff. Gas is a lot to deal with, especially when you're new. You also don't, unless you're making a multiplayer game, you don't need it. Okay, so there's no nav mesh, right? So we're gonna have to do, yeah, this is gonna be interesting. I'll be right back. I just wanted the ability system. I completely agree with you. The ability system is amazing. Some pain in the ass to implement. I did it. I've done it. I have actually implemented the ability system. Let's see. I implemented the ability system for this. So this game currently has the ability system. I wouldn't worry too much about it. So we're gonna have to implement. Okay. So what I'm gonna do is I'm gonna implement my own pathfinding. You loved that game? Oh, you loved Future Cop? Here. Oh wait. I should do this. I should do this for everybody. Yeah. Yeah. I'm just gonna do this. I have a bunch of games. I got this one. I've not played all of these, right? I got Legend of Mana. Digimon World. I am actually looking. I've been on the hunt for a copy of Crazy Taxi for the Dreamcast. Got this bad boy. This one's interesting looking. Fast and the Furious, effectively Tokyo Drift. Simpsons Hit and Run. Yeah, those are new games. No, I only have those ones. So there's RetroArch, right? If you grab RetroArch, it's free. You can install different emulators, right? Oh wait, I'm not on the right one here. And then if you have something that will read the media, you can just play it directly in a RetroArch from a CD, right? So I have looked for, but I've not found it for a reasonable price. Crazy Taxi Dreamcast. It's really expensive. It's not actually available on there, but Dreamcast. Here, this has it. That's actually not that expensive. Nice. Cheaper than I was expecting. I thought last time I looked at it, it was really expensive. That's my bad then. But yeah, I wanted to pick it up because a lot of people are like, oh, you know, your game is very reminiscent of it. Yeah. But I also do have it. It just doesn't have all of the extras with it. What's this? Is this the Japanese release? This is the Japanese release. Fucking great. When I go back to Japan, I'm going to take a look, see if I can find it. Don't know. I don't actually play a whole lot of racing games. So I'm not sure that the A-star algorithm is going to be right for the game. Just because the A-star algorithm is more like actually no, it might work. The problem is that we're not necessarily looking for the most efficient path. I kind of here. It'd probably be easier if I just did this. Don't save. So effectively, like what we want is, right? We have a city block, right? And the city block might look like this, and this will be, right, the sidewalk, and then let's say that this is the road. Right? And then in the road, maybe we'll have like a crosswalk here. Right? And then we'll have this section here, which is you can't go into, which is going to be effectively buildings, right? Okay. And then effectively what we've got is we've got our one player, right? Our NPC, and they're going to walk from there to this point of interest, right? And then they'll just, once they get there or once they're close, they'll decide on their next point of interest, and their next point of interest could be here or here, right? So like this could be the next point of interest here, or it could be here. Yeah, effectively pre-made paths, but like you can't reasonably make pre-made paths for everything. So you mean like if I draw this out, like we've got our here's our sidewalk, right? Effectively, we have a lane, another lane, another lane, another lane, another lane, maybe another lane. Right, so 1, 2, 3, 4, 5, 6. So if we've got 6 people. And this person could be going this way. And this person could be going this way. Maybe we have another person right here going this way. And then when these two get close to each other, one of them's going to have to switch over here. Maybe this guy will have to switch over here. Yeah, that's probably how I'm going to do it. Because that mimics how the roads are going to be. Yeah, pretty much. Everybody just uses car pathing. But there's one more thing that I'll need to do. Right? And so we might have a sidewalk that goes like this. So this would be red. Like that, right? And then here we've got walkable, right? These would be like our little paths. And then we'll have sections, right? Like this. That will be for people like standing around and stuff like that, just walking or standing or chatting and chit-chatting and whatnot. So like if we go into here, right? We look at this. This is a train station entrance. It's not correct, but it's a train station entrance. Like this here is a train station entrance. So the walkable path is right here, right? And here is walkable too, right? But all of this needs to have people in it. But those people don't necessarily need to be moving. Some of them might be moving. They might be walking. They might come along here and then come into say like here, or they might come along here and go over to here, or take a look at the statue, and then walk over here and go down here, or walk into one of these, walk into the stores or whatever like that, right? Or like they might come over here, chat with somebody, and then come over to here, right? So they'll have different states of like loitering and stuff like that. And these areas here, A star makes the most sense for that. And there's not a ton of those where it's like we need a lot of people loitering. Right? Like certain points of interest you'll need it. Like right here we'll have probably a little bit of loitering. Very small section. But they don't like I think what I described is more advanced than what is actually required. God damn it, I think I'm having an allergy attack. Like what I imagine will happen is that I'll probably have like a couple lines that go like this, or like go around here. I don't know. But also, I want to know how this gets generated. Houdini to Unity pathing. What's up, Fox? Yeah. Okay, so let's start with the most important thing.
By making our authoring component to store some data, so a new model behavior script called the zombie spawner authoring. Then over here, let's write our normal code. So we have our zombie spawner. It's going to be I component data, and then let's make the standard Baker class. So Baker, let's bake zombie spawner.
All right, I'm gonna move this off screen for now because we're gonna go pretty quick here. Yeah. Okay, so we come over to here. This would be there we go. If it's not too buggy, Unity has a spline package now with 6. Now in 6. Neat. Using Unity engine. This gives us a mono behavior. Oh, I imported editor. That's why.
authoring, so not the zombie. Okay, this one. And over here, same thing as always. Entity, get entity. Let's get a dynamic entity and add component onto this entity, a new zombie spawner. Okay, great. So now let's think, okay, what data do we need over here?
Public override. There we go.
The goal is to spawn a zombie and spawn a zombie every certain amount of time. So let's store a float for a timer, another one for a timer max. And on the baker, on the authoring class, over here, let's expose the timer max. And when constructing the zombie spawner, let's set
Public float timer. Public. I don't think that's what I want. I want timer max. Yeah. I
empty a new zombie spawner. Okay, great. So now let's think, okay, what data do we need over here? The goal is to spawn a zombie and spawn a zombie every certain amount of time. So let's store a float for a timer, another one for a timer max. And on the baker, on the authoring class, over here, let's expose the timer max. And when constructing the zombie spawner, let's set that one. So timer max, authoring.timer max. Okay, just like this, let's save. And over here, let's make an empty. So inside the empty subscene, create a new empty game object for the zombie spawner. And over here in the world, let's place it over there on that corner. Okay, great. Then let's attach a component. So let's put the inspector back into authoring mode, add the zombie spawner authoring, and let's put the timer at something like 1.5. So we want to spawn one zombie every 1.5 seconds.
that's what I thought. Yeah.
Okay, that's that. Now let's make the system to run this. So in our systems folder, let's go ahead, create a new entity size system called the zombie spawner system. And now here, let's first get rid of these. We just need the on update. So let's do our on update. And now let's do system API query. And for handling this logic, first we need to have the local transform so we know where to spawn zombies. Let's do ref ro local transform. Okay. And then we're going to need our ref rw for the zombie spawner. Okay, that should do it. So let's put this inside a for each. For each, our ref ro local transform, call it local transform. And then ref rw for the zombie spawner, call it zombie spawner. Okay, like this, let's just format everything. Ref ro, ref rw. Okay, yep, here's our query. Now first, let's do the usual thing. So count on the timer and reset. So let's go inside the zombie spawner, grab the value rw, and grab the timer, count it down by system API.time.time. And then let's check the zombie spawner value. Let's just read the timer. And if the timer is above 0, if so, then the timer is not yet on left, so let's skip it. Let's continue. But if not, then let's run this code, go into the value rw, and reset the timer. So set the timer back into the zombie spawner. Let's read the timer max. Okay, so this handles the time logic. And then over here, we just want to spawn our zombie. So for doing this, it's pretty simple. We're just going to do the exact same thing we did for the bullet. So in order to get the reference, let's go here onto the entities references author.
Okay. Okay. Okay, so oh, I missed some stuff here. Okay, so this is it. Yeah, okay, so this is it. We save and we build. And then we come back into here and we're going to add it to one of these. You're just going to add it to this one. And I'm just going to go like this. There we go. Beautiful. And we're going to go to here and we're going to add a pedestrian. Add the pedestrian spawner to it, and then the spawn interval will be 1, and then the max pedestrians will be 1,000. Then we need a lot more. Then we'll need to we'll have to have a moving component, right? So I think maybe I'm getting ahead of myself. So let's create a new prefab. Empty object. Test. How do I get a mesh cube into there? Oh, there's a human? You're perfect. Yeah, I think so. Okay, there's this is my test pedestrian for now. Then we need create a um, random move authoring. Then we need to go to systems. Oh, that's why. Still a problem. Huh. None of these are good. I hate it. Okay, that works. But the pedestrian itself does not have the correct thing. This is not right. I don't think. Yeah, it's not. Damn it. So how do I make that correct? Can I jump to it? Man, it sucks that this doesn't work properly. Click the name of the material. One sec. Oh, there it is. So if I duplicate this, can I duplicate this? Yeah, okay. So if I go like this, and I go universal pipeline, just do lit. And then we go to this mesh and I swap it out. Then I move her into here. I don't think I get an error. Yeah, I don't think I got an error. Yeah, there we go. Now if I go like this and we select that, there we go. it's all there. Interesting. Anyways, she works. I'm learning. Okay, so now we need our move system. Oh yeah, this is our random move. Float. Walk speed. Maybe? No, I think it's just that, right? And then we go to the systems and it's this. All right.
Max, and when constructing the zombie spawner, let's set down. So timer max, authoring.timer max. Okay, just like this, let's save. And over here, let's make an empty. So inside the empty subscene, create a new empty game object for the zombie spawner. And over here in the world, let's place it over there on that corner. Okay, great. Then let's attach the components. Let's put the inspector back into authoring mode, add the zombie spawner authoring, and let's put the timer at something like 1.5. So we want to spawn one zombie every 1.5 seconds. Okay, that's the data. Now let's make the system to run this. So in our systems folder, let's go ahead, create a new entity size system called the zombie spawner system. And now here, let's first get rid of these. We just need the on update. So let's do our on update. And now let's do system API.
Yeah, I'm just gonna refresh this.
Was ones that we just installed. Again, like I said, part of the reason why it does not show up over here in the inspector. However, if instead of making an entity, let's make this a type game object called the visual game object. If we do this, yep, no, it does show up a normal game object field. So now we can assign it. And again, make sure you're working inside the prefab. So let's open, go inside the prefab. And over here, now we can just click and drag the select game object. And yep, that works. Let's save, let's go back outside. Okay. So now we do have this field assigned with the correct reference. And now the question becomes, how do we convert a game object onto an entity? And once again, thankfully, because of the baking system, the answer is super simple. We just use literally the exact same get entity function. So over here, when constructing the selected, let's assign that one. So we're going to want to assign the Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to dynamically generate some move positions so our units don't all try to go to the exact same spot. Okay, so right now we have units that we can control. I can click the select an individual one, select a group, and all of it works. However, right now, all the units, those are all trying to go to the exact same position, which leads to all this piling up. And let's also keep track of which position index we are trying to assign. That, and then for the second ring, we will just use a bigger vector, just going a little bit bigger, and same thing, we still rotate and so on. Okay, that's the rough logic. Now let's implement it. So over here on the unit selection manager script, let's make a function to generate our positions. So let's write private, and for the return type, technically we could return a normal vector3 array. We could return this, that would work. But instead, let's actually return a native array, make it a native array of float threes. Again, native array, that is a native collection that works with dots and bursts. So let's make this one and call it generate move position array. Then for the parameters, so first we need to know the target position, so float3 for the target position, and then we're also going to need to know how many positions we want to generate, so an int for the position count. Okay, sounds good. So now here the first thing we do is create the array with this size. So native array of type float3, that's going to be our position array. Let's construct a brand new one. Let's use allocated.temp, make it temporary, and for the size, let's define with the size of position count. Okay, yep, just like this. Then we can simply test if we are requesting 0 position. So if position count equals 0, if so, then we don't really generate anything. So let's just return the position array. If not, then let's keep going. So if we're generating at least one position, then the very first position on the array, so on index 0, this one is going to be the target position. We always want to make sure that we want to use that position. And then let's do another if. So if the position count, if it is 1, then this one is really all we need. So let's return the position array. Okay. If not, then let's finally generate all the others. So first let's define some settings. So we basically need to define the ring size. So how far away is each ring from the origin? So let's find a float for the ring size, and let's use a number like 2.2. Okay. Then we also need to keep track of which ring we are currently generating. So let's define a ring int for 0. And let's also keep track of which position index we are trying to assign. Now since we already assigned the origin over there on index 0, let's start with the position index and start off as 1. Okay, great. So now here we're going to run our generation logic while the position index, while that one is under the total position count. So basically keep generating until we have all of them. So that makes it perfect to use a while. So while the position index, while that one is under the position count, while doing that, then we're going to generate a bunch of positions. So it's over here that we want to cycle through all the rings and calculate all the positions. First thing we should define here is how many positions we're going to have for this ring. As the ring expands, we can see it has more area. So as it expands, we want to have more positions. So we don't want to just be fixed. We don't want to have just 4 positions on every single ring. We want to have some kind of minimum and then some kind of bonus depending on the ring. So let's define an int for the ring position count. Is how many positions we want to have in this ring. Let's define a minimum of something like 3, and then add, let's say, ring times 2. So on the first ring, on ring of 0, we are only going to have 3 positions. Then on the second ring, ring of 1, it's going to have 3 plus 2. On the next ring, it is going to have 3 plus 4, and so on. Okay, so now that we know how many positions we want to generate for this ring, let's actually go through them. So let's cycle through all those positions. Let's use a simple for. So in I starting on 0, while I is under the ring position count, I plus plus. Okay, cycling through all the ring positions. And now here, like I said, we're going to have a vector. We're going to start with the vector pointing in some direction and just get the vector. Then take that and basically take once again by 2. This one is the entire ring. For the size of this vector is 0, then it's just by the ring vector. Applies that rotation on a top down, so we want to rotate on the y angle and rotate by this angle and use this quaternion and that vector. Okay, so yep, so this is the ring vector and we just apply that.
It's not quite what we want. We can't do a move 2, right? is we don't have a nav mesh, so we can't be, hey, move to this point, can we? Unity move lerp. Unity move to a set, move object to position. Move towards. Let's go back to this, and it was the physics stuff, right?
Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to write our first system to make our unit move. This requires us to learn how to do it. And let's open. By the way, personally, as a rule, I like to append system to the name of my systems. You don't have to file to find another part. The way Dots works is very much based on source generation, meaning you write some code, but then the system auto-generates a ton more code in the background to make everything work. System base. Now, the difference between these two is system base is meant for managed systems, and iSystem is meant for unmanaged. Or put another way, iSystem is meant for structs, and system base is a class. Now, in general, you should prefer iSystem. As here we have our system, and as you can see, we have, in terms of lifecycle for systems, by default, it all. So super. Be right inside of here, all this is going to run for every single entity that matches this query. However, it's not actually like this. This code will not actually run properly. Once again, it's due to how structs work. They are value types, meaning they work as copies. So you just plug into it. So now you might be asking, why would you ever limit yourself to read only if you can read and write? And the answer is this will actually become super important later on when we work with the job system. Because right now this code have two nice properties. We have the value RO and the value RW. Again, same thing, read only or read. Add a new flow3 onto it. And by the way, flow3, this is a special type that is part of the unity.mathematics library. So let's go up here and using unity.mathematics. And over here, we can find a new flow3. This mathematics library is what I mentioned a while ago on how it's super fast and specifically designed for dots and bursts all the time. However, again, here our code is done. So we have a for each doing a query on everything that has a local transform. And this code inside of here is going to run on every single entity that has a local transform component. It's going to grab that one and set it to basically the same thing, moving right by 1 unit. Okay, so let's go ahead and save and let's test. So hit on play. And if right away it does work, there's the unit constantly moving right. All right, awesome. Except it's actually not entirely awesome. Are moving right. And dots, it's how systems do not care what our system is being applied to 3 onto the unit. This one only just had a comment and then another type. In this case, we want the move speed component. Again, importantly, it's a move speed, not move speed authoring. Nope, over here we're working the dots world, so we want the dots component and add the move speed component. Also for readability, I like to they need to have so on as since our unit is the only thing that has both these. I like my code to be as explicit as possible, so there are no questions. I want to and make it move at a speed of maybe 5. Okay, now let's hit on this lecture. We're going to the unit is constantly moving, so it has a component for the move speed. It has a make it rotate towards the move direction. So here we are in our unit mover system. Okay, we have the local transform, our move speed component. Okay, great. So in order to rotate towards that direction, first of all, let's actually calculate the move direction vector. So we have a float for a move direction vector. Actually, this is a float 3, which again is pretty much the equivalent of a vector 3.
Do I actually need physics? Is the, like, do I need to do this through physics?
It's just in the special mathematics library. So that one, first of all, requires the target position. So let's actually define it, as opposed to over here, we're just moving right, or actually just moving towards the move speed. So let's define a float 3 for the target position. This target position will eventually be an actual proper position, like for example, the mouse position or whatever position we tell the unit to go to. But for now, again, let's just make it move to the right. So target position, just go into local transform onto the value RO, just for reading. Let's grab the position and add a new float 3, and just go to the right by 10 units. Okay, so this is our target position and following direction, some super simple math. So just target minus the current position. So that's the local transform dot value, a bunch of big components down here. This one is using just normal game object physics. So that is why the cubes win. Hello and welcome. This component our movement direction.
Here we go. Move direction will be a, I want to get a random point. Get a random point within 100 units of the current position. This is local transform. Value dot might dot value read only dot dot position plus. Okay. So because we're on a flat plane, we can do what would it be? It would be maybe this one. One sec. Oops. Unity dots get random float value. Unity mathematics. Struct random. Random number generate based on XOR shift. Designed for minimal state, 32-bit. To be easily embedded into components. Core functionality is integer multiplication free to improve vectorization and less compatible heads. I want to say that this is it, right? Because the Unity mathematics is the what we want, right? Yeah, but I need to get I can come back to that. That's not really the problem. What I'm looking for is I need a random point, right? So I need a random number. But I need a random number that's going to work inside of dots. I think Unity mathematics does Unity work inside of dots. Okay, so struct random. So we would do Unity dot mathematics dot random. What's this return again? Unity dot mathematics dot random. And then we give it a seed, which doesn't matter what the seed is. Oops. Oh, right. This is a random, new random. There. Then this gives us a seed, right? And then from here we can do, what is the next float? This should give me a float back, right? Next float 3. Dot y is up, right? We just do that, and then we can just do Oh, I see why I was getting errors. God damn it. This would be new float 3, and this would be uh new rand There we go. Then if I take that, let's take this here. Then we do the move speed. We say 10. I think it should start moving, right? Randomly. Is it the ground? No. This one? Mhm. Wait, what's going on now? So it's falling, but it's not moving. Hmm? What? Wait. No, this is a system. moving a rigid body by its transform doesn't work well. Oh yeah, that's what it was. It's my bad. We wanted to do it using the transform. The
manually just set the inward velocity into 0. So we can just go inside flow 3 and access flow 3.0. Okay, yep, just like this, it should work. So
do target position minus location transform RW. This gives us our location. Yeah, that's fine. Then we do local no, it's value RW. Right, we're not passing in the physics velocity. Ref RW physics velocity. Dot linear, yeah, there, and then physics velocity dot angular. This should be working. Hey, please stop going out. Interesting, interesting. I think it's always moving in the same direction. Okay, so that works for now. We've got that working. Now what we want to do is
Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to create a job and use burst so our movement code is insanely fast. We're going to look at the result before and after to see the really massive difference that it makes. Okay, so here we have our unit. I can right-click and tell it to go to some position. So yep, everything does work. And here we have our unit mover system. So all of our logic is over here on update. We're doing a simple for each cycling through the query, meaning that all of this code, all of this is running just on the main thread. So for example, if we have a CPU with 16 cores, then 15 of them are going to be completely idle, doing nothing, just wasting time. Only one of them is actually going to be working. Ideally, we don't want that. Ideally, we want all the cores in the entire CPU to be doing some work, so our game is as performant as possible. Now, in order to write multi-thread code, we could use normal C# code. We could manually create threads and give them tasks. But like I said on the lecture on what is not, writing good native multi-thread code is extremely difficult, and it is very easy to make all kinds of mistakes. So thankfully, Unity has created the job system, which makes that process much, much easier. So let's see, how do we create a job? Now, first thing we do is define a struct, and we can define it anywhere, but it makes sense to define it next to the system where we're going to use the job. So here on the exact same file, let's define it. Although if this were a job that would be used in multiple places, then we would probably define it in a proper file. But this unit mover job, this will only be used over here by unit mover system, so it makes perfect sense to define it right here. Okay, so let's define a struct. So that's the first thing. Then jobs are also
Get back to this. We're going to need a job.
going to have some source generation, so let's make sure to define it as a partial struct. Then we use a name. Let's call it unit mover job. Personally, I like to append job to the name, but again, not a requirement. And now finally, we implement an iJob interface. Now you can just write iJob and you can see all kinds of interfaces you have. These are all going to run slightly different. Remember how I said that all the components that make up dots do not have to be used together all at once. So you can write multi-thread code with the job system without using entities at all. In those scenarios when not using entities, when just doing some random normal multi-thread code, for that you'd use either iJob or iJob4. Those are the two main ones. But when working with entities, for that we have the super useful iJob entity. This one is going to be really easy to use. Technically, we also have iJob chunk. This one is also related to entities, but this one is for more advanced use cases. It is more performant, but requires you to do a little bit more setup. Whereas the iJob entity, this one runs super fast and is really easy to use. So let's use this one, iJob entity. Let's go ahead. Now for this work, we really just need to write a void execute function. So just like this, and on this function, on the parameters, over here we include whatever components we're going to need. So let's copy exactly the same query that we have up here. So we need the local transform, the unit mover, and the physics velocity. So let's add those. So local transform. Then we have the unit mover, and finally the physics velocity. Okay, that's our three components.
Local transform. Unit mover. Oh, yeah. Yeah, and physics velocity.
Components. And out here we also need the same thing that we define up here. We need to define them as either read, write, or read only. However, down here on the job, this one uses a different syntax. Although actually, technically, you can use the same syntax, so you can use refrw. Technically, you can use this, but the Unity docs, they recommend something a little bit similar. So instead of using that, if we want to make something as read, write, for that, we write the ref keyword. This is the ref C# keyword. This one basically means that this field will be received as a reference. And since it is received as a reference, even though this is a struct, it means we can write to it. And then if we want something as read only, like for example, the unit mover, we only want to read this one. For that, we use the in keyword. So yep, ref for local transform, so we can modify it. In for the unit mover for read only. And for the velocity, we want to write to it, so let's make it as ref. Okay, yep, just like this. Again, technically, you can use refrw and refro and it won't work, but the docs recommend this syntax instead. So like this, we have defined our execute method. And basically, when we set the job to run, it will automatically create a query with all of these components. It will do all of that just like the system API up here, and we'll run the execute for each entity that matches that query. So now our goal here is to do literally the exact same logic. So let's just copy the same code. So just copy it down here, paste it. And the only difference over here, we don't have the refrw or refro, so we don't go through the value RO. Instead, we just modify directly. So just get rid of this, and this one. Okay, so yep, so here we have exactly the same code. And the other difference is what we see here, we have an error. And this is actually the general limitations that exist inside of jobs, meaning that jobs mostly have to be self-contained, meaning they cannot access data outside of it. Now, technically, you can pass in a array and then access different positions in memory and something like that. But
Target position.
But in general, jobs are self-contained, meaning they need to have all the data that they need in order to execute their function. Now, this limitation of jobs being mostly self-contained, this limitation is actually what helps write super fast multi-thread code without causing all kinds of chaos. If the job only works on data that the job has, then it's super easy to make it run parallel in multiple cores at once. So the error that we have here is because we cannot access the time.time from here. And the way we solve this is super simple. We basically just find a field on job. So here, let's just find a public float delta time. So just a perfectly normal field. And then down here, instead of going through system API, we just use that field. So that's it, no more errors. So now basically when we construct our job, we simply need to assign the delta time and everything will work perfectly. So let's actually do just that. So up here on the on update, let's construct a brand new job. So a unit mover job. Let's call it unit mover job and construct a brand new unit mover job. And now inside of it for delta time, over here we can need access system API .time. And so that's our job all set up. Let's make sure to
Oh, wait, but this is shared state. So we can't pass in the rand because it shares state, right? And because it shares state, everybody will get the same state. um, or because it will never update, right? So we need some system of figuring out a random number. Wait, when he does his thing, right? Is he dispatching to
comment out the other random query code. Okay, so up here.
No, he's not. He's not dispatching in a for loop.
We have defined our job. Now all we need to do is just run it. And we actually have multiple ways of doing that. Now the most straightforward one is go for the init mover job and just call run. Now this one will run the job directly on the main thread. So this kind of was the main point behind jobs. You should probably only use this one just for testing or debugging. Essentially this will end up pretty much the same thing as we had previously. The main goal of job is to make multi-thread code. So usually the one that you want to use is the one that's called schedule in parallel. This one will schedule the job to run on all the entities that match the query in parallel. Meaning if you have lots of entities, it will run the job on multiple threads at once, and each entity will be responsible for updating a few entities. Although quick note, just something to keep in mind, which is actually something that I only learned after doing a bunch of research. This one, schedule in parallel.
Locking destroys your performance. But it makes it safe.
This will split the logic in multiple jobs based on the number of entities. So this is real perfect if you have tons of entities doing some logic, but if you have just a handful of entities, so if you don't have many but you have a complex job, if so, they're likely all going to run on the same thread because you don't have enough entities to split it. So just keep that in mind, that's how the job system works. If you have some really super complex logic, but you're only running it on a handful of entities, if so, then this will basically run just on one thread. So in that case, you probably want to split the logic into multiple jobs yourself. Okay, so
Okay, can I get the job ID? Can I do this? Unity dots get job ID from within job. No. Oh, you know what? I know. Unity ID. Yeah. C#. Unity get max value of u int. Oh, int max value. Values don't work. Oh, min rand value. I wanted that, but random range doesn't provide that. So wait, is it? Is it just u int? It was because I had a u int. There we go. Then Why will it be ignored? Why is it going to be ignored? The parameter unit ID will be ignored. Why are you being ignored? Hmm. Oh, that's why. Is this right? Okay, so this needs to be a uint. And then we take this. There we go. This is not ideal. But we've solved a problem. We've solved a freaking problem. Mm-hmm. Now, what we'd want to do is we would want to do something like float or something like that, like a uint float. The uint float something, right? Like probably another uint, and then we'd be like time, like random number here to add to uint or to seed, right? That way, because right here, we're always going to have the same random number. So if we need any level of randomness, there we go. And then we would go. We could, yeah, here, like this could be delta time, but I'm not going to do it. Give me a second and I'll take a look at that. Let me just get this initially set up here. Sorry,
Hey, this is so random, but you should really learn how to properly generate random values in Unity's entity component system. And that is exactly what I'm going to be showing you in today's video. Today we're going to be going over how to use the Unity's random struct, which is part of the unity.mathematics library, and we can use it to generate random values in Unity's entity component system. It's a really cool and easy way to generate random numbers. There's some nice features on it, but there are some pitfalls that you need to be aware of, so we're going to be going over that today. Basically going to be going over how it works. I'm going to be showing you how to actually implement it. I'm going to be showing you some of the incorrect things that you might do when you're
yes.
implementing it and how to avoid those. And if you stick through all the way to the end, I'm going to give you a little bonus tip that's going to show you how to use some nice clean code principles in Unity's entity component system. So make sure you stay tuned for that. Anyways, if you find today's video helpful, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system and their data-oriented technology stack. Of course, if you
Also, sup Don.
have any questions for me or suggestions for future videos, you can always leave those down in the comment section below, or join us over on Discord. We got a nice community of ECS developers over there. Just go to tmg.dev/discord. I'll see you there. So this random type works very similar to many other random types in computer programming, where we basically initialize it with a seed value. Now, when we initialize with a seed value, basically anytime we ask for a new random number, it's going to return a predictable result of random numbers. So let's say we want to generate a random integer between 1 and 100, and then we pass in a seed value of 5 to our random struct. So when we want to request a new random value, then we're going to get the same results every time we run our application. So let's say when we request it the first time, we'll get a value of 88, then we request a new number, and then maybe we get 72, we'll request a new number, and then we'll get 14. Now let's say we close our application, go ahead and run it again. If we initialize the struct with the same seed value of 5, then again, we're going to get the numbers 88, 72, 14 when we request those new random numbers. However, if we're to initialize it with a different seed value, let's say a seed value of 11, maybe we'd ask for a number between 1 and 100, and then we'd get 36, 84, 26. And so that's basically all there is to this random class as far as the basic interactions go for it.
This is correct.
You just initialize it with a seed value, and then when you want to request a new value, you basically just call next and then data type. So if we say we wanted an integer, we would say our random.nextInt, and then every time we call that next int, it's going to return a random integer. So I should mention that there are all sorts of other different things that we can randomize. We can get random integers, doubles, floats, booleans, quaternion rotations, and a lot of these can actually be defined with a minimum and maximum value. So if we actually don't put anything in, then there's kind of like a default range. It's usually between 0 and 1. For some things like integers, it's actually between the minimum value and the maximum value. And then we can actually sometimes pass in one parameter where basically just gives us a random value between 0 and then using that parameter as the max value. And then we can actually pass in two parameters so then we can get a random value between the minimum and the maximum. And if you do want to know a little bit more about how it works behind the scenes, it uses an XOR shift, not an exorcist, but an XOR shift, as in an exclusive OR shift, which is basically a way to kind of scramble the bits around in order to produce a new random value. And when we actually initialize the random struct with a seed value, it's going to generate behind the scenes what is known as a state value, which is an unsigned integer, and then based off of that state value is what we use to calculate the different values between our defined range. And each time a new random value is requested, a new state value is generated. Okay, so the random type that we use in ECS, like I said, it's part of the unity.mathematics library, and it's a struct, so we can easily drop this on any data component that we want. And that's actually the preferred method of using the random struct in ECS, is actually giving any data component that we want to basically randomize any values on, give it its own instance of the Unity random struct, and then we're going to be using that instance to generate random values. And when we get into the kind of tutorial section, I'll show you some of the pitfalls about using maybe one central random thing. But basically the idea is when we kind of jobify things and start multi-threading, when we request a new random value, it doesn't actually write back the random value to the original basically instance of that struct. So what actually ends up happening is we get our initial randomized value, but then nothing randomized after that. We keep asking for new random values, and we just get the same random value returned every time. Now we can run this on the main thread without the burst compiler, and that works just fine. However, that's not necessarily ideal, especially if we're trying to randomize a whole bunch of things in Unity ECS. Okay, so moving over into the Unity setup, basically again, I'm going to show you kind of the incorrect way to do this real quickly. So this is where we have kind of like a central random controller. So you can see here that I've set up this just real simple game object with the convert entity script on it. It also has this central random data authoring script, and you can see what this central random data authoring script looks like. We just have a public random called value, and you'll see up at the top I have this using random equals the unity.mathematics.random. The reason we do this is because there's like 7 different random libraries that we could be using, so we want to specify that we're using the unity.mathematics.random. So in this example, the red capsules are going to be the ones that are getting their values, their random values from that central random controller. You can see basically all they have is this convert.
Why don't I publish my VODs? I do. You mean to YouTube? They're all there. Twitch isn't. Wait, what? Why is it not saving them? It's supposed to be saving them. When did that change? Wait, stream settings? Oh, okay, so I have them. They're just not published. Oh, so good. There we go.
Convert to entity script on there, as well as a central random tag on here, just so we can filter out by that specific tag. All right, so real quick, this is the incorrect method of doing this, so don't pay attention to it too much. But in the onStartRunning function, we're basically just going to go ahead and get that singleton for the central random data. We're going to initialize it with a seed value of 10. I'll go into a little more detail when I show you the correct way to implement this. We're just going to go ahead and log that state value to the screen so we can see what it is. And then whenever we press the R value manager. Okay, so now for the correct way to do this, basically we're going to be doing this on the green capsules. So we have the individual random capsules, which each have an individual random data authoring on there. So you can see that each one of these capsules has its own random value on it. Of course, we can set the state here in the editor if we want to. However, we're going to be doing this all through code. And here's the data component here. As you see, we just have a public random value right here. We're going to be adding a little bit more things to it later. So then moving along to the actual individual random system, basically in the onStartRunning, first we're going to initialize the random seed. So basically we're just going to do an entities.forEach on anything with an individual random data, which we'll call random data. So then we can just do a random data.
Thank you to whoever just did that. Got somebody out there that keeps gifting random subs today.
data.value.init state, and then we can pass in any value that we want, say 120. And then you'll see that in the onUpdate, we're basically doing the same thing. When I hit the I key, I'm just going to manipulate the X value of the translation component, again, to a random value between 0 and 25, and we're going to schedule it parallelly. So go ahead and enter play mode, and you'll see when I hit the I key, you'll see that the capsules move to a random location, and when I press the I key again, you see that every time that I press them, they're moving to a new random location. However, you're seeing that they're all moving to the same random location, and that's because that we're basically setting them all up with the same seed, which is not exactly what we want. We want this to be a little more random, so there is a way that we can actually
Individual random seed system base system. Oh, interesting. So this requires a system base.
implement a unique seed for each of these, and that's by using the entity index. So in order to do that in our entities.forEach function, basically the only way that we can get to it is if we first define the entity E, and then we do an int, and then we actually have to name it specifically entity in query index with all that capitalization like that. And then what we can do is inside here, we can pass in the entity in query index, and then we actually have to cast this to an unsigned integer, and then we will move back over to Unity, and then if we hit the play mode, you see that we actually end up getting an error. It says that there's an invalid state of 0. I might have mentioned it before, but we actually cannot have a state value of 0. We need to initialize it to a non-zero number. However, when we basically get to the entity query index, obviously the first entity in the list is going to be at index 0, so we can't actually use the init state if we're using the entity's index. So what we can do instead is we do random data.value, and we'll set this equal to random.createFromIndex. So this is a static function built onto the random struct, and then in here, we can pass in the entity in query index, and again, we do need to cast this to a uint for unsigned integer. Now, we can come back over to Unity and enter play mode, and now when we hit the I key, you'll see that everything is just randomly moving all over the place, which is exactly what we want it to do every time I hit the I key. And of course, we can randomize more things than just the translation. Maybe if we wanted to, say, randomize the rotation, we could do a ref to the rotation. Just call it ROT, and we'll say ROT.value is equal to randomData.value next quaternion rotation. It's just built right in right there. We actually don't need to put any parameters in there. If we come back over to Unity and hit the I key, and you'll see that they're now randomizing on position and rotation every time I hit the I key. So there's something cool and simple that you can do. And real quickly, I'm going to be showing you a good clean code principle that we can use in order to make it a little bit easier for us to get a good translation value. So for now, I'm just going to go ahead and remove this line. I'm actually going to come back over to the individual random data component here, and then you'll see that I've added in some public fields for minimum position and maximum position, and I've added in a new property called next position. And I'm just using the
It's 3 years old. It seems so may need to look it up a bit. I think we'll be fine.
Expression body syntax here, and then we can just do value, which again is just a reference to this random value up here, and then on here I can just do a next float 3, passing in the minimum position and maximum position, and this will just return a random float 3. So when I
That does so that's actually solves my problem. Okay, so he was saying that individual. Wait, what?
I come over to the system, I can just say translation, the expression body syntax here, and then we can just do value. I'm going to be showing you a good clean code principle that we can use in order to make it a little bit easier for us to say now.
Okay, I want to start running. Yeah, okay. Wait. Is this my mover system? Give me a second here. Yeah, okay. Here. If we have this and we pair it with this, we should be good. But let's see here. Random create. Where are we getting the entity index from? One sec. This would be you. Oh, we can prep them. Okay, that makes sense. So in this job doesn't have to take nothing. Right? We can do a for each inside of this job. This would be no. Okay, we're definitely missing something. This is effectively what he's got here is exactly what I wanted to do. Right? But you said this is 3. Okay. Unity ECS random data. There's a random value. Public class. System base. Oh yeah, because we're using what? We're using iSystem, not system base. So maybe it's a bit of a change between iSystem and system base. Also, this does not exist in 6. Wait, what? This should exist. Where is the Unity 6 API docs? Okay, and this was what? This is so bad. Ugh. Hey, let's go back. We're gonna go back until we get to the one in question here. System base, here we go. I don't know what's going on here. Cause like none of this should be. Or I guess maybe, I don't know, like maybe there isn't an update yet for, I don't know. It's weird. All right. I think I'm gonna call it here and come back to this tomorrow. Is it running an ad? It's running an ad, isn't it? All right, I'm gonna call it a night here, and I will catch you all tomorrow. I've got some stuff I got to get worked through, and it's been 8 hours, so ta-ta for now.